Welcome at the main conference day of Ethical Hacking Conference. Today we will travel a little bit around the world as we host speakers from 11 countries, from Europe and also United States. So before we begin, I would also like to thank you to Mrs. Alenka Brezaušček, our moderator, who will guide you through today's program. So as our first speaker is already with us, I would like to announce Mr. Klaus Agnoletti to introduce himself shortly and then continue with his topic. Klaus, welcome.
Yeah, well, thank you. I hope you can still see my screen and all that.
Yes, we see you and screen. You need to share it again, please.
Okay. Hang on. Where do I do that thing? Oh.
This green button below.
Yeah, but you know that. Oh yeah, because it turned small in the corner of my screen and I couldn't really do anything. But
yes, we see it now. Perfect.
All right, great.
So the floor is yours. Thanks.
Yes, thank you. Yeah, well, welcome to my talk about implementing AppSec using common sense. My name is Klaus Agnoletti, and this is what we're talking about today. First, we're talking about why should we care about application security. I'll talk a bit about OWASP and OWASP Top 10, SDLC and AppSec, so software development lifecycle, and how that hooks into application security. Then I'll come up with some suggestions about how to implement application security or AppSec. I'll wrap it all up, and then we'll have questions in the end. Please have in mind that this is a slightly shortened version of my talk. I would usually spend a little bit more time. So instead, there is a recording of a talk I did last night here in OWASP Dublin. I'm in Dublin right now. Usually I'm in Copenhagen, but not today. And you can download it by scanning the QR code in one of my last slides. So and there I will have time to elaborate on some of the stuff that I have to skip over a little bit in this talk, just so you know it. Yep, and you'll also be able to download the slides. There's a QR code for that as well. Right, so here we begin. Before we start, the best thing that happened in my professional career was the last 2 times I got fired. And why that's a good thing is because they gave me a chance to change my career into something that's better for me and grow freelance. Since I got an HD diagnosis 3 years ago, I realized that I have to change my career and make it into something that's better for me, since obviously I have special needs. And being freelance, that makes it possible. I used to be a freelance InfoSec. Sorry, I've been an InfoSec professional for almost 20 years. And I realized that what I liked most about my job was all the things that I did in my spare time. Because I've been arranging OWASP Copenhagen meetings for many years. I co-founded BSAS Copenhagen. And I've always loved all the community aspect of it, that's gathering people and helping them network and share information and learn new people and meet new people and have a good time around it. So I love the community. I love giving back to it, and I hope this is of use to you. I'll start out by talking to you a little bit about what 20 years of InfoSec experience has taught me. It has taught me that, well, you're working with humans. They're rational by definition. This means that people usually don't want to act on security before it's too late. We've all tried this as security professionals, so this is not specifically related to AppSec, but that's just a general thing. And sorry, but that's how it is. And also in terms of application security or AppSec, if you don't have any security at all, you shouldn't start with AppSec. That is like building a house without having the foundation. You should start with something general security, like syscontrols. I've linked to that here on the slide. Basically, syscontrols is like a number of controls in prioritized order to make you have good security bottoms up and very practical oriented. So I like using that. But we're not talking about that. We're talking about AppSec. It's important, obviously, otherwise I wouldn't be talking about it. And And if you're wondering about the image, I've turned to AI generating images as well. And this is the search term. This is the term "poo on a white cloud," because basically that's what it is in the cloud. Because with cloud computing, with AppSec and the code you're producing, that's literally the only place left to screw up. Because if you think about it, it makes sense that everywhere else in the stack being hosted on the cloud, there are like an operating system that has been tried by many people, tested by many people, and all bunch of other applications. And the only thing that you inject is the code that you produce yourself. So if you haven't done any security testing at all to it, then that is likely where hackers is going to attack you and find vulnerabilities and hack you. So also, don't forget about API security. You can, with an API, you can basically do the same thing as you can with the website. You can hack it in every imaginable way. It's just a little bit more discreet. It's easier to overlook, and it's a little bit cumbersome to find all the API security functions that you all the API functions that you need to test. But you need to. Anyway, the point is that should also be in scope whenever we're talking about web application security. Yeah. In terms of OWASP and OWASP Top 10, OWASP is a worldwide non-profit organization that started with focusing on web application security, and they have released a bunch of free tools to help you with that. They also do IoT security and mobile application security, but the most famous project OWASP has is probably the OWASP Top 10, which is the 10 most critical and widespread vulnerability around web security. It's been around since 2003. Categories and grouping has changed a little bit, but in the end, still many issues are still the same. It's the same. Many issues still has the same root cause. It's like it's injection, lack of encryption, no hardening or patching and stuff like that. Time permits only a very brief walkthrough. So instead, as I said, watch the recording for more elaboration, for a more elaborate version. I'll talk about top 3 here, and in reverse order. So number 3 here is injection. That's a classic. That has literally always been around. It's injecting all kinds of code into your website. Most infamous is probably SQL injection, where it's possible to add SQL injection to the database server running behind your web server because there is no input validation within your website. But you can, in theory, you can inject all sorts of code. Number 2 is cryptographic failures, where you fail to encrypt data and you use clear text data transmissions, weak cryptographic functions, or one of the really big sins you can do here is to implement your own cryptographic function. That's usually never ever a good idea. Always use what's built in, because it's really hard to do in a proper way. Number 1 is broken access control. It covers many kinds of errors. For instance, if you don't implement deny by default in your application, or ACLs are wrong, and much more. This is like a motivator. This is meant to be a motivator of all the things that can go wrong, and sort of inspire you to go into security. You can of course dig much more into all the top 10 and talk more about various examples of bad security and bad things that can go wrong. If you are worried and you want to implement, or you want to make a company focus more about security, the best way to do it is to talk to management on top level. But being a tech person and talking to management, it's very often hard because they speak a different language. So if you're doing this, you should think strategically and turn this into a communication assignment, because obviously management buy-in is essential. If they don't allocate money and time, then it's not going to happen. So you need documentation. I'll be talking about SAM a little bit later, which is a framework for documenting where you are with your application security. You should turn this into a language they understand, which is obviously financial risk, and also try to talk about what's important for your company. It's very common in security to talk about the CIA triad, confidentiality, integrity, and availability, and which of those are important to the company and how the vulnerabilities that you are specifically worried about will affect this and how much it will cost, because that is basically how you should talk to management about this. You shouldn't exaggerate, even though it may be hard not to, because if you are perceived as being exaggerated, then you are not being taken seriously. That being said, it can be healthy with a little bit of panic, but I guess that depends on a lot of things. I could talk just about how you should talk to management for 45 minutes, but obviously I won't. So yeah, just a few tips. Hands-on inspiration or things you could if you want to look more into details or know more about this, you should buy the book by Tanya Yanka called Alison Bob Learn Application Security. It's a very excellent book. And if you happen to meet Tanya at an InfoSec conference or anywhere else, please say hello to her, because she's generally one of the nicest people I've ever met in InfoSec. So support her and buy her book because it's good. How to get started with application security? If you want to, you should try to find out by determining your baseline and where you are with it. And the best way to do that, I think, is to use the OWASP SAM framework. SAM stands for Software Assurance Maturity Model, and it provides an effective and measurable way for all types of organizations to analyze and improve their software security posture. It's designed to be applied into an existing SDLC, and I'll talk a little bit about later about why that is a good idea. It also helps you prioritize your findings and how to and help creating some kind of mitigation plan so that you can improve your security in a realistic way. A common pitfall in all this is to use the OWASP top 10 as a checklist, because that's not what it is. That's not what it's meant to be. I guess that's the downside for having a very known OWASP project, because everybody knows OWASP top 10, I guess. But if you're trying to have some kind of checklist, it's not the top 10 you should use, because that's only meant as examples. Instead, you should use the OWASP ASVS. ASVS is Application Security Verification Standard, or OWASP Proactive Controls, a project which is basically what it is. Proactive controls you can implement before everything turns bad. But the problem with those, obviously, is that they are not so generally known as the top 10 project is. The goal with an AppSec program is to formalize your security, whatever you do security-wise. But because if you don't have an AppSec program at all, it doesn't mean that you don't do anything in regards to security. An AppSec program helps you to being able to document what you're doing, making sure that you are doing things the same way every time, all that stuff. And of course, the goal here is that all the software you create and maintain is secure, and the program formalizes all those activities. All of the things that I'll be mentioning, they are examples. They are not meant as mandatory list of activities. You should select the activities that make sense in your organization and implement them the way that it makes sense for you to do it. I'll also talk a little bit more about that later on. An important thing to remember is to have fun and experiment. Obviously, fun is not mandatory, but having fun always helps motivating. but the experimentation part is really the essential here. As a developer, you wouldn't want to develop without prototyping either. So it's all about experimenting and creating POCs and finding out what works for us, and then collecting feedback for that. Whenever you try something new, create feedback from your peers or people in the organization to find out how it works. Because if it doesn't work if what you're trying to do doesn't work for everybody involved, then it's not going to happen. It's as simple as that. So remember what I said in the beginning about communication. That is very underrated and very important to talk to people about that. People change management, also an essential part of communication, or communication is an essential part of people change management, because whenever people are involved, you should always think of the human side of things, and humans are involved in security. Actually, communication is a very important part of security. It's not just all about tech. It's often overlooked, and I simply don't understand, because that is a very big mistake. The thing with security and people is that, first of all, people don't want to change. They hate change in general. They just want to do what they've always done, because that's easiest. And if you want them to change, then they really need to understand why we are doing this. And what I've experienced in all my years in security is that when I start talking about security to people that aren't into security, then their eyes turn blank and they start immediately thinking about something else, and you don't have their attention. So whenever you're talking about security, you have to make it relevant to people, and think and make sure that when you're talking to them, they understand what this is about and why it's important to them. Because if they don't understand why you are doing this, then it's simply not going to happen. And that's just how it is with security, and how it is with everything that you want people to do. If you don't understand it, they're not going to do it. And that also means that when you are implementing things, changes within your organization, in terms of AppSec, you have to make it as easy as possible for people to do the right thing. You have to change the existing processes as little as possible, and basically do as much of the thing that they usually do, and then put a few application security activities into the procedure, so that people can recognize that this is what we usually do, but with a little modification. Yes, that was it, I think. In terms of application security and SDLC, the reason why we're using SDLC, by the way, SDLC stands for Software Development Lifecycle, or Assistance Development Lifecycle, both term is used. It's a very well-defined process, and it's also a common language to talk about software development and maintaining. AppSec, that's not very well defined, so that's why we're using using AppSec to hook into SDLC, so we can keep using SDLC as a common language here. Also, when you see all these phases of SDLC, what you should know is that in the beginning requirement design, it's much easier to change or to correct any security vulnerabilities there in the beginning rather than in the end. So shifting left, as it's called, to do things early on in the process, that also applies here. It gives you a better design, a better design in the security part of your application if you design it in from the beginning, and it's also, as I said, much cheaper to fix bugs in the requirement or design phase rather than after release, when it's maybe part of a bug bounty program where it will cost you like $100,000 or even more to pay out the bounty, and then it'll cost you to fix the flaw as well. So as early as possible, of course. If you don't have an SDLC, yeah, well, then you have other problems. You should turn to syscontrols, as I talked about earlier. In terms of DevOps and Agile, it's especially important to understand how the process within this works, because Agile is not very security minded at all. So understanding how your company work with agile development and putting a security angle on that, that's very, very important. And as I said before, all the suggestions I have with AppSec activities, they are only suggestions. Your mileage may, of course, vary. Requirements. This is the first phase of the SDLC. Security requirements. You have to make sure that you are designing the security for the right requirements. Important factors to remember is important factors to put into consideration is, does this application have any external access? Is it handling any personal data? Does it do anything sensitive, like money transferring? Risk activities, are they allowed, like uploading a PDF file or file? Is it important to business? If it's down, does it hurt? Right? Because basically, if there's no need for security, then you shouldn't spend too much time implementing anything. If nothing can go wrong, don't do anything. Or in the other way, or of course also the other way around. If it is really important, you should have a lot of security, and they should all of course try to mitigate whatever is important in this thing, is whether we're talking about confidentiality, integrity, or availability. Security user stories. If you do user stories, there should also be security user stories for like security situations such as cross-site scripting, brute force attacks, etc. And they should ensure that CIA is intact, so the critical business processes keep working. The design phase. This is really where we're talking about shifting left and trying to fix flaws before it's getting too expensive. Unfortunately, what 20 years of security has also taught me, security is often applied in the end, 5 minutes before release time. That is bad, because you can't do security properly. It will be too expensive, and everybody will hate you and hate security, and that's not good for anyone at all. But one of the first things you do here, and obviously also one of the very important things here, is threat modeling. Is very often overlooked in favor of functionality and deadlines. Basically, it's about thinking about all the things that can go wrong. You can call it even brainstorming. It's actually quite fun, and it's also fun to. It's a fun activity if you involve developers in this, and they're usually good at it. How far you should be depends very much on your maturity. But your maturity, it can be very simple, like what's the worst thing that could happen, or you can list a number of threats and rate them and mitigate one by one and all that stuff. It can really be a lot of things depending on your organization. Design review. There should at least be a peer review of your design. It can also be a third-party review, of course. Secure design principles applied. Those are basic designs like protect sensitive data, no secrets in the code, never trust user input, only use and trust server-side data, deny by default, authorize these requests, and many more. They are always they are all very important to have as ground security rules. In terms of code, as it turns out, that obviously it makes sense, but if you don't educate your developers in producing secure code, and you don't provide them with sufficient time and resources to do it, then it won't happen, right? It's as simple as that. When those things are in place, that you should implement controls and not before, because obviously security doesn't happen by itself. And in this phase, when you are educating developers, this is where you will find out who is particularly interested in this, and that's important, because those will be your ambassadors or your sort of your eyes and ears on the ground that can help you finding out what people think and also how what you should change in your program to maybe make things work better. In terms of policies, guidelines, and standards for development, they are important because they ensure high quality in the sense that the same problems are solved in the same way every time. And when you're producing these, developers should be included, because if it doesn't work for them, then it's not going to happen. And it also ensures that they buy in on this whole idea. It's much easier to it was harder to hate something that you have been a part of developing yourself and creating yourself. So always include always include developers in this, because obviously it has to work for people on the ground, people doing this every day. A code review, mentoring by peers, that's also a really good idea, that developers sort of review each other's code, because obviously it ensures that people learn from each other. And when you're doing this, you should mix and match differently, so that it's not always the same two person that are peer reviewing each other, so that everybody peer reviews everybody, so everybody learns from everybody. That's a really good idea. This could be done manually or using SaaS tools, which I will be discussing a little bit later. Testing, that is very tools driven. It should be automated when possible. There are different kinds of testing tools: SAS tools, linting, secret scanning. SAS is static application security testing. Linting is basically not necessarily errors, but those are tools for finding or to make sure that best practice are being used when using that specific programming language. And secret scannings, yeah, you don't want hard-coded passwords in your code and upload it to GitHub. That's a very bad idea. I can personally sign on that. So those are just basic things that can be automated. So do that if you can. DAST, that's the dynamic application security testing, also called a web application scanner. It's an automated tool that crawls a web app. It tests every parameter and simply bombards all form field everywhere data can be injected. It tries, and then if your application throws up, then something is obviously wrong. Software component analysis, also really important, especially in light of Log4j, that you should probably know by now. Log4j was this or is this framework for logging within Java that everybody seems to use, and the best thing about free and open source is that it's free, and also it's the worst thing about free and open. It's the worst thing with free and open source software, because you don't have to tell anyone that you've included it. So nobody knew where Log4j was used, so nobody had an overview of it, and thus that is one of the reasons why 6 months after Log4j came out last December, a vulnerability in VMware Horizon was found because hackers started exploiting it. This wasn't discovered by VMware themselves, and we'll probably see more Log4j, because Log4j is a gift that keeps on giving, and that's really cool in that sense, and also really bad. But if there's anything Log4j has told us, is that you should know what's in what your code is consisting of. This is also called an SBOM, a software bill of material for each application. So you need to have this. Luckily, this can be generated automatically, and you can have tools that can help you know which components you have and which are vulnerable and which you need to update. Security unit tests. A good example of this is that you add security activities to your existing procedures. For instance, when you're doing unit testing, that's usually for testing individual units or components. So typically unit tests, they need to be passed for developer to commit code. So, and they usually focus on functionality and are being run to ensure that the same correct thing is being done every time. But if you add a security aspect to it, it could be here that to test that the application fails gracefully every time bad input is received, so it's not possible to do remote code execution and give commands to your application when it's in an unstable state. That is how vulnerabilities occur. And penetration tests, that is really not a good idea to do in the beginning, unless, of course, you want to communicate that something is wrong. Usually, if you do this the right way, you should do penetration testing whenever you have implemented a lot of other controls. And one reason to do that is that it feels a little bit stupid to have somebody externally asking for a lot of money to tell you things that you already know. So say with all these application security activities that I've been talking about, you will be, if you implement them, almost doesn't matter how you do it, you will be picking a lot of the low-hanging fruits, so that the thing that's left is the hard part. For instance, one thing that penetration testers are usually good at, because it's a human, is to find flaws within the business logic, and that's what a human can do. A human can understand your application and try to find ways around that. Automatic testing, they're not good. Tools are not good at doing stuff like that, at least not yet. Also, penetration test is a very good means of communication. If you are showing your developers how their specific vulnerabilities in the code can be exploited by a pen tester, and show them face to face, that has a very, very, very good impact, and that makes people really remember and understand why it's important. So show and tell, that's a very good idea. In the release phase, we're talking about logging, monitoring, alerting, and incident response. They are all related, and they're related to your CM. And if you aren't doing alerting, then you can do incident response. Obviously, this really doesn't have anything to do with application security, but it's important nonetheless. Else you can't do incident response at all and find out what's happening within your application if something goes wrong. If you don't have any of these, then again, look to syscontrols. This is basic security that you should have implemented in any organization. WAF is also often a reverse proxy, but WAF is a web application firewall. It's the first layer of defense. RASP, and also web application firewall blocks requests on the layer 7 on the web layer, tries to find like SQL injections in the code or in user requests or something like that. An important thing to remember about security is that you should have more than one security control, so they supplement each other. So that means that if the WAF fails, then you also have security controls within your code to ensure everything goes well. RASP, runtime application security protection, it hooks into the application runtime and detects and mitigates threats as well, using rules or regular expression or AI or ML if it's fancy. Wrapping up, good security like orcs and onions, they have layers. And also, if you are wondering about the picture, this is also AI art. It's orc holding an onion in his hand, green like Shrek, Pixar style. But anyway, there are plenty of good reasons to focus on AppSec. Communicating with stakeholders is important, but also really, really hard. APIs, they shouldn't be forgotten, because obviously the attacker won't. Some gives a great overview. Don't forget the human side, and do what you can with automated tools. If you have any questions for me, I'm always there to help. Reach out to me on LinkedIn, on Twitter, on Mastodon, or throw me an email. I always have opinions. I also have career advice, whatever I can help you with. And by the way, I'm also a freelance consultant. I'm situated in Copenhagen, Denmark. So if you need any help with anything, please reach out. If you go to my LinkedIn profile, you will find some articles pinned there that talks about some more exotic stuff I do, like community marketing and stuff like that, where I try to combine my love and knowledge for the community with something that I can live off and which benefits the community as well. That's really, really exciting, I think. I don't have a website yet. I will soon, but we'll see. If you want to hear a longer version of this talk, I did a recording last night in Novi, Dublin. If you scan the QR code, then you can download it and watch for yourself. It's around 50 minutes, I think. And of course, if you want these slides, then scan the QR code and download them. And thanks for your time. And if you have any questions, this will be the time.
Okay. I don't know if you hear me. Thank you, Mr. Agnoletti, for a very comprehensive presentation. I think we have time for questions if there are anybody. I checked the chat. There is only one post. Interesting talk. Thanks a lot and good luck in the career.
Thanks.
And maybe one short question from my side. I guess that AppSec security principles are extremely important for software developers. But what do you suggest maybe for organizations who primarily use commercial software?
Well, I guess the best thing, well, you can do two things. One of them is, of course, to have when you are signing up with companies that are using commercial software, to having the contract with them some clauses about how they should handle application security. That's one thing you can do, but you can also do like dynamic testing on commercial software as well to see how it handles that.
Yeah.
And then if you find any vulnerabilities, you can always go to the vendor. Mm-hmm. But obviously it won't be a thorough walkthrough of security in the code when you don't have access to the source code. Mm-hmm. So it won't be the best thing to do, but it will be better than nothing, I think.
Okay, thank you for your thought, for your talk, and very much for your experience. So let us continue. The title of our next speech is Adaptive Security in an Oracle Database. Mr. Pete Finnigan is the next speaker, is with us maybe?
Yes,
Yeah. It is. Mr. Finnigan is from USA and
no, from England.
From England, sorry.
Yeah.
He's one of the most well-known experts in database security. So we are very glad to share your experience with us. So, Mr. Finnigan, the floor is yours.
Thank you. Can you see my screen?
Yes.
Okay, great. So we can get started.
Yeah.
Thank you. So yeah, I'm going to speak today about adaptive security and adaptive audit in an Oracle database, because my specialty is Oracle databases and obviously security of Oracle databases. So that's the sort of the basis where I think about things, but this could be applied to any other database. It isn't just related to Oracle, but obviously my detail is about Oracle. So I've been doing Oracle security for more than 20 years. I run my own company doing security audits and products and training and lots of other things. You can have a look at my website, petefinnigan.com. So I'm just going to talk a little bit, just a very brief history of where this came from. We're going to talk about audit toolkits, why I use a toolkit and how that can then lead into being used for adaptive audit and adaptive security. I'll explain the sort of link between these two things in a slide, one slide's time as well. So this won't click. That's it. So I first started trying to solve the problem of helping people put audit trails in Oracle databases a long time ago. So I asked for a show of hands at conferences. I remember doing this at the Hall 1 at the UK Oracle User Group at the ICC in Birmingham, and I did a rough count of how many people are sat in each row and how many rows there were, and I think there's about 900 people in the room at the time. So the big stage where the X Factor is filmed in the UK, and I asked people, put your hand up if you've got an audit trail in your Oracle database, and I did a rough count. And probably there was 20 to 30% of people had their hand up. So, okay, but not brilliant. I said, then keep your hand up if you actually do something with that audit trail. Have a guess how many people kept their hand up? One person out of about 900 people actually used the audit trail from an Oracle database. This doesn't sound as bad as it seems because most applications will have an audit trail. There will maybe be some audit at the OS level, but in terms of auditing the Oracle database engine, literally nobody's doing it. And this still is going on today. I ask this question quite often to people. I asked it in December when I was at a conference in Birmingham in the UK. And very, very few people are doing this. So I had a company came to me in about 2009, a bank, a small bank in the UK, which we call building societies. So they're like a small bank, basically. And the guy, I'd done security work for these guys before. And the head of IT or head of security came to me and said, we've had a problem with our external auditors. They've picked up, we don't have enough staff. So we've got a conflict of interest, particularly around the database. We don't have audit trails. We'd like you to come in and have a chat with us to see what you can do. So I went to speak to them, and they basically said they don't have any money. They don't have any staff to maintain an audit trail. They said, what can you do? Can you create an audit trail where you can simply turn it on, but it's succinct and it's auditing the right things? And then can you manage it without doing any work? So in other words, it has to clean itself up and it has to produce reports and so on. I said, well, how much time have you got? They said, well, we can afford to pay for 2 weeks. I said, okay, let me think about it. And I came back and thought, this is actually a good idea. So I decided to invest some of my time and build a toolkit that would allow them to simply turn it on, but to choose policies beforehand. It's incredibly simple. It would manage itself. It would produce reports and so on. So I did that and I deployed it for them. It solved their problem. And again, over the years, I've discussed this at various conferences. I've implemented it at various companies throughout Europe and one company in Asia as well. If you call Egypt Asia, I'm not sure if you do. No, anyway, in Egypt. So this has been quite a successful idea, particularly in the Oracle world, based on the mention I gave at the beginning, that most people don't have an audit trail. It's perceived as complicated. So if you could just flick a switch and you've got something useful, that would be fantastic. So this came out of that, really. This leads us into the title of the talk, adaptive. So after a while, I started to think, well, now I've got a toolkit and I can just flick policies on and off easily, just simple switch in some code. We could create adaptive audit. So we can have a database where it's being audited just lightly for most of the time. And if there is a perceived threat, we can increase the audit, because the more audit, the more storage needed, maybe there's a performance problem, more management, and so on. And I thought about the idea of adaptive audit, and no one's implemented it apart from me in a test system that I'm aware of in a commercial system. But I think it's an interesting idea. You could have a base level audit. It's a bit like the American DEFCON 1, DEFCON 5, and so on you see in films, and obviously they have in real life. If we have adaptive audit, we need to basically have audit to be able to create adaptive audit. And then similarly, if we want adaptive security, because we could do the same thing with security. If we want to create adaptive security, we must have security in the first place. We can't adapt it if there isn't any. And most likely we would need to use adaptive audit to create adaptive security, because we would use audit to dictate and detect if something is happening, and then use that to switch the security. So audit is the key. So we need to think about designing audit trails. As I said, most sites don't seem to have an audit trail. Some sites claim they've got an audit trail, but these are just the default settings that Oracle give you when you install a database. These are not designed by you. They're not your settings. They don't mean anything really. They're basically settings that are there to entice you to buy a product from Oracle called Audit Vault, which if you don't have, they're not really very meaningful. So lots of sites don't have it. Some sites have application level auditing. Some sites, in fact, most sites have some level of application level auditing. A small number of sites have maybe OS auditing. This is a real problem, because if there is a breach of your database, it's very difficult to find out what went on without an audit trail. You can do some things, and I do things around Oracle Forensics quite often, trying to find out what happened in a database when there was no audit. But having an audit, if you were breached, makes it much, much easier to work out what happened. So it's definitely worth having. So we need to design audit. There was a clue of this before. You can't just implement what Oracle gives you. That's not your design. That's not your settings. You must design your audit. You must design what you want to know. So you need to decide, I want to know if somebody logs in out of hours. I want to know if somebody tries to escalate rights. I want to know if there's SQL injection. I want to know if somebody tries to log in as a DBA. I want to know if somebody creates users. You can quite quickly come up with a list of things that you want to know. At this point in time, you don't need to know what the solution is. This could be Oracle's auditing. It could be a third-party product. It could be a custom thing you create. Maybe you add it into the network. It could be a network sniffing type tool. You don't need to know the solution, but you need to have the design before you think about the solution. I see quite a few people buy third-party products that are sniffing the network, but they don't have an audit trail design. They just implement it, and it's really not of great value unless you actually customize it yourself in advance. So here's a sample of a set of events that I created for a customer. So these are events. We've come up with ideas of things they want to know about their database. We've categorized them. We've decided whether we're going to report on it or not report on it. In other words, we're just going to collect it and leave it, or we're going to react to it and do something in real time. We've also said how often we should react to it or do something with it. So some things are immediate. So things like a failed login, we might want to know if that's an attack. So somebody's trying to guess passwords. So we'd want to then interrogate those failed logins. So if there was one failed login, we're not bothered probably. But if there was 60 failed logins in 10 seconds, we want to know, because that's probably somebody trying to break in. So create a design first. This is an example of a design that I've done. Then once you've got the design, you can work and build on that. You can decide what the actual solution is. You can decide what raw audit data you need to collect from the database. You can then decide how you're going to report on it. Is it just reports? Is it something automated? Are you going to send an email? Are you going to send an SMS when something particular happens? So in other words, you need to know how to alert or escalate if there's a particular issue. You can create this design very quickly. This usually takes just a couple of days in total, maybe with backward and forward meetings with the customer. So not really a couple of days work, but a couple of days of elapsed time. Not a massive amount of work to do this. Once you've got that, what we do is use our audit toolkit. And what I wanted, as I said at the beginning, for this customer was to be able to just, this is a SQL plus prompt in the first line. So type at the name of the script and it deploys it with minimal configuration. So just working out what policies you want, putting in the connection details and installing it, and it's up and running, it's managing itself, it's purging itself after the time limit you set, it's creating reports automatically, and so on. But it can also react in real time to things that are happening, such as the example I just gave. Maybe there's 60 failed logins in 10 seconds. It can react to that. Also, since I first created it, we've extended it, and it's called ATK, Audit Toolkit. We also created ATC, Audit Toolkit Central. So we can install the same toolkit in every database in a company and install it on one database that becomes the central audit. We then can ship all the audit from each of the target databases to the central. That gives us the ability then to monitor multiple databases and actually look for patterns across the databases. This is great because this feeds into adaptive auditing and adaptive security, because you can tell that if two periphery databases seem to be getting attacked, we could then use that information to tell all the other databases to increase their audit settings or increase their security. So PFCL ATK, the audit toolkit, it's policy based. So you're choosing what you want to turn on. They're predefined policies with things that need to be set. It's alert based. So it's using triggers, not database triggers per se, but triggers in terms of events or data to tell you what to do at that particular time. So some event happens. What do you do about it? Do you just produce a report? Do you do nothing? Do you send an email? What could you do? And obviously this can feed into adaptive security in terms of it could turn the security up, it could turn the security down, and so on. The core design is quite complicated. It's got quite a lot of stuff in it. It's about 20,000 lines of PLSQL, but it's quite succinct in how it works. So we've got, I think, 20 policies, 17 events. We have jobs that run at different times to do things and work things out. It's not just audit based in terms of database auditing. It's using things like error triggers and system triggers. And it can also add additional things into that as you go along. You can extend it. You can use checksums. You can do whatever you wanted to it. And we use jobs to basically control it. So that's how it's automating itself and managing itself. We have these things called factors. So here's just a little bit of the setup that you can change and customize for your own installation. So we can decide on, what is a support IP's address? So we can eliminate those from potential threats. Or what is the number of failed logins that we would agree is okay before it becomes an issue? So I've said 60 here in 30 minutes. So if there was less than 60 in 30 minutes, it wouldn't trigger an event. If there was more, it would, and so on. So we can add these factors. They're very, very simple. It's just declarative language, very, very simple to add, simple to extend. Here's an example of a policy. So the policies are made up of two parts. So they've got a policy name, obviously, but then they've got a set of raw things that you're going to collect, raw data that you're going to collect from the database engine itself. So I'm detecting the use of create profile or drop profile or alter profile system privileges. And then the second half of the profile is what you're going to do with that information. So we've got a filter. So this filters the audit data as it's collected. And this one runs every half an hour. So it runs in a job. So every half an hour, a job fires up and it goes to look to see if any of these issues have failed. In other words, there was an event and then we can do something with that. And the toolkit allows you to attach events to filters, to policies and so on. You can extend it as much as you like, but you can just simply turn policies on and enable it. It's very, very simple. So we must also have audit of audit within this toolkit. Oracle security becomes recursive and layered. So if you have some security in Oracle, Oracle is complex. You can have security at so many different levels that you then need to test the security of the security, or you need to test the audit of the audit to see if anyone's reading the audit, anyone's changing the audit, anyone's trying to manipulate the audit. And it's the same with security. So we also have the ability within the toolkit and the policies that are shipped with it to audit itself, to audit the audit of the database, and to audit the security of the database. So we can create simple policies, and I've just got a simple piece of SQL here that is just showing the policies that I've decided to enable for my toolkit here. So we've got 22 policies here, and I've decided to not turn on these ones with the N and to turn on most of the others. It's just a simple tick in one script. Just yes, no, yes, no. It's very, very simple to do. So I'm just selecting them from the database to see what's actually going to be enabled in my database. This is just an output of installing the toolkit, part of it. This goes on for hundreds of lines of output because it's quite a big toolkit. But just to give you an idea, it's very simple. You just type @ATK, enter. You've got a working audit trail in your database very quickly, very simply. And you would build this and base it on the document that we showed, the table of events that we showed earlier. You would then turn on or turn off policies, and then you can tweak and create your own custom policies if you want to. Here's some examples of some attacks against my database. So at the top part of it is an attack using SQL injection through a web interface. We've got on the left-hand side an attack basically doing SQL injection and trying to steal data on the left-hand side. And on the right-hand side, we're doing an attack where we're trying to change the password of a user. So it's very similar to the one on the left-hand side, but we're going further because we're doing DDL. This is just a sample of part of the output. So there's 185 columns of data in the audit trail. So 185 different things we can choose from. They're not all there for every record. We can produce any reports we want. And this is just a simple report, just showing the basic left-hand side of a report, showing the basic details of what the command was, what the error was, the session ID, the IP address, and so on. And we can see things in here that relate back to the previous slide. So we've got things like alter user or a blog, which is the second line from the bottom of the report. That relates back to that one there, alter user or a blog. So you can see that it's captured. Standard Oracle auditing, if you just deployed a new Oracle database and you got the settings from Oracle, wouldn't capture that. It's not there. So we're just adding extra levels, but we're doing it really simply to give you audit in your database very, very quickly. You can customize and write your own reports. They're just SQL scripts. They're very simple to do. So we can get on to the main idea of the talk, which is to build on top of the audit trail, which is adaptive audit. So what we want to think about is changing the audit trail based on the security or the perceived attack at the time. So obviously, doing auditing, you want to audit things that shouldn't happen, but you don't want to generate so much audit that it would cause you cost in terms of disk, cost in terms of CPU, cost in terms of people having to do something with it, because it generates a huge amount of data. And if you're then sending that data to somewhere off-site, to some other system like syslog, greylog, grey matter, whatever, it doesn't matter. You can have a limited audit under normal operation where there's no perceived attack, there's no perceived threat, but that audit level is enough that it would detect an attack, but it wouldn't be so intense that it would cause a big problem. So you can think of the American DEFCON 5, the lowest level of security according to America. And then DEFCON 1 is basically they're under nuclear attack. So you can have the same idea. You can have normal auditing in your database that is detecting, but it's detecting enough to detect an attack, but not enough to cause a massive amount of data. And as you rise up with the security or the perceived threat, you could increase the auditing. And this is really simple in the toolkit because we can just enable extra policies that add extra levels. So if we thought there was an attack in one database and we've got 100 databases, and every database is at DEFCON 5, lowest level of auditing, but we see some potential attacks of somebody trying to guess passwords in 2 databases, we could raise the security level in all databases to DEFCON 4. We could tell those databases to additionally audit perceived attacks of guessing passwords, so we can turn on additional audit to do that. We have to be very careful that this type of idea and technology could be perceived as a denial of service threat. So if somebody knew that you were using this idea, they would simply do some attacks on a couple of databases to cause you to raise your amount of CPU and disk and storage and everything. So this has to be done carefully. This is why we need to use conditional auditing. So Oracle allows you to do conditional auditing. There's a number of technologies within the database, such as fine-grained auditing. We can use triggers whereby we can decide what goes in the body of the trigger. We can use things like secure context to control this. Unified auditing from 12C, 18C, 19C, 20, 21 and 23 have conditional auditing in where you can basically put an if clause around the audit clause. So you can say audit access to this particular table for select, but you can also now say audit select, but only if it's Fred or Jim, or if it's not Bill, so anybody else. So we can do conditional based auditing. This feeds into the need to collect less data. And ideally, our design should always be about looking for things that shouldn't happen. So attacks, obviously, changes to configuration, changes to security, these things shouldn't be happening. So having audit turned on for them doesn't cause a performance problem or a storage problem. So we can do that. And that brings us into adaptive security. So if we have adaptive audit, and we can increase the audit based on perceived attack, we could also change the security. So we can have the database secure, not wide open, but reasonably secure, but not completely locked down under normal activities. If we detected potentially an attack in that database or another database, we could tell the security to increase itself to the point where maybe we lock everybody out except the application user. We stop all random access to the database. We can do things like this by using the ideas of context-based auditing, policy-based auditing, and reacting to that audit. And then we can do context-based security. Because we can change the auditing dynamically, we can also change the security dynamically. We can do this automatically. So if we think there's an attack, we could lock every account out except a particular DBA account or the application account, so the business keeps working. So we can use adaptive audit to build adaptive security. But remember, we can't use adaptive audit if we don't have an audit trail. We can't use adaptive security if we haven't actually implemented any security in our database. And we can't really do adaptive security without adaptive audit. We need all three of them to be together. So obviously you need to have basic auditing. You need to implement security in your database before you can think about going this far in terms of security in your database. So in conclusion, secure your database before you do any of this. This is nice to talk about, but you need to do the basics. You need to secure your database first. That database security should include an audit trail. And then when you secure, you could think about things like adaptive security, adaptive auditing. So we'll stop there. I think I've got about 4 minutes left if anybody's got any questions.
Thank you very much. Maybe there are some questions for Mr. Finnigan. I checked the chat. There is no post. Maybe one question from me. I'm not an expert in databases, but I guess that performing an audit in a complex database is very time, as well as time and resource consuming activity. So I suppose we need to balance between our resources which are available and desired security level. So is there any useful hint you can suggest to database administrator how to reach the optimum? How often should the audit analysis should be performed?
Yeah, I'm not talking about doing a security audit. I'm talking about audit trails implemented in the database. So yes, you need to do a security analysis to understand what the security level of your database is, and then use that to then decide what to fix in your database and what level of security you need. But in terms of the audit trail, which we were talking about today, then I mentioned a few times throughout the talk that the key thing is to audit things that shouldn't happen. So if you audit the things that shouldn't happen, if there is then a performance problem or a storage problem because there's too much data, the problem isn't the audit trail creating the performance problem. The problem is somebody doing something they shouldn't be doing. And you need to then fix that and stop them doing what they're doing. And then the audit trail problem goes away. So it's a balancing act. This is why I created this toolkit to make it easy for people to implement an audit just simply by turning policies on. But obviously, you know, what you talk about doing a security analysis of a database is part of this whole process, because you can't decide on audit settings without understanding the security of your database. So you should do a detailed audit of a database every year, year and a half maybe, and then you should do automated scanning maybe once a month, every 6 weeks, maybe every 2 months, to understand if your database stays in step with what you've decided as a security policy for your database. Hopefully that answers your question.
Yeah. But the audit trail is the primary condition to do effective audit, if I understand right. If you implement audit trail into database, then this is the first condition just to perform audit in the future. Yeah.
Yeah, the audit trail is like logging what happens in the database. So it's like auditing on Solaris or on Windows or whatever. It's the audit trail. It's not the security audit.
Okay, thank you. For
They're two separate things. Yeah.
There is a post in the chat from Mr. Babić. Thank you for your talk. I got new insight into databases as I learned at college. Thank you.
Thank you.
So thank you very much again for your presentation.
That's all right.
And, we can move further. So our next speaker is Mr. Christopher Cowling. Is he with us? Yes. So Mr. Cowling has more than 20 years of experience in cybersecurity in different industrial areas. Today, he will talk about European covert methods of entry. So, Mr. Cowling, if you are ready, the floor is yours.
Thank you very much.
Yeah.
You guys can let me know when you can see my screen.
Yes, we can see.
Cool. Hopefully my slides will appear as well.
We can see a beautiful
Okay.
island. Yeah.
It's not my island, unfortunately.
Fortunately. Yeah.
So good morning. Welcome to one of my favorite talks to give, because it means I get to share some of my favorite YouTube videos, as you'll see. So we're going to look at why being a physical tester or a covert entry specialist who wants an easy life may be better off moving to America. Everything that you're going to see in this presentation is stuff that we have done. We've performed on various clients. Most of it is obviously illegal unless it's against your own property or you have a legal out of jail letter from the client that you're testing against. So do not attempt to do any of these things without it. So who am I? Father, hacker, barbecue pitmaster. As Christina alluded to, more than 20 years of experience, mainly with blue chip. My glamorous job in Formula One, as you can see, I'm working for telcos, industrial control system vendors, etc. Currently working as a red team operator and pen tester. I'm probably domain admin or root on one of your systems, and I get to tinker in the physical and hardware security world. So why physical testing? Physical testing has been part of red team engagements forever. You know, if we can't get you to click on that phishing link, we can't break into your website in order to get that initial access, then a red teamer is going to go on site and try and install a keylogger, a network device, get access to one of your systems. There's an old adage that, you know, physical access plus time is always equivalent of a cyber breach. You know, if I steal your laptop, it's only going to take me so long before I get access to the stuff that's on there. It can also mean stealing physical records, so invoices, HR records, anything with personal information that can be sold. You know, all of those things are of value to an attacker. So they're, you know, they fall under the remit of what we can do. So, you know, I like to say that my job, I can be running down a set of stairs with a bag full of intellectual property over my shoulder, being chased by security guards without a care in the world, because if I do get caught, what I'm doing is completely legal. So just makes my job more fun. So where it differs from just performing plain robbery is it's usually non-destructive. We tend to have clauses in our contracts and agreements that prevent us from, you know, smashing windows and breaking locks and things like that. And ideally, you're trying to do it as forensically cleanly as possible. And you also, you know, only ever do it when you have that out of jail letter. You know, some of the downsides of it tend to be, you know, waiting for people to leave a building. So, you know, hiding in the toilet or that stairwell, you know, means that usually the first thing you do when you get in is try and find where the toilets are. So, you know, to give an example of how critical this can be, so the guy on the right there in the photo comes from the January the 6th storming of Congress in the US last year. You know, that guy sat at the desk of Nancy Pelosi and is going through her mail. You'll also notice there's you know, a computer in front of him that he may or may not have had access to. So how it's going? So as I mentioned, it's been part of red team engagements for years. It's increasingly being offered by cybersecurity companies as a separate service, you know, physical penetration testing, rather than just having it as part of a red team. It is very US centric. If you are looking for material on this, there are spades of it out there telling you how it works in the US. They even have training and certification covering, you know, covert methods of entry, physical access control systems, surveillance alarms, etc. Why is it easier in America? You know, it's a very young country. You know, Queen Elizabeth died last year in the UK. She'd been alive for a quarter of the entirety of US history. You know, most of that history has been in the industrial age. So they've come in with mass production of cheap products rather than having to develop stuff over time. The US is actually very geographically spread out. You know, it's not uncommon that your nearest neighbor isn't, you know, just literally next door like we think of it in Europe, but they could be, you know, 15 kilometers down the road. The other reason tends to be guns. You know, when 89% of the population have a gun, you know, you don't necessarily need to have great locks on your facility if you've got armed guards in there that are acting as a additional deterrent. One of the other reasons is the keyways on locks. So one of the primary skills for a covert entry specialist is lock picking. You know, we have a lot of crossover with the lock sport community. So, you know, picking locks, bump keys, impressioning, creating keys from photos, or, you know, if you can get hold of a key for a short while, taking a copy of it, are all ways that we use to be getting through there. So the keyway is, you know, this gap here where you're actually putting in the key, and they tend to be much wider in the US. So when you're picking European style locks, this is much narrower. They tend to be a lot more complicated in the shape that they are, making them a lot more difficult to actually get tools in to actually do the lock picking and stuff that you're doing anyway. And additionally, we tend to see a lot more of this style of lock in Europe. It's known as a dimple lock. It's essentially the same as a normal pin tumbler lock, but the the grooves that you see normally on top of your key are just on the side of the key. So they're just a different style of the same technology, but they are, you know, a different kind of set of skill set, because you're not lifting things up and down. It's a rotary kind of action with a different set of tools to pick them. So yeah, lock variety in the US, there's, shall we say, 7 major manufacturers, but the vast majority of locks are made by 4 or 5. In fact, Schlage and Kwikset cover 98% of residential locks. Things were a little different in the commercial space. So that means that, you know, providing resources such as this chart is the pinning chart for a Kwikset, so we know, you know, the distance of where the cuts need to be made and how deep they need to go on a Kwikset lock. The other diagram we have here is an overlay. So if you've managed to take a reasonable photo of a key, you can overlay this on top of the key in order to actually figure out you know, what the bitting is, and you can reproduce a key from that photo. And you know, there are tools like the item you see on the right, which is a kind of a depth gauge that will allow you to, you know, check your work. So to give you an example, this here is a Schlage key. If we take that photo overlay, we can place it on top of the key. We line up the black lines with the top and bottom of the shoulder, and then we have blue lines are odd, grey lines are even. So from this we can see pretty clearly that the bitting for this lock is 69979. That allows us to, you know, even walk into a hardware store and that can cut a key to code and actually do it, or we can cut the key ourselves with a file and measure it against the chart on there. Standard keys are a lot more prevalent in the US. You know, this is a list of common keys that we typically see in the US. By far and away, the most prevalent is the CH751. This item here, it was originally kind of done for those recreational vehicles, kind of the caravan already attached to the vehicle. There's even a Twitter hashtag out there where people are posting photos of where they've discovered CH751 keys, and they are everywhere. Standard keys do exist in Europe. They're not as common, and there's a lot more of them. So you end up just carrying huge numbers of keys. So what we tend to do for Europe is just carry primarily the common keys for server racks, so that once we've managed to enter your server room, if we've been that fortunate, then yeah, we're able to open the server racks, but we tend not to carry too many other kind of standard keys. Building entry systems, so the intercoms, where you're pressing a button to speak to someone, or putting a code in to open the door, and then the person lets you in, are are very, very common in the US, and there's typically only 4 major brands that are doing it, and 2 of them have standard keys that are on this list. This is one of them. I don't know if you can hear the audio from the video.
We do have a dorking system. Id procs if you want to sniff it or clone it.
So this is a dorking system.
Override key.
So we have a key on the front for the postal workers to get in and deliver packages, but we're not interested in that because it has a standard key. You can press one switch on the back and it unlocks the door and allows you to go straight in. So these dorking systems have basically had the same key since 1992. So the switch that he pressed, as I said, is to allow a postman or someone to deliver a package. You know, they typically have a key that they put in and turn, and it would press the same button that he is. If that isn't installed, basically where they are connected to the circuit board on the back, at the bottom there are connections. You can literally just jump those connections and do the same thing. Manuals for all of these systems are online. So you can go and figure out the same bypasses for most systems that are out there. So door hinges. The US still uses a lot of very traditional door hinges. So if you have door hinges that are on the side of the door that you are, they tend to be what we call non-captive, which means that the pin inside that's holding the 2 pieces of the hinge together can be removed. So, you know, why would you try and pick a lock when you can just open the other side of the door completely? So this is a hammerless pin removal tool that fits nicely in your pocket, about the size of a pen. You know, if you can just find something hard and stuff, you can always find something to hit it with. So if you don't have a hammer or a nail or this tool, you can usually improvise some kind of a solution. So going under and over the doors, by far and away the most prevalent tool used on jobs in the US is what's known as the under door tool. We do use it in Europe as well, but it's the principle behind it is that, you know, underneath this gap at the bottom of a door, there's usually 3 or 4 mil of gap. You know, we tend to have maybe some weather stripping there or a brush, but that doesn't stop the tool being used. And we're going to reach through that gap, come round and actually just pull the handle. So if there's an access card on the outside of this door, you know, if there isn't one on the inside, the door's always going to open when the handle gets pulled. So this is what it looks like from the inside. This is actually part of our development stuff. We were testing a very thin new tool. And as you can see, you just pass it through, pull it over the handle, and then there's a string that pulls down and bends it. If you don't pull it hard enough, you can just give it another go. And the door is open. So if there's not a gap at the bottom of the tool, a lot of US handles actually you can lift up as well as down in order to open. It's a design that's less prevalent in Europe again. Or if they have the old ball style handles, both of those you can actually attack by going over the top of the door using some old 35mm film, which we'll see in a later video.
Go.
So latch loading is another big area that we see all over the world, but is a little bit different in the US. So the latch is this part of the lock that actually goes from the door into the frame or the strike plate. In the last 15-20 years, we've seen a lot more of this little bit sticking out on the side appear. This is what's known as a dead latch. So when that's pushed in, it stops the latch from going in. The reason this is important is because a lot of handles actually just stop you, just stop you from turning the handle. So this latch is still free to move unless it has a dead latch like this and it's put in. So unless your door doesn't have this, or the hole that it's going into is too big, or your door isn't quite hung right, you know, if this dead latch can pop into that hole or be pushed on the door to go into that hole, then this latch is going to be able to move. And there's various tools for allowing you to move it. So here's a good example. So the guy has what's known as a latch knife. It's a very straight tool. So this door is obviously locked. It's got no way of going in. So when he finishes his little talk, you'll see he's going to put his foot on the bottom of the door and give it a bit of a push. And then he's also going to lean on the door with his shoulder. And what he's doing is essentially pushing the door in so that you can see the small dead latch on the here. So it goes into the hole. He reaches behind the latch and then pushes on the angled side of it to slide it out. And he's then through that locked door. So in America, doors tend to all be very similar to the one that you just saw, where there's basically, you know, a straight line between the door and the frame. So we have tools that look similar to this one. This actually is 3 tools in one. It's called a rescue gym. It has a pull piece here, a pull piece here, and if the door is facing the other way and you need to push on the angled side rather than pull on it, you can just stick in and use the front of the tool here. If doors are a little better fitted and that gap isn't quite so big, to get a tool like this in, you can use what are known as super mica shims. They come in various thicknesses to be able to work through. They're basically the modern equivalent of your flexible friend. You know, you can actually use a credit card like you see in the movies. Just don't expect the contactless payments to be working afterwards, because you'll probably snap the aerial that's inside there. The trouble with Europe is that a lot of our doors actually look like this. You know, there's a lot stricter regulations surrounding energy efficiency, etc. So we tend to not have just that straight line between the door and the frame. We tend to have rebates and overlaps, which means that we need a whole different set of tools. So as you can see, most of these tools have some kind of an angle in them that you can work around the frame to get in to perform the same action. You know, similarly with these what are called latch needles up in the right hand side here. We also have spiral tools. So when we have like multiple angles in the door frame, we can place these next to the door and actually just twist them like a corkscrew, and they work their way between the door and the frame to push on the latch. All of these tools will tend to work against your home doors as well. So a lot of people, when they go home, they shut their door and they don't have a handle on the outside, and they think it's safe. But if you're not actually locking your doors, then you know the latch can still be manipulated using similar tools to this to get into your home. So we do have some similarities. Doing privilege escalation in the physical world tends to exist where we have what we call master keyed systems. This means that, you know, if we take our wonderful crypto people, Alice has got access to her office, but she doesn't have access to Bob's office or the secret document destruction room. Bob's got access to his office, but not to Alice's, but he does have access to the secret room, and Carlos, being the manager, has access to everything. So if Alice gets disgruntled, or maybe she gets a nice bribe from an attacker, you know, they're going to try and make it so she gets access to everything. So we're going to escalate her privileges to be able to do that. So the way master key systems work is that they add in an extra little wafer that you can see in green here in these 2 stacks. And that means that keys that are cut at 2 different depths are going to work in that lock. So we already know the depth of cuts that work for Alice's key, because she's already got a hold of that. But she can actually work through what we call creating exploratory keys that will search through all of the possible depths in each of these stacks to try and discover where there are other working lines that will actually allow the key to turn. And from that, she can actually quickly discover the master key that will open all doors in the entire building. So it's actually quicker than brute forcing, because we know that there are certain rules, such as, you know, there may be like two cuts between existing things to just prevent the locks from jamming up. But once we have that successful depth, we're going to be able to get into all keys. So we do have other similarities. This is what's known as a J tool. You'll see this in use in a moment as well. So where you have thumb turns that tend to sit on the internal side of doors, this is designed to reach through the gap in the doors, connect onto the thumb turn and turn it and open from the inside. So the other kind of tool that we tend to see is what's known as a double door tool. It looks very similar to this. And you'll
Sparrow's DDT stands for double door tool. Sells for about $13 on the Sparrow's website. It's kind of odd because on the website they say if you don't know what this is, you don't need it, but I think we do. How does it work? Well, I think you guys can figure it out. It's fairly intuitive, but that's the purpose of the glass door. You can see exactly what's going on. All we're going to do is work our tool through the glass, through the gap, and then we're going to turn it. And you can see we're engaging with that quick release. Now the door is locked. So let's go ahead and see how easy it is to do the bypass. And that, my friends, is all.
So this tool is a tool we tend to use very much on fire escapes. You know, those doors that have the push to exit bar. It's a very useful tool for doing that. So the other thing we tend to see on doors is exit sensors. So those PIR sensors that sit above the door, you know, you'll see them for double doors for shops all the time. You do tend to see them in some offices as well. And they're looking to detect not only movement, but also a change in temperature. So if you can trick that sensor into thinking there's a change in temperature and movement in front of it, it's going to open the door for you. So the best examples I could find for that are in a compilation of these videos. So we'll see a few more bypass techniques and some of the ones we've already discussed as we go through. So yeah, bypassing the supposed safety lock, typical on a lot of hotel rooms as well. Another example of the under door tool. This is the that's using 35mm tape. Feed it through the top of the door. You know how long it needs to be, then from one part of it, create a loop. Lift the handle instead of pulling on it. Slightly more complicated way of getting past that latch. Piece of trash that was actually found to latch load this door. Plastic water bottles tend to be very good. There's another American tool called the Traveler's Hook, again on a very simple to open door. Now people do try to prevent this by putting plates over, but you can just use a bigger tool or a piece of string. Bent coat hangers are very useful for opening doors. The DDT tool again. So here we start to see using compressed air that you use for cleaning your keyboards and things. Creates a change in temperature and some movement in front of the sensor. Door opens. Using your vape tool also seems to work. And if you happen to have a cold glass of whiskey over ice, that can work as well. So this is a tool for automatic coding and opening tubular locks, similar to your bicycle lock. It can be that quick and easy. I wouldn't recommend you go around removing your parking clamps, however. Hotel safes are a security nightmare. We recommend you don't use them. Most have a key. For this case, it's hidden behind that little one. This particular model, basically secured by a piece of foam behind where those LEDs are. But again, a piece of bent coat hanger. Will allow you to open the safe. nice car in a showroom where the doors are secured just by the bolts at the bottom. Use our J tool. Place it on the front turn, give it a turn. And we get in. So as you can see, there's lots of bypasses that involve not picking locks. So just because you think your door is secured because you have a lock on it, it may not be the case. And you know, a lot of the training that goes on for this kind of work will involve you know, learning how to analyze doors and figure out the best way to get through them. You know, similar to as you would with vulnerabilities in doing normal pen testing. So physical access control systems, you know, there's a whole bunch of tools that are out there nowadays for looking at these, assessing them. A lot of them focus around copying of access cards or key fobs. You know, they're used not just for doors, but also for alarm systems. But there's many ways to defeat other ways to defeat alarm systems, like the you know, the sensors that go around doors and windows can usually be defeated by placing a magnet in front of them as you open the door. So if you have more complex systems, you know, such as biometric entry systems as well as card access systems, there is a way of working around those as well. So rather than trying to copy somebody's eyeball or chop off their finger and keep it warm to get in a door, you can actually just attack the reader itself and sniff the traffic that goes from the reader to the wall. So here we've got a locked door with a quick tool. And most of mine literally one screw. We can pop the reader off of its frame and pull out the wiring. So we're looking for 4 wires. We've got a red and black for power, and there's a green and white one for data. And what he's doing is punching down those wires onto a tool that you see pictured in the corner there, known as an ESP key, which is a Wagon protocol analyzing tool. So it takes just a matter of seconds to put that on. We saw the blue light come on, so it's all got power and working. And he puts the reader back on the wall and disappears off. So the ESP chip on there allows him to connect to wireless to the device. He waits for somebody to enter, and it records the message that's sent from the reader to the controller to open the door using a standard protocol, which is known as Wagon. We can then come along afterwards, open up our application, and tell the small device on the wire to replay something it already saw, and you're straight in. So it doesn't matter if somebody actually authenticated to the reader with a retinal scan, a fingerprint, they entered a PIN, they scanned a card, whatever the process is for the reader, it still sends the same information through to the controller. So by sniffing that, we're able to bypass even those more complicated type solutions. So SDR and Wi-Fi attacks are still very prevalent. So in a minute, this guy's going to use a hack RF with a porta pack to open this garage door. It basically is a replay attack because there's no rolling codes that are implemented for this particular system. It could have been done with a flipper 0, flipper 1, anything that you can use to replay it. If there was a rolling code, you know, 2 yardstick ones, one blocking the signal, one capturing and replaying the second one would still allow you to get in. Wi-Fi cameras tend to be very prevalent these days. You can actually magic your way past them by just knocking them offline with a normal Wi-Fi deauth attack. You know, it can be as simple as a few button clicks on a tool, replay a wireless signal, and the door's open. We do have some things that are worse in Europe as well. So we tend to see a lot of these, what we call tilt and turn windows. Tools like the one you see in the left can actually be passed through to place something over the handle, pull the door closed, and then move the handle to the position that will open the window fully. And this style of lock that you see on the right is so prevalent, it's known as a Euro cylinder. And as you can see, the weakest point is around the screw there. So if you can get a grip on the outside of it using like a pair of vice grips, and you can manipulate that to cause a failure in here, it takes typically about 13 seconds. It doesn't always have to be hard though. We are looking for other EU-based covert entry specialists. So if we have any physical testers who are on, we're looking to create a centralized repo of things like key gauges, common keys for a particular country, things like that. So if you're interested in helping build that community in Europe, let us know. But like I said, sometimes we don't need complicated tools or particular skills. It can be as simple as this.
This has to be the simplest, cheapest, dirty red team trick in the book. Take a pen or a pencil and lean it against a locked door on the hinge side. Now just wait for an unsuspecting employee to let you in. I prefer to use a pencil because it doesn't stick out against the door and it compresses instead of breaking. Once the employee opens the door, the pencil falls into the gap, preventing it from closing and granting the pen tester access.
It can be that simple. Thank you very much. I know I'm probably close to time, but if there's any questions,
thank you. Thank you very much, Mr. Cowling, for a very interesting presentation. I think that during the break, the first things we will do will be to check our front doors. Are there any questions from the participants? You can put in chat or maybe simply raise your hand and you will gain access to the microphone. Yes, Mr. Uroš Babić has a question. Yeah, please.
Yes, I'm here.
Yeah.
Hello, everyone.
Yeah.
He's our next speaker. Yes.
Our next speaker. Yeah. Maybe one question, if you have time, a minute for Mr. Cowling. If you draw a parallel from the logical security, I think there is an urgent need to implement the two-factor authorization in physical access. Which solution do you suggest for private use?
Yeah, so for private use, everybody has a lock on their door. As I mentioned, a lot of people actually don't lock their door. They'll close it and assume that because there's not a handle on the outside, it can't be opened. So actually locking your doors when you even when you're in the property at night to stop somebody coming in, but also adding an additional deadbolt. It's unfortunately most burglaries or attempted break-ins don't involve any form of lock picking. They're typically a destructive kind of attack where somebody's going to try and snap your lock, break down the door, break a window, coming like that. So having sensors that are going to detect those kind of things and adding a deadbolt to your front door are probably the most effective things you could do for your personal safety.
Okay, thank you very much. So we come to our last presentation in this section. Mr. Uroš Babić is already with us. Mr. Babić currently works for Serbian oil industry as a cybersecurity manager, and today's talk will be about Azure Active Directory incident response. So, Mr. Babić, now is the floor yours.
Thank you, Alenka. Thank you firstly for organizer who invited me to the Hek.Si conference. I'm very proud to be part of this conference. Yes, the subject of my presentation is Azure Active Directory incident response. That is, my focus for this presentation is how to describe the life cycle, the process and tools, because Active Directory in Azure response methodology is a critical life cycle process and tools that anyone who is using or try to access and identify on Azure Office 365 and 30-party cloud can count it. With this methodology, we explore how the Azure Active Directory investigates, manage, and response and many security breaches. It involves many skills knowledge and experience about security incidents, how we protect Azure Active Directory, and collaboration with the different CERT team. Definitely, it depends of type, wide, and scope of incident. Short about me, I'm currently working as head of cybersecurity in NIS company, that is an oil company, Serbian company, but I'm also working as a micro-certified trainer in SEMOS education. I'm working currently with a very different IT security tool, like security event management system. Like I'm also a cloud access security broker administrator. I'm DLP administrator, and a lot of other IT security. I'm responsible, for example, for privilege access management, identity management in my organization. But I mentioned I am also involved in many international training with my education and experience with my students for all Azure program. Okay, but I'm also CompTIA instructor. I'm responsible for EU Council program, because I'm responsible for incident response in my company, but I'm also involved with my student in the incident response, EU Council incident handle program, and computer hacking forensic investigation, because I'm previously working in law enforcement and conducted many cybercrime investigation in my company. Okay, that is shortly about me, and my focus in the next slide, how to describe many Azure cloud security challenge, because cloud services are provisioned and deprovisioned more quickly. Cloud provisioning is allocation of cloud provider resources and services to the customer. Cloud provisioning is a key feature in the cloud computing model, relating how the customer proceed and cloud services and the resources from the cloud provider. It must be self-provisioning, which, for example, cloud customer fills out online requests for the services with the cloud provider and then sets some aside cloud resources for the customer. The provisioning is actually removing some user access in the Active Directory for my application, for my virtual machines, for the system, for the data. For example, I mentioned this pairs, the cloud strategy in a large organization. Many organizations have a problem in trying to adopt with the cloud strategy, because is not sure. Some of companies not cloud-based oriented. For example, before 1 day, we have some global Azure network outage, and it affected us to work too. The question is, how can organization using Azure to prepare for these issues, incident of outage? We must keep track for some education in Azure status with the service halt, set up some alerts in our Azure mobile application, how we detect and configure Azure action groups, backup deployment, automatic backup, failover groups, and the geolog replication for our cloud services. That is very important. Implement backup and disaster recovery for your Azure application is resource part for the web application firewall resiliency. That is also crucial. And how we make use, how we the help, how we using the Azure support in critical situation. That is very important. But from an incident response perspective, there should be some incident response plan and detect and monitor and respond to security incident, how to affect application architecture components under their responsibility. We definitely must have some strategy of NDA in place with our Microsoft as a cloud service provider to ensure they can manage cybersecurity incident with their responsibility. For example, does the cloud service provider have the relevant certificates? Has the risk assessment analysis of data processing in the cloud? What about the encryption or all confidential data before the transfer in the cloud at rest? With application of the best global practice to complete some restoration with disaster functionality, is the transfer to another location ensured the cloud service verified? What about for our exit strategy to be verified, the specified and procedure, it should ensure business continuity in case you have some unavailability of our service in more than one working day, for example. And we have visibility and control change, because cloud visibility is ability for have some detail of your all activity of our Azure cloud. It means we can detect security threats and inefficient performance in our cloud deployment. One of the main benefits of the moving cloud is scalability, but scales come with the risk. If your organization increase capacity, you will have more infrastructure to monitor. In addition, you're bound to face the security challenge. And that is some tricky situation. Of course, we must have some shared responsibility plan. We rapidly changing workflows because we are relying in the past with the traditional cyber attack in on-premise, but we now have some sophisticated attack, zero-day vulnerability. How we dealing with in the cloud? Security skills and short apply, the visibility and control I mentioned, loss of control. Moving the cloud means release twisting control in your organization, IT to cloud service provider. You no longer know the data center of which your data resides. You also don't control the network that your data runs through. The loss control could lead a loss of visibility. That is very important. And I mentioned compliance with the regulation in the many interesting standards. For example, 27 ISO, including 31,000 for the risk management standard. That is also important. And we have, I mentioned, shared responsibility model. What means? Many organizations rely on the software as a service delivery model for cloud application to manage core business functionality and requirements, including web application, out application, communication. Those applications are considered by threat actor as a high value target that many contain confidential data, such, for example, personally identifiable information, some supplier data, some customer data, financial, business data. Understanding the shared responsibility model for cloud application is critical for many organizations to develop effective strategy in responding to security incident. Important platform is identity. In software as a service delivery model, consumer is responsible for the security of data, for endpoints, for accounts, or for example, access rights, and identity management, while other components are responsibility of the cloud provider. And we have incident response management process defined in Microsoft Azure with the life cycle, because Microsoft Online Services, security teams and services teams working together on the take some approach and security incident with which the based of NIS2 861 response management plans. In preparation, that is refers the organization preparation, it needs to be respond, including many tool, process, competencies, and reasons. Detection refers to activity that detect security incident in production environment. Containment, eradication, recovery, action taken to contain security incident based of analysis done in the previous phases, more analysis to be necessary in the phase 2, fully recovery from the security incident. And the last, we have the post-incident activity that refers to the post-mortem analysis, how we recover this after recovery security incident. Of course, we have preparation with a lot of training and background check, because preparation enables rapid response when the incident occurs, and many even prevents incident in the first place. Azure dedicated significant resources to prepare for security incident, and organization, of course, using some Azure service and should provide employee with the training, how we dealing with the security incident, how we are dealing with the response procedure appropriate, definition security incident, role and responsibility, plan, training staff. And of course, we have penetration testing assessment that is very important in accordance with the OWASP top 10. When we automated security testing, conducting vulnerability scanning, for example, we defended for the cloud with the Qualys, and external internal penetration testing, and conducting system vulnerability testing in accordance with the Microsoft Online Service Big Bounty program. And also important part is attack simulation based of red, blue team and joint exercises. After that, we have detection, because the organization should be centralize this audit logging and analysis to detect many anomalies and suspicious activity. Log files from the Azure service should be collected and stored in the central place, like security event management system, cloud-based oriented in the Microsoft Sentinel with the Sentinel user behavior analytic, and how we correlated log entry from the different sources. That is very, very important. That should be central management detection tools in place, including antivirus and anti-malware suites and network-based and different tool for intrusion detection, system prevention, manual detection methods such observation from engineering and end users. When the potential incident is detected, the process should be escalated from the severity on security response team should serve some key orchestration in security incident response process. We have some Microsoft Cloud recommendation for application security offers deep visibility in the Office 365 activity. You can see that in this slide. But the part of incident diagnostic, it is necessary to initial stage for this in the process and small accounts to provide many different answer for that. And that is a crucial process in detection and analysis incident. Base of analysis coordinated in containment, crucial is the primary goal for security incident is to limit impact for the customer for their data or Microsoft systems. The primary goal of containment is also for the system, limit harm, applications, customers, customer data, and security response team in this phase should work with the affected service teams to limit impact for security incidents and prevent further damage. All automated response solutions with Azure should help team contain of incidents and involves preventing the further spread of incident of implementing. That is very important. In eradication, we have a process for eliminated root cause analysis on security incident with a high degree of confidence. And the goal of eradication is to evict some completely from the environment, I mean, great vulnerability to contribute some incident and could enable to re-enter environment and steps to evict some adversary and mitigate vulnerability based of analysis performed the previous incident response phase. In recovery, when the security response team is confident to adversary has been evicted from the environment and no vulnerability have been remediated, the team should work with affected service team to initiate recovery. Recovery brings affected system to know security configuration. Recovery process include many identify the last known good state of the service, restore for backup, and confirm the restoring state mitigate its vulnerability and contribute for the incident. Key aspect of recovery process is enhancing detection control to validate the recovery plan has been successfully executed. No sign to breach with the environment. For example, increased network level monitoring, targeting alert for attack vector, enhanced monitor helps to ensure the eradication successful, that adversary is unable to enter environment. Affected system are in turn in production, system recovery, accepted and adopt the patches after installation, reinstallation, returns files to the backup copy, change access control list, and everything. And customer notification is very important after detect affected tenants in Azure Active Directory, and corresponding communication team works together. It's very important. Notification include these steps you can see in this slide about the incident, some description of the incident, what is affected of the customer data. And we have also post-incident activity because we have actually 4 stages in this phase. The first is post-mortem. After incident has been resolved, select security incidents, especially customer, impacting or resulting in the database on the full incident post-mortem. Deep analysis, the root cause analysis and investigation to detect opportunity to improve. Lesson learned is very important in this phase. Activity after incident, for example, analysis of key causes, documents, acquire knowledge about incidents, incident reporting, and unmentioned root cause analysis, the person in charge of incident, what lead to incident, the method is used, for example, for analysis, root cause analysis to detect the cause to lead for the incident, with correlation of events of security incident, graphic representation, timelines of key causes of the incident, categorization of incident and description, vector attack, established timeline I mentioned, and that is the following activity in this phase. We have process improvement with the law enforcement, maybe incident have some cybercrime. For cybercrime investigation, we must define the chain of custody in our forensic investigation to have proof for contact with law enforcement, logging and tracking internal Microsoft engagement database, and lessons learned. That is very important, and that this can describe that life cycle and security control. We have the logs. We define everything because. For example, signing logs, Azure activity from our Microsoft Defender for Identity weight, crowd layer, but also we have many incident response tools in that phases, and we prepare, we detect, identify, we contain with the DENI description, with the recommendation in the response, how to reduce, how to deceive and destroy in the eradication phase, and of course in the recover phase we have some remediation, but very important thing is communication with the diligence reports, and investigation feedback is very important. And I mentioned some Azure platform logs. That is very important because platform logs provide some details, diagnostic and audit information for Azure resources, and Azure platform depends. For example, we have resource log, activity log, Azure Active Directory logs, audit log with our PowerShell command prompt let, for example, use for the query logs, 90 days, rotation limits, list of some signing application, how many password resets happen in my Active Directory tenant. And also we have Office 365 log in two categories. Undefined audit logs and mailbox audit logs when you're talking about the Microsoft Exchange Online. And that is example some attack because attacker using internet to port scanning to discover there is a public IP listening on some management port, and then could use some brute force attack your jump box, take control for virtual machine, and establish footprint in your environment to perhaps have access for your virtual machine. And we have that is how we resolve that with the just-in-time virtual machine access. You can lock down to inbound traffic for your virtual machine to exposure attack while providing easy access to connect virtual machine. For example, for my virtual machine, I just enable just-in-time in my virtual machine in my Microsoft Defender for Cloud, and I define, for example, for port 3389, for 3 hours, I have access only with my IP address with my virtual machine, and that is how we protect in that. But we also have many other challenge with other security control with the problem attacker deploying the malware security when they try to detect counter-resist application. Application whitelisting is very good mechanism to limit exposure for malicious and vulnerability application. And of course, that is example when I have some application whitelisted for Microsoft application, but with no Microsoft application for Adobe XD, I have violation and audit in my logs. File integrity monitoring is very important with how we examine operating system files, Windows registry application software, Linux file system, how we track change tracking resources, what are different solution, and we can file and registry key creation to removal, file modification to tracking, and file integrity monitoring inform us about suspicious activity, file modification, change in file size, access control list, for example, hash, registry modification, and of course, changing in size, access control list, and everything. That is example for some configuration text file, how we monitoring in security center with option file integrity monitoring. And we have different category here. And we are also using some incident response playbook for this different type for attack, for phishing, password spraying, application constant grant, compromised and malicious application. And some playbooks, each playbook include 4-stage prerequisite workbooks, check investigation steps, detailed steps, evidence for the specific investigation is on the Microsoft link. And some for, at the end, some very good Microsoft tools we are using in investigation. I mentioned many tools. For interesting for me is, for example, Sparrow in PowerShell tool developing with the cloud forensic team to detect some malicious activity, such probably compromised account and application in Azure and Microsoft Office 365 environment. Azure Hound use some Azure PowerShell module for gathering data with Azure Active Directory. Hawk is module scan for Office 365 audit logs, gathering all information and export audit logs from Office 365. Azure Active Directory incident response use Graph API under the hood access to data to start with obtain API access token. Once this token has been received, you can call to resources, returning data and everything. And you can see on this slide many other very interesting and very useful tool for incident response like CrowdStrike, like Sentinel detection, Office 365 extractor I mentioned, Azure Hound, Blue Team Kit with 365, Azure Hunter and everything. Generally, that is it from my side. Alenka, if you have, that is very wide.
Just in time.
Yes, yes.
Maybe we have time for a short question.
Yes, of course.
I will check the chat. There is nothing in chat. Maybe one question from me, since I'm not a technological freak.
Yes, yes.
Maybe general question, is the solution or methodology you talk about also applicable to micro companies, or is suitable for large enterprises more?
Yes, that is very, very good question. Thank you for your, because that is very important question. That is for both options. And protect organization information as well as it's for reputational risk, deploying and implementation incident response infrastructure, for example, plan, define roles, training, communication, management, oversight for quickly discovering of cyber attack, and then ethically containing the damage, eradication for attacker, presence and restoring integrity of network and system. That is the crucial. And we definitely, that is all of recommendation is not only, for example, a large organization, but is very useful for small, medium enterprises environment. And that is crucial. And thank you for your question.
Yes, we got another question in chat. I will read it from Mr. Uroš Benkic. He writes it, here where I work, we have free Azure just for ADFS sync, if I read right. Does everything applies to free version 2?
Yes, so, actually, does everything applies to the free version 2? Some version for some stage, some have commercial purpose, but definitely here we have free Azure just for AD Directory Federation service synchronization. Yes, that everything applies for the free version. Definitely. Thank you, Uroš, for question.
Thank
and
you.
Also you have, sorry, you must have gradation with subscription. For a different purpose, you must have a E3 license and you must have E5 license. That is the base for your Azure subscription model and everything in correspondence with your cloud service provider.
Okay, thank you very much again.
Thank you.
Yeah, so we came to the end of the first section, and now we can afford 15 minutes break to stretch a bit. We will continue at 11:15, so 11:15. Thank you very much and enjoy your break. Welcome. So we are ready to continue. There will be another 4 interesting speeches in this section, and the first among them is Mr. Matthias Luft from the company Astronomer. The main focus of his lecture will be ensuring security in the supply chain. Mr. Luft, the floor is yours. You can share your screen with us.
Thank you very much. Right.
Oh,
Can you
thank
tell
you.
me whether you can
Yeah,
see it?
we can see, yeah, thank you.
Perfect, amazing. Thank you for the introduction. Yeah, no big surprise there. My topic will be supply chain security. I'm very excited to be back. I'm still bummed out that I missed the in-person conference last year because I just in time caught COVID, so that traveling would not have been fun, but excited to be with you all again online here. Switching slides. Yeah, my name is Matthias Luft. I work for Astronomer. We provide a hosted data pipeline service. So I'm working in like cloud native security. I've been in security a long time, but you can read that later. That is not too interesting for you. So coming back to the title of my presentation is Rage Against the Software Machine, a critical look at the state of supply chain security. So in this presentation, I will give you a couple of rants and critical points on supply chain security and how we approach it today and what the potential challenges are. But no worries. Oh, I also did not change the date here. I changed it on the first slide. I will correct that later. But not to worry, I will not just rant, I will not just complain. There will also be a little bit of a constructive approach to supply chain security in the end. But in order to make my points, I will try to get all of you on board by pointing out a couple of funny, interesting, and raging facts about supply chain security. So what is a software supply chain? There is a very good project called SLSA. And they have this supply chain overview that I like a lot. You can see with the exclamation marks that they will give some additional guidance on the different threats that can occur in the parts of your supply chain, but I would just want to give you an overview. So in order to produce software that ends up being used by a consumer, you usually have a developer that develops source code. That source code gets checked into a source code management system. Usually from there, it gets built into a package, and then that package gets hosted in some type of artifactory from where the consumer can download it. So source code management system, for most people, it will be GitHub. There are hosted GitLab environments. There's like more enterprise Atlassian style solutions for that. Then we have many build systems these days. Circle.ci was just in the news. There's Jenkins, there's Drone AI, there's Travis. There's a couple of them available. Then package hosting solutions, it really depends on what you're hosting. There's Docker Hub, there's lots of container registry, there's the Python package index, there's NPM, all of those things. This is what we're referring here. Or you may have your own hosted version of like a JFrog artifactory or something like that. So this would be a nice and straightforward way. We would just need to make sure that our GitHub account is locked down. We need to make sure that our Circle.ci account is locked down and that there's no like unwanted permissions on our artifactory, right? And our supply chain would be somewhat secure. I'm not going to focus on all the network paths in between. I think there's enough talk about HTTPS and how to properly secure that. This is not our biggest issue in supply chain security. However, and here's the fun part, it's rarely that a developer just writes source code, which gets then shipped to the consumer. It's usually that there's lots of dependencies involved that get pulled into the account. So let's see how interactive the audience is. If you want to, you can type in a typical number of dependencies in like a, let's just say, medium size service that you would develop. I would say Node.js, since that always makes for entertaining examples. So let's see whether we have any takers. Otherwise, I will move on fast and talk a little bit more about why the dependencies are such an issue. Any ideas like how many dependencies get pulled in typical projects? All right, no takers. So I've seen JavaScript projects, larger ones with literally 100,000 dependencies. So these were all JavaScript libraries that got pulled in the build process. So the problem is we don't only need to secure this whole chain. The problem is we need to do this for 100,000 other chains. And that is the big problem with supply chain security. And I'm pretty sure you're all aware from that, of that, but I wanted to make sure we have a shared understanding here. So when we talk about this, there are actually interesting challenges out there when you pull in additional dependencies into your project here. So one example that I pulled in that I wanted to show here is the example of Kafka. So those are screenshots from Docker Hub. If you want to use a Kafka container and want to run this, if you search for Kafka these days on Docker Hub, you find this top example here, which is by Bitnami. That's like a packaged software provider. And yeah, it is a quite common tool, right? So, and this image has 600 stars. A couple of years ago, when you searched for Kafka, the top result that you got back was actually this guy here, Wurstmeister/Kafka. I know there's a lot of like German heritage or German language knowledge going on in Slovenia, but Wurstmeister in English means sausage master in German. So this is the stuff that was being pulled into enterprise environments a couple of years ago. And you can still see, because this container still has a considerably higher number of stars compared to the officially published image. So this is the fun that we need to deal with. Like, how do we know what's in this image? How do we make sure that's the image we want to use? How do we know it's like updated? See, this one was last updated 8 months ago. This one was last updated 4 days ago. So there's obviously already some type of equality difference. But still, this image has way more stars than the top one. Docker Hub seems to be accounting for that, since this is now the top search result. But yeah, still an interesting fact. Another fun thing, the first time I gave this presentation was on an event by British Telecom. So I just like looked stuff up a little bit, and when you go to github.com/British Telecom, you find this account. Luckily, they do not have any public repositories, but if they would have repositories, you might be tempted to just use code from there, because after all, it's British Telecom, right? The big problem with that, you have no idea to know whether this is British Telecom or not, especially with an account like that. So there's a good chance that British Telecom just reserved this account, so nobody else would grab that and do what I just described, but we don't really know, right? And even if you do everything the right way, and I put my company as an example because obviously I'm biased that this is the right way, here you have a little bit of a chance to verify that this is actually the Astronomer account. So we have a verified tag here. That means we went through a registration process with GitHub. We also link to our website, astronomer.io. And on astronomer.io, we link back to GitHub. So you have a little bit of a small web of trust there that we can follow around. So these are the challenges that we have. Basically, the challenge is we have no idea where stuff is coming from. Yeah, I mean, you were not super interactive, but maybe this one's better. I already saw someone wrote about Log4j in the chat. It's an amazing example for a supply chain issue that we're still dealing with, that many environments are still dealing with. However, supply chain security is probably one of the hottest topics, like the last 12 to 24 months, I'd say. So do you have any terms in mind that were thrown at you in the context of supply chain security? You can mention anything. Otherwise, I have a little bit of a list already here hidden, but I'm pretty sure if you mention anything, it will be on this list. Yes, it was a few buzzwords that were quite heavily promoted. No takers, maybe not even the chat open. But so these are a couple of the things that get offered to us, or that I hear very often when talking about the supply chain security. So SBOMs, software bill of material, were one of the big ones. You have container scanners. Pretty sure all of you have heard of container scanners, right? You have container security metrics. That's like a shorter topic. Then we have image and code signing. Then we have a couple of examples here for container scanners or dependency scanners. We have dynamic analysis tools or static analysis tools for code that is getting used. So we will talk about a couple of those and why they don't really help us with those challenges that we don't even really know where stuff is coming from for a vast majority of dependencies. So looking first at container scanners, I spend a lot of time on those since they just provide a lot of like fun results that you have to deal with. So container scanners basically scan containers for known vulnerabilities. It depends on the scanner what they are actually doing. Some do only the operating system package manager and go through the packages that are installed in the distribution. Some also look for application level dependencies, and then they look for well-known files or for well-known directories. So that's basically what they do. And that is already a little bit disappointing, because most of them, if you add any like statically compiled software or add a package manually outside of those mechanisms, they don't really find it. I saw this meme flying by, and it works amazingly for SBOMs, but it can be just as well applied to container scanners. So it's really just a little bit of regular expressions and crap. So the results that you're getting, they are tricky. You need to know what they are returning to. So I had a look at some of those. So basically one of our images basically returned this result. There were 13 critical vulnerabilities in there, and in total, like a high number of vulnerabilities, and 232 of those were fixable. So that means you could have just applied an update, right? So I was looking into that, and we got those metrics played back to us by customers a lot of the time. So they're like, oh, you have many vulnerabilities. You need to take care of that. Why is that? You run such a poor security operation. So of course I took that personal. And I was digging in that, and I was saying, okay, like, this was fixed in version 0:0. No idea what that meant. So I started looking around. Nobody knew what it meant. That was the first interesting one. After looking around quite a bit of it, this was actually a bug in the Claire. The container scanner was Claire, and there were a couple of GitHub issues open that described this behavior and where it was coming from. So it was basically a bug in how the Debian vulnerability feed was being published and handled, and then how this could be passed, and it was very messy. So after I looked into that and was okay, this is basically a false positive, I looked a little bit further into the quality of the vulnerability feed. And since then, I really can't recommend Debian as a very good distribution anymore, because the Debian OVAL database, there's a lot of like outdated stuff going on. For example, it's still running an unsupported version of Python in the meantime. And then you have also Debian maintainers, and that was very interesting. There was actually a valid vulnerability that could have been fixed in the meantime, but the maintainer unfortunately muted the mailing list that emailed the information about the fix to them. So the package maintainer kind of like ignored the vulnerability notification. So that was all a big mess, and that was all a container scanner. And a lot of people just use those container scanners and rely on those, but they have no idea what's going on there. So there's a lot to unpack there. A, you need to dig into container scanners, what they actually provide to you, and understand the results. And B, you really want to look at the distribution you are using. Based on that, you also have dependency scanners. Dependency scanners, Sneak is probably the most known commercial product. A lot of other tools offer that as well. Trivi has a dependency scanning component. There's lots of language specific ones. The Go modules have now an audit feature. There's NPM audit and all those things that give you results for your package level vulnerabilities. And they give you a lot of results. If you have some of those projects, a JavaScript project with like thousands of dependencies, you get dozens of vulnerability notifications. So sounds bad, right? But just as like with the operating system level vulnerabilities, we didn't even go into that, but all of that applies to operating system packages as well. But even more so for application level vulnerabilities, a lot of those vulnerabilities will not apply to you. So here is a very, very good talk that basically confirms what I'm about to tell you, but I want to tell you my personal story around that. But there's a Google and Stripe large data set analysis on what I'm telling you. So, but I'm still telling you my story. But if you need more confirmation, that's an excellent presentation that you should watch. So when I was at Heroku, container hosting services for millions of containers. I was triaging Heroku's sneak results for 1 year. And within that year, I did not find a single critical or high vulnerability. I triaged the high and critical ones. There was no way to triage all of it that actually affected us, because we either did not use the vulnerable configuration, we did not use the code path that was actually vulnerable, we did not, or we had another compensating or hardening control in place. So really none of those vulnerabilities affected us. And here's the interesting part. In this talk, they say, hey, if you apply all the updates immediately, that's nice. You're staying up to date. It's like good maintenance practice. However, A, the vulnerabilities usually don't affect you. And B, if we have a supply chain incident and one of those packages in your supply chains got backdoored, then you will just pull it in faster. If it gets backdoored now and you update every day, you pull it in before it's potentially getting detected. And we actually had that being 2 times the case during the year that I triaged stuff. So I'm not saying don't update your packages. That's certainly not the message I want to convey here. But again, you need to look at it in a little bit in a more distinguished way and make your own plan for it. So when we're talking about vulnerability information for dependencies, there is one promising approach out there. That's the vulnerability exploitability exchange. And that basically, you can publish that with your SBOM for your component. And then if there is a vulnerability in a dependency that you are using, you can state in your SBOM whether your application or whether your library is affected by that vulnerability because you used that code path or not. Problem is, the maintainers of software, they of course have a little bit of an incentive to state that they are not affected, right? Because they still want to have like software with a good security footprint. If the security researcher finding the vulnerability would be reporting it, they would have a little bit of a different incentive, because they of course want that software is effective, because then their finding is more relevant. So there's a little bit of a trust issue that we still have to solve, but I really like this approach. So when SBOMs become a more reliable tool, this is definitely something to keep an eye out for. And this might help with this flood of unusable alerts that you are getting. So since we have all those amazing metrics, we have container scanners, we have dependency scanners, and all of those give us results, right? And then some companies get the idea, oh, well, we have those results. Let's just make it a 0 vulnerability tolerance for high or critical findings. Nothing can get done unless there's no critical or high vulnerabilities in there. And this is very tricky. This is certainly a good idea on paper. It sounds good. We don't want any vulnerabilities in our code. However, as I just pointed out, a lot of those, they don't really affect us. They are somewhere laying around in our image, in our code base, but there's no way to exploit them because the code is not used. And this is the problem. Then you have to spend a lot of time on patching and just constantly working on stuff and so on and so on. And that takes time away from more important security efforts, for example, or engineering efforts. So this is definitely a consideration that you need to make. It's a very easy metric, but I don't think it's a good one. I don't have a great example yet, but a great solution that is just off the shelf applicable, but we will talk about that in my conclusion. Then I talked about software bill of materials. Software bill of materials is basically a list about your component that lists all the dependencies that you are pulling into your component. So if I write a service, I list all the other libraries that I am using. Great idea. And I think everybody should strive doing that. But current tooling and the current maturity and the current availability of SBOMs is very limited still. The point is that I think it's clear that a developer of software needs to create this SBOM in the build process. There's a lot of tools out there, and this is where my criticism is coming from. There's a lot of tools out there that says, oh, show us your container image and we create the software bill of material for it. So they basically just pass everything that's in your image and then create the SBOM for you. And that is just like with the container scanners. It is just very difficult to do in hindsight. And there's a couple of examples, a couple of funny ones, why this is a bad idea. You can read up on that. This was going so much that the US government was actually requiring SBOMs from all vendors that were delivering software to any US government institution. And then the vendors like basically had like an interest committee, and they basically submitted a letter of something that said, hey, please don't make us use SBOM. It is way too premature. The tooling is not there. It's just not the time yet. So this is also a good example of the current state of SBOMs. It's of course something that sells nicely and you will hear a lot about it, but again, just understand what it can help with. And that's the point. An SBOM itself doesn't do anything for you yet. It just gives you a list of stuff and you can use that to apply your own security processes to. Just because an SBOM exists, that doesn't secure anything. That's also something you need to keep in mind. And so basic that I almost forgot about that. So then there's the great example of signing everything. It's basically, yeah, just put signatures, cryptographic signatures on every step in the build process in here. Developer signs their commit, the build system signs their created package. The signature is then included in the Artifactory and the consumer can validate all the signatures. Of course, the dependencies are also all signed and we know everything, right? That's a great idea. However, the problem is not signing everything. The problem is key management and verifying signatures. If we think back to the Kafka package from the beginning, if the sausage master guy had put a signature on that container, how would that help us? It doesn't help us anything. We still have no idea who sausage master at googlemail.com is. No idea. Doesn't help us anything. So just saying sign everything, that's often advice that is given, but you need to look at your supply chain and understand whether it's actually helping you. If your supply chain that you're offering to customers is basically, hey, look, here is my supply chain documented, and here are all the security measures I take along the way, and then you download my software package from this HTTPS URL, you probably don't gain that much from a signature. Also, there were a couple of examples. There was a very popular Windows tool that was backdoored, and that was properly signed because they just injected their code in the build process. So signatures can be a great thing, but you need to apply them very carefully and you need to look at them in a whole context of things. So basically, this is what we would need instead of all the stuff that we got. So we would need to make sure that there's an uncompromised developer workstation. There's an uncompromised source code management, CI system, Artifactory, uncompromised transport. I already said it's a bit of a solved problem. And then you also need to make sure that all of this is also true for all the dependencies. And that's the actual problem that we're having. And that is very, very hard to do. However, as long as a software provider doesn't really document all of that and publishes it to its customers, it's very hard to rely on anything, despite of all the fancy tools that are being sold to us. So these are the criticisms that I have. This is what we would need. And here's a short recap on basically what we got instead, like very outdated and broken functionality in all the tools that are being offered to us. So let's see what we can do here. I often get asked, yeah, but then maybe we should just not allow external dependencies and manually verify all the dependencies that we are having. That would, of course, be the conclusion if you want to make sure that you don't pull in any malicious code. The problem is, if you do that, you will be out of business soon. Everybody these days is relying massively on external dependencies. And if you're not using them, your development will just be way too slow. That's the problem. You will be at such a competitive disadvantage. Yeah, you won't be able to make ends meet. It just won't work. So the good thing is, supply chain attacks, of course, will affect the bigger players, because if there would be a very targeted supply chain attack, I think it would be very, very hard to defend against that. There were examples where people injected code into packages where they just posed as a legitimate contributor. They actually submitted bug fixes and everything for a couple of months. And then after a couple of months, they made like one more commit that got merged because the developer was known. And that's just a little bit how open source works. That's a problem that we are having. However, if we're talking about untargeted supply chain issues and vulnerabilities in packages, I think there's a lot that we can do. And I would absolutely urge you to start with documenting and understanding your supply chain. There's a nice framework for doing that. And once you have documented that, I would also recommend to challenge your documentation. And that is pretty easy. There will be something popping up. Let's hope it won't be on a scale as Log4j, but some vulnerability will pop up. And then you think, oh, this could affect me. And then you can challenge your documentation and reaction capabilities by determining, do I know whether I used that package? Do I know where I used that package? Do I know who I need to ping to update that package? And how fast can they update that package? And if anything in that process you came up short with, you go back to documenting and reacting and so on and on. Of course, you also want to invest in strong patch management processes. That would be a whole different topic for another presentation. But when you've done all this groundwork, then you can decide, okay, what tools would actually help me in achieving all of that. That's it for me. I have a little bit more of a step-by-step approach of what I just said on this slide. There's a couple of like sources in the end, like of good or not so good advice that can serve as a bad example. And yeah, I think it's perfect for having now 4 minutes for questions. Thank you very much.
Thank you very much, Mr. Luft. There is some comments in chat from Mr. Spohn and from Mr.
Yes.
Very hard to pronounce for me, Leventopoulos. Maybe you can
that's right. You pronounce it correctly.
Yeah, thank you.
So exactly, yeah, I can understand what Matthias said, and I completely agree. I would also add that it will be useful for every company to check what is applicable to its DNA. Now we are creating bundle solutions, and everyone, as Matthias pointed out, try to follow the stream and implement something, even if it's not that applicable to their specific cases. And also, we have then the problem of the hardware. And as was correctly pointed, you need a non-compromise workstation for the developer. You need a non-compromise infrastructure for the development. And when I was at the NATO, we took a lot of care in order to understand whether the desktop computer was emitting RF signals. And we had the specific case where we were putting the desktop computer, we're running tests for around a week or so in order to understand that nothing is emitted from the computer. And this was back in 2005. So you can understand that the same problems are there and we need to deal with. So thanks, Matthias, for a very interesting presentation. And I think that we need to see very, very closely to that.
Yeah, I mean, and the problems that I pointed out, they are just even more difficult on the hardware side of things. I'm not qualified to talk about that, but I imagine that to be even more difficult. Also, if you're working for someone like NATO or like someone like super high security clearances, you would potentially need to apply a more strict approach. That's why I pointed out a little bit. If you are a target for a very targeted supply chain attack, you need to apply different approaches. But if you're not super worried about very targeted attacks that directly want to get all of your things, you can start the way I pointed out in a very good cost-benefit ratio. But that is a very important differentiation as well.
Thank you. Maybe another questions from other participants? If yes, just put in chat or maybe raise your hand. Otherwise, thank you again, Mr. Luft, and I hope see you in September.
Yeah, right.
This year.
Crossing
Okay.
fingers.
And
Thank you very much.
Yeah, we welcome. Mr. Leventopoulos is also our next speaker. The title of his speech is Retaliation within the Scope of Cybersecurity. So, Mr. Leventopoulos, if you are ready, yeah, we already see your screen, so the floor is yours.
Okay, thank you very much. Thank you for the invitation. Good morning from Greece to everyone. So today we will discuss a little bit about retaliation within the scope of cybersecurity. I know that it's a heavy word to say retaliation in the international law and all these concepts, but for sure it's something that it's there, and it's something that will take the lead in the next years. So moving forward a little bit about me, I'm an ex-military. I have 25 years of, I had 25 years of service. I was Chief Information Security Officer in the various military units. I was also a planning officer, again for various military units, specified mostly in air defense. I was a domain site administrator at NATO. And during my 2 years of civilian life, I was a senior information security consultant at Netcompany Introsoft, a consultant at Leventopoulos, a startup based in Greece. And now I have founded a new company, and we will deal with two pillars. One is cybersecurity, and the other one is how civilian and military sector can work together in order to create cutting-edge technology. So I don't know how many of you have seen the video. It's in YouTube, it's free, it's there, regarding the Aurora generator test. They created a couple of lines of code. It was a malware, and they reached out to the physical world, and they completely destroyed the generator. It's quite impressive if you will see it. That was back in 2007. In 2007, again, we had the DDoS attacks in Estonia. Estonia asked back then for the invocation of Article 5 of NATO. This means that all the NATO should go and defend Estonia. It was not accepted during that period. In 2010, we have the Stuxnet malware, and there are numerous examples of how attacks in cyberspace can reach out in the physical world, can remove the ability to track targets, remove the ability for communicating with the units, and all of these things. And of course, we have the Russian-Ukrainian war, and we've seen very targeted and very sophisticated attacks incorporating kinetic attacks. We've seen cruise missiles hitting data centers within Ukraine. We've seen extensive electronic warfare happening in Ukraine. So we are in the beginning of facing a reality that deals with cyberspace, cyber warfare, offensive and defensive operations. So a little bit to put the context within for the international law. There are some specific sources of international law, which when we say sources of international law, we mean where you can read the law or where you can have an opinion about the law. The most effective and the one with the greatest power is United Nations Security Council. It's one of the most powerful organs within the United Nations ecosystem, and it's the only one that has the ability and authority to issue binding resolutions to its member states. The problem here is that you need consensus. So in order to achieve consensus, you need most of the countries or all the countries to accept the resolution proposed by the Security Council. The second part is the International Court of Justice, which also creates binding binding resolutions and has also advisory opinion in a great deal of matters. And it's the professional opinions of the International Court of Justice that are one of the primary source of international law. When you have a resolution, when you have a decision from the International Court of Justice, this it's actually like something that you need to follow. You don't have to revisit the same issue again and again. The next part of international law mostly deals with aggression, mostly deals with warfare. So we have two, let's say, subcategories within the international law ecosystem. The first one is jus in bello. It's also known as international humanitarian law and govern how warfare is or should be conducted. So its main purpose is to limit the suffering cause of war, because Article 51 of the United Nations Charter clearly states that while you should refrain from war or the threat of resolving to aggression, you still have the possibility for individual or collective self-defense if an armed attack occurs. So here's a little bit tricky part, because it uses the word armed. And usually in cyber, we don't have that armed portion of an attack. The second part, it's jus ad bellum. It's when you have the right to go to war. And there are some basic principles that you need to follow, like proper authority and public declaration. You need just cause. You need to consider the probability of success, whether you have or not any means necessary in order to success to your strategic objectives. Otherwise, you are creating unnecessary suffering. And also, it's the last resort. So you resort to war or to aggression only when all the rest of the means that you have in your arsenal will fail, like diplomatic solution, for example. So a little bit about warfare and war. Warfare actually is how you're conducting war, is the mechanism, the method, the modalities of an armed conflict, while war is an intense armed conflict between states and etc. We can say safely that war is like a behavioral modification. For example, you will resort to war in order to convince your opponent to accept terms that otherwise he would be reluctant or he will deny to follow. In order to have a complete understanding of the warfare, you need to take a little bit the picture there. You need the strategic objectives. You need to have clear strategic objective. For example, during the World War II and the Operation Barbarossa, the Nazi Germany were invaded Russia. The objective was, we will stop somewhere in the Ural Mountains, and then we will see what we will do. This is not a correct approach and creates a lot of more problems that solutions that perhaps it will give. So, what is cyber warfare? As a concept, it's still a little bit debatable. Some people say, no, it's just cyber attacks, it's just hacking. It's just something that we've seen, and it cannot be similar to a, let's say, conventional warfare. The truth is that we've seen that we are moving towards a cyber warfare, and cyber warfare, it doesn't need to be, let's say, only with cyber attacks. You can use also kinetic attacks in order to attack infrastructure that holds all the necessary machinery and systems that supports your cyberspace operations. So there are some issues that you need to consider. when you are resolving to cyber warfare or when you are discussing about cyber warfare. The first one is state responsibility. So you need to have a very well understanding about who is responsible and whether it's a state. You can launch a cyber warfare against an individual. And here is also the tricky part when we are discussing the hack back or the ability for companies or organizations to retaliate in cyberspace when they had, for example, a hack or they were subject of a ransomware attack or similar. The second one is arm attack. Here is also the tricky part that we said earlier, because we don't see armed, it's all digital form, but we have a resolution from the International Court of Justice that said any weapon, even if it's a digital one, can be identified as an arm. So this resolution, this decision from the International Court of Justice actually clear a bit the fog regarding arm attack. So we can identify cyber warfare as an arm attack. Then we have the principle of non-intervention. You shouldn't intervene in the internal matters of a state as a cyber warfare. Also, you need to take care about the severity. We need to clear here that while cyberspace is like international waters, no entity in the world can claim ownership of cyberspace, we do have a very physical infrastructure. And when that infrastructure resides in a state, then this infrastructure and the data contained in it are sovereignty of that particular state. So this principle should be also taken care. The next one is proportionality. You can't launch a nuclear attack because you had a ransomware in your company. So you need also to measure your answer, your retaliatory action against the initial attack. You need to be very careful not to retaliate or overcome some threshold. And finally, it's the attribution. This is the most challenging issue when we are talking about cyber warfare. If the opponent, if the attacker will take all the necessary measures and will implement certain parts in his code, in the malware and all these things, it will be almost impossible to understand or to attribute the attack to a certain entity or a certain state. We have this tungsten example. After all these years, we'll still don't know for sure. We are not 100% sure whether it was the Israelis or United States or Israelis and United States and all these things. Also, we have the example of the Olympic destroyer, for which was launched during the 2010 Winter Olympic Games in Seoul, and every researcher attribute the attack to a different entity. So again, we need to be very, very careful when we are discussing and when we are trying to attribute an attack to somebody. So war, again, is a form of behavioral modification. We have two strategies in warfare. One is annihilation and the other one is of attrition. But what can we do in order to don't go to war? So the best thing is deterrence. And the deterrence theory starts with the Peloponnesian War. It's almost 2,500 years ago. We have the classical deterrence theory, and it was a concept that became very, very popular during the Cold War, when we had mutual assured destruction, where all the opponents that had nuclear weapons were assuredly be destructed in a case of a nuclear war. And this also introduced the retaliation or reprisals within the concept of international law. I need to threads out here that retaliation is not an easy word, and it's not a concept that is easily accepted or widely accepted in the international law. It's you won't find any mention in the international law regarding retaliation, but it is an acceptable concept, and all or most of the deterrence theories or deterrence approaches that are there in the States, they have some form of retaliatory action. So when we are discussing about a retaliatory deterrence in cyberspace, what we need to take into account, first of all, is attribution. It's a very difficult concept, a very difficult project to go on and to attribute a cyber attack. When we have a kinetic attack, then it's a little bit easier. You need to be very, very careful in order to identify the capacity to answer. First of all, it's knowing yourself, as Sun Tzu said. You need to be very, very certain that you have the capacity to retaliate in the cyberspace. And also you need to be very certain that the opponent has the capacity to understand your attack. For example, if there is a country that's not dependent upon digital form or digital governance, then it's probably more, let's say, secure than Estonia, for example, that it has a very extensive digital governance running there. The other thing that you need to take care and to take into account is the thresholds. First of all, it is difficult to convince someone that you need to retaliate when actually no one is suffering and no one is dying. You have only monetary losses. So it's very, very difficult for a state to go and say, yeah, I will retaliate when no one is dying, when we don't have such physical damages and all these things. Also, you need to understand that after a while, perhaps it will be unwise to continue to retaliate or try to retaliate. The second one is the ability to punish. Here you need to understand which weapon, let's say, you will use. You will use a cyber weapon, or you will use a kinetic attack in order to retaliate something. And finally, it's the proportionality issue. You can have an extensive retaliatory action because this will be perhaps leads to counter retaliation, or it will be an escalation that you don't want in the first place. So having the strategic objectives and the strategic goals that we said earlier, it's very, very important in order to understand the proportionality and the threshold issue. So what can we do in order to deter in cyberspace? The concept still remains elusive. During the Cold War and the nuclear arms race, it was something that was considered a little bit straightforward. What we need to have in mind is that cyber deterrence should be repeatable. So if new malware or new security measures, all of these things are introduced every day, then you need to adapt and to create new ways, new weapons, or new approaches. And also should be symmetric. Symmetric means that it should be directed against states and not individuals. You can't go with states and you will say, I will retaliate this group or this ATP because they shut down the country for a couple of days. Even if it's not easy for an individual to do something like that. So we can identify three cases. The first one is to retaliate with a cyber attack against a cyber attack. This is quite easy because you have, let's say, a cyber attack. You have the challenge, of course, of attribution. Perhaps you won't be able to attribute it at the fullest, at 100%, but you can have indications that a certain entity, a certain country had launched the attack, because you need a country side, let's say country level infrastructure in order to be able to shut down a whole country. Again, the thresholds, it will be something very challenging in order to convince the international community that while no one is dying, there is no suffering, this should stop, and the only way to stop it was via cyber attack. Again, the ability to punish also is to take into account. You need to, first of all, you need to be able to understand that you are under attack, and the second one is to have all the necessary, let's say, infrastructure in place. You need to have the people, you need to have the roles, you need to have the command structure in order to launch a cyber attack. And the final issue that you need to take care is proportionality. Again, cyber attack will help you in order to be proportionate enough to the initial attack, because again, we don't have the suffering, so the opponent will not have extensive suffering. It's something that you can go under the radar if you want against your opponent. You can have also issue safeguards and countermeasures in your cyber weapons, as to also create difficulty for your opponent to attribute this attack to you, but also it can be very loud. It can create, havoc, can create headlines. So again, you can have that. You have this ability with a cyber attack. The second scenario is when you can retaliate with a cyber attack against a kinetic attack. This is the most, let's say, straightforward scenario, because kinetic attack will have the suffering. It's easy attribute to a certain state. The proportionality, it's way better when you will retaliate with cyber attack. In fact, we had some information at the NATO that cyber attack should be the, let's say, weapon of choice, due to the less harm that it will create, the less pain, the less suffering. And it's perhaps it will be a question why, when you could use a cyber attack, you didn't implement it to answer a kinetic attack. The final and most difficult, and something that you need to take a decision up to a highest level, is when you need to answer a cyber attack with a kinetic attack. If we will take the example of Estonia, and let's say that Estonia is a little bit bigger and has a little bit more military capabilities, long or deep strike capabilities and all these things, it could be an answer when you can target very specific infrastructure as to stop the cyber attack. At this case, of course, you have the issues of attribution, you have the issues of proportionality. Proportionality is off the chart here, and this should be a scenario that you need to consider it very, very well. So, some final considerations. We can say, I've presented this slide also into the Integrated Air and Missile Defense Conference last year. The first bullet, the nuclear deterrence in 21st century, it was the one that created the most, let's say, debate. But we can say that we are moving forward. We are moving towards a similar concept like nuclear deterrence. The second part is that you do have some advantages when you will implement retaliatory actions within the cyberspace. No suffering. It can be extremely, extremely targeted, like Stuxnet demonstrated. You have no pain and you have limited physical damages. The thing is that we have limited to no legal framework. We have only one resolution from the International Court of Justice, and that's it. Tallinn Manual is a great, let's say, effort, but it's not complete and it's not within the sources of international law. So it's not applicable. And in fact, there are many objections about what it's mentioned within the challenge manual from countries, except Russia and China, which they were never invited to give an opinion about international law, but also from countries like Brazil and India that were also not invited for their opinion. Another issue is that we have no global standards within cyberspace. We've seen a lot of different standards out there. We have NIST, for example, we have ISO. There is no standardization in cyberspace, and this may create additional challenges. Attribution will be a nightmare, so you need to be very well prepared in order to have all the necessary measures there, so all the necessary sensors and all the things that we will start collecting data early from early in the attack as the attack unfolds. And finally, perhaps it will be in the future the weapon of choice due to all the advantages and all the things that we have already mentioned. So two final thoughts. The first one is that retaliation is not incident response. Perhaps you can implement some parts of incident response or disaster recovery, but it's not an incident response. Retaliation, you need to have the means, you need to demonstrate the means, and you need to demonstrate your will to implement them when some thresholds will be passed, will be crossed. And there is also, we can discuss a lot whether cyber retaliation will be applicable to companies or private sector or public sector. But I think that this is a discussion for perhaps the next conference live in Slovenia. So I think we have also 4 minutes almost. So I thank you again for the invitation. Thank you for watching the presentation. And if you have any question, I will be more than willing to discuss it.
Thank you very much, Mr. Leventopoulos. Are there any questions? There is one comment in chat from Mr. Spohn. Maybe you have something to add? Any other participants with questions? Maybe one question from me. I'm not from this area, but I was thinking, what is your opinion? How important or how applicable is the artificial intelligence in performing cyber warfare? Are these approaches frequently used nowadays, or more classical methods are still dominant in this area?
Yes, well, artificial intelligence is something that we start understanding what it can do and what it can't do.
But we are scary, a bit scary.
Indeed, we do have a little bit of hype within artificial intelligence. You need, for example, if you need to, for an effective artificial intelligence program to run, you need to have the data set, and you need to have the annotated data set in order to be trained well. If you don't have the data set, then, or if you will miss a large portion of the data set, then you won't have an effective AI program of AI concept. So this is the first one. The second one is that we see that we can manipulate easily people opinion. We can create chatbots that look like people. We can create people that are, artificial people that look like real people. So because cyber warfare is not only about cyber attacks or about kinetic attacks, cruise missiles flying, it's also about disinformation campaigns. It's also about misinformation campaigns. Then that is the tricky part. And I don't know, perhaps we need to implement internationally some form of watermark, so everybody will know that this has been created through or via AI, or perhaps we need to train, let's say, to create a culture, because you won't believe something if you are not ready or if you are not willing to believe it. And right now we live in an era where we are ready to believe everything because it's on the internet. We are using internet like the university. And while this is true, there's also a lot of noise, let's say, in internet. So yeah, okay. It's a brave new world out there.
Yeah. So awareness would be very important also in this area.
Exactly.
One comment is in chat from Mr. Spohn. Maybe Mr. Spohn, who is our next speaker, maybe you can,
Okay, good afternoon all. I can just quickly comment on this one, what I typed. I like the presentation, really good introduction and what will come next, and fair points on all the legal perspectives as well as the analysis and attribution. The main concern, I think, at the moment, and it might be controversial, but we have to be honest. We cannot point at others and say they can't do certain things and we keep doing it. It's like espionage in warfare for now hundreds of years. It is tolerated. It's of course not welcome. It's not liked, but there's nothing really we can do. And as long as one nation will spy, another nation basically or entity will do the same thing. And in cyber, it's the same. The West cannot be talking about like active persistence or forward presence or whatever else you want to do, or call it active defense, and at the same time tell others, no, this is not what you should do, this is not ethical, and this is not welcome by us. So just to highlight what our speaker said, very true, and we need to be all acting and basically performing at the same level.
Yeah, exactly. I completely agree.
Okay, thank you very much, Mr. Leventopoulos again. And I would like to invite our next speaker, Mr. Spohn. The topic of his presentation will be quite related to the topic of the last presentation. The title of the presentation is Cyberconflict in Ukraine. So Mr. Spohn, I don't know if I pronounce correct your surname, but the floor is yours.
Perfect pronunciation. Thanks a lot. And thanks for having me. So I hope you can see the screen.
Yes, we see. Thank you.
Thanks for having me back. First of all, a little bit on the background. I don't have a slide on it because, as some speakers said, it's not really important. Former ex-military, ex-German Air Force officer. Now I'm working for NATO as a NATO civilian in securing the cyberspace of NATO. And the next slide is dear to my heart because this topic, of course, the Ukraine conflict is dear to many people, and some nations and their inhabitants, I believe, in chat here and in the conference are a little bit closer to the problem than we are at the moment in Belgium. Not saying it is not a problem for us, but you know what I mean politically. So I don't want to cause any disturbance. I'm quite straightforward. I question a little bit some of the, as it was stated earlier, the current beliefs. I do not trust everything that is reported either in the media or the internet. Like the previous speaker said, you need to be very, very careful. And he did a huge favor because he mentioned in the end some of the things I will pick up. This is, of course, not NATO's opinion and the statement on what we believe in the official statement. So this is based on current events, mostly based on open source information and intelligence and the assessments of the information. Of course, some people might be controversial and say this is not true or we see this differently. But at the moment, we have to be honest, a lot of the points and a lot of the indications that we see point to conclusions we have in the slide. And I made the mistake, I used conclusions. That's why I say we have lessons identified. If we learn them, it's basically up to us and all to the individuals that we have in our companies and organizations and maybe governments. So I tried not to take sides, but have to report on a few things, and some of them are really impressive in their activity. And with that, I lead over and want to say, what are we talking about? First of all, I want to be a little bit of a myth buster, which means what's real in the conflict and what actually is going on and what happened, because there's still a lot of misunderstanding, or a lot of people, unfortunately, are blind to some of the real events. We have a short background on the history of this. We go a little bit into the conflict details, and we have one special element in this, and these are the involved hacker groups, be nation state affiliate, nation state directed, or independently like hacktivists, and then we come to the lessons identified in the end. Now, to go a little bit into the maybe misunderstandings, or where media at the moment is not really transparent. A lot of people believe that nothing significant has happened in cyberspace in the conflict, apologies, in the last 10 months. And this is definitely not true. Why? I have, of course, details, but just to dispel that, this is not correct. A lot happened and a lot is still happening. And we will see. I don't dare to look out, but I believe cyber might be less of interest in the near future, just simply because of the physical consequences of the conflict. Also, the statement that Russia was not successful in their cyberspace efforts is unfortunately not true. They have been very successful, at least in the beginning. And then it came to the problem that the military couldn't keep up, the army couldn't keep up with the success story. So the two missions and the two directions basically diverted. And a lot of these cyber efforts had to step back and had to scale back into the scope of the campaign. Interestingly enough, this was reported now that since fall last year, this has been restored, and that now cyber activities are aligned with the conventional efforts on the battlefield. One example is all the energy attacks, especially since fall last year, that are now sometimes targeted in cyber first, and days to weeks later, conventional activities follow. So this leads to a couple assumptions. We come to that later, but to give you an idea, what I want to lead into is that either cyber doesn't achieve the result and then a missile or a conventional strike will. It is a little bit more brutal, because that, of course, is a destruction and there's nothing that you can regenerate, take over, or reuse. Or cyber just simply is no longer as successful as hoped. And then comes the conventional strike as a conclusion. It's a little bit more surgical, as our previous speaker said. If you know what you're doing and have the right access to the right system, it can contain some of the troubles you have with a physical strike. But of course, this assumes we still have an infrastructure, we still have a attack vector, we still have a tool in place, and you can even access your target environments. Now, as mentioned in the last couple of slides in the previous presentation, Russia is also part of a cyber confrontation, because it's part of their information confrontation doctrine and their effort. And this is really interesting, because a lot of the activities we need to understand in the bigger context. So let's move on. The idea of the activities that we have seen, there was no real use of 0 days, or is this the A game of future cyber warfare? The problem here is the 0 days might exist, the A game might have existed, but do you really burn all your access? Do you really burn all your sophisticated tools when you do not need to use them? Why there was maybe no need, I will come to in a minute. But the A game you reserve normally then for, as it was mentioned, scenarios like Stuxnet, SolarWinds in its technology and approach was amazing, NotPetya and some other activities. If I have a cheaper, easier and non-burning tool means of doing what I want to do, then I will use it and reserve the rest. Now, to explain where are we coming from in the conflict, the attack vectors and the related problems. We all know, maybe out of our younger days, or maybe of what our children's or kids in school do, you shouldn't use cracked software, not only because you violate laws and you basically spend money of a company that you haven't properly spent or legally spent, because those software tools are usually sometimes vulnerable. Sometimes they are already loaded with malware. Of course, I'm Captain Obvious here, but this is the case. It was used in the Ukraine and still is, which of course opens also easy entry doors for the adversary. It is harder to patch because you might not dare to go online with your tool and patch a piece of cracked software. You have the use of vulnerable software. Unfortunately, a lot of tools have been used which are known to be vulnerable compared to some other secure tools. Now, why? Don't ask me. I'm not in the official position over there to mention this. Maybe easier, maybe cheaper, maybe it was the tool they had available at the time. But in the meantime, with all the help they are getting, that needs to be or should have been shifted over. Best example is if you have Outlook Web Access, then you shouldn't use some other third-party, weaker, less sophisticated web access to your email environment. Lack of cyber hygiene, for example, improper use of USB policies and the security policies, overall a bad security policy implementation. And now we talk at the beginning of the conflict. It later changed with the move to the cloud, with moving assets into other countries, with basically all the countermeasures implemented through companies like Microsoft, Asset, Mandiant, or now Google, as well as others. Bad account management and identity compromise, and you can already see this all I reverse in lessons identified. We need to do all of this. Sometimes our organizations or even you privately are bad in doing this, which means that keeps you vulnerable. Phishing attacks, the lack of logging. We all heard of the multiple phishing campaigns, unfortunately very successful. Brings us back to the zero-day discussion. Why use 0 days if you have an attack vector of phishing and it still works? You need to keep logs. You need to understand at least what happens in your network and look for adverse behavior, which was mentioned earlier in some of the presentations. Monitor your cloud access. This is now true after you move to a cloud. You need to make sure that your conventional environment is no longer used and vulnerable and basically allowing the adversary just to follow into the clouds. For example, manage and keep an eye on the privileged accounts owning the cloud environment. Multi-factor authentication, lack of that, you know what this means, simple password and username, no longer cut it. And then, of course, advanced issues like session token reuse and some other problems. Now, interestingly enough, since the beginning of this year, people might have followed that, and General Gerasimov is actually leading now the Ukraine campaign from a Russian perspective. He is one of their most successful and most interesting generals. And to understand the information confrontation and how the Russians take this, we have to look back a couple of years and understand the Gerasimov doctrine, which he actually wrote, and see where we are. We are in an information confrontation that has the psychological, the technical, as well as all other aspects and elements. And this is what we see in a daily execution. Attack against media station, against press, against individuals, against the government, use of deep fakes, as we saw Zelensky asking the military to basically surrender and give up, which was a smart use of a deep fake. So there's a lot going on which is aimed at destabilizing the people, the trust, the government, their outreach. And to fully understand, we need to, some people, of course, go back to Sun Tzu, as it was mentioned earlier. Here, this is critical for understanding the Russians. What has he actually written in his doctrine? Now, the phases of the conflict, and this is going back to February last year. At the beginning, we saw a lot of the cyber recon and pre-positioning. This was happening, of course, way in advance of the conflict. The conflict goals in cyberspace, of course, are a simple espionage. What's going on there? What do I want to know? What can I know? What can I use for my campaign? Hack and leak. We see this a lot now also in recent ransomware campaigns. Unfortunately, if you don't want to pay a ransom, maybe some of the information that is taken is leaked to either prove you have been hacked or to embarrass you. This is also true for now the Ukrainian government officials, maybe some of the Western companies, Western governments, Western industries supporting this. So you see some of the threats spilling over into our direction. The destruction, of course, we talk about similar tools like Black Energy 2, attacks against infrastructure via cyberspace. Then, of course, the influence operations, as I mentioned, plus the others, all the unknowns you can maybe gain via cyber, or maybe at least try to. Now, phase 2 is the time of the invasion where we all saw the multiple Vipers. This is interesting because the Vipers basically destroyed data. It was a ransomware attack without ransom keys. So you encrypt the data and basically say, okay, that's it. Throw your data and your system away. You have to fully recover. Now, persistency in such an environment, this is interesting. If you ever wondered, where do you stay when you actually wipe out a system? The Russians are pretty good at the moment on edge infrastructure attacks, which means they sit on compromised either switches, smart routers, web servers, other entities that you haven't wiped. And from there, you just basically come back after the infrastructure recovers. Now, in the transition from phase 2 to 3 and beyond, we have the operational technology attacks, as we saw with the energy attacks, which lead to the support of or in leading into a conventional strike. Again, energy sector attacks or against state media, state news outlet to limit the outreach of the government. And the numbers of attacks in the Ukraine vary, but you see some studies point to multiple attacks per day against the Ukrainian CIS. So you see what either they or together now with Western support are up to when it comes to incidents and incident management. Now, once the conflict was in motion, and this is really interesting here, and I picked out one example further down. For the 6 to 9 months initially, the conflict and the cyber activities had been contained to the Ukraine. And a lot of the rest of the world and the West even realized a lot of less activities by Russian cyber actors in cyberspace. They had been focused, they had a goal, they had been needed, and most likely they had been kept busy. This has again changed because now the Russian actors picked up activities again. Best example in the last couple of days since we declared we are now delivering tanks and the next load of equipment, there are denial of service attacks, attempts to breach, hack and leak operations, etc. We have also potentially the assumption, I hinted at that, as a lot of infrastructure is destroyed, as a lot of infrastructure is defended now by Western companies, has moved into the cloud, like into the Microsoft cloud. Maybe the impact of cyber events and attacks went down, which means we have time to refocus and time to basically target other environments. Interesting was, and it has to be mentioned because this is the best example on media operations on both sides, the hacking of the Delta system. This was basically a command or is a command and control tool of the Ukrainian government provided by the US. And there had been successful breaches through phishing attacks, by the way, no 0-day needed. And on the Russian side of Kurt, you heard we had all the data. We now know what they are doing. We know what they have, where they have it. On the Western side, we heard this was limited access. They cut it down. They found it out quickly, and not much was revealed. Somewhere the truth is in the middle, as always. Now, really interesting is the discovery of the pipe dream malware kit. And I have this from the Dragos company. This is actually a complete toolkit, which poses a threat to operational technology and to the industrial control systems at large. And this thing is a real problem because it is very sophisticated, as far as we know at the moment, not deployed yet, not used actively, but it is highly capable. and people might know Metasploit or similar attack frameworks out of the normal environment. This is now focused on OT, and it shows basically where the journey in the future will go to, what really is at risk and at threat, and what sophisticated actors can and will do. Now, the issues during a conflict, and we come slowly to things we all need to consider, especially as a company, not really as an individual or as a military organization or international organization. You need to maintain situational awareness, and this is in conflict. Take also the Corona time when you have hundreds, thousands of people in the home office suddenly or no longer in your controlled environment. How do you maintain situational awareness? Are you prepared? You need to support local operations when movement or activities are limited. Again, the pandemic, war zone activities show you cannot just send out people, either pick up a hard disk for forensic investigation or go somewhere and physically deploy either new technologies, additional technologies, or physically recover systems. What about lack of critical resources? We all understand this in a different supply chain problem. Without water, without electricity, without food, you soon encounter real problems also for your staff maintaining the systems. What about an enemy overrun? Both sides claim we have gained access to critical information through the capture of military equipment, telephone grids, GSM nodes, TV stations, radio stations, etc. Really, really interesting that you have network segmentation and that you are prepared to basically cut off certain elements of your infrastructure. Lack of secure comms, network bandwidth, quality of service. You want to do something remotely. If your network doesn't support it, you have a problem. The trust in a remote system. When do you know, as it was mentioned earlier, with a database attack, that your system suddenly becomes a problem and is no longer your trusted asset? Rollout of new technology during a conflict. Multi-factor authentication, a real problem because this poses interesting issues. How do you get, for example, tokens to your customers? Management and use of social media. This is, of course, true for both sides. We, to be honest, and here I can speak for NATO and the national militaries, we both have the problems on we reveal too much information. You might even do this privately, and it's a separate presentation on the use of social media, AppSec, OSINT, etc. But the Russians, as well as the West, have problems on we give too much away, which then leads to AppSec and OSINT concerns. And again, this immediately is a lesson identify. We need to get better on both ends. Now, an interesting and controversial issue, and I don't know if anybody in the audience was lucky enough to attend Black Hat in Las Vegas last summer. It was mentioned by Kim Zetter, who writes for Wired, as well as some other famous papers. We at the moment are really, really happy, at least in the West, that we have so many hacker groups and hacktivists supporting the Ukraine. The problem is the Russians have similar groups. By the way, those are the ones now attacking us in the context of tank and other deliveries. But the numbers point at some around 200 different entities. Sometimes they might overlap, sometimes it might be script kiddies using denial of service tools. That doesn't really matter. We create at the moment a mindset which we already identified a couple of years ago when Anonymous became big, when LulzSec became big, that this can be a problem. At some point in time, the cyber or the Ukraine conflict overall will stop. It will cease to exist. Then what happens? What will those people do, especially after the barriers have been lowered and they might feel they lack something? Now we need another thrill. Where will this go to? We have enough other problems. We have a migrant problem. We have an energy problem. We have political problems. Do we see more hacktivism against our countries, against government entities, or because, as it was mentioned earlier, we retaliate because something that we do not like happens and now we take action? So as Mrs. Zetter said, we have to be careful on what we wish for, because this easily will spill over, will become a problem. And if we simply believe we put the lid on it and we contain, that will be, personal opinion, nearly impossible. That is no longer containable. Now on the lessons identified, to leave a couple minutes maybe for a question or a discussion, cyber hygiene. We all need to implement at least simple cyber hygiene measures. Like our speaker said earlier on the supply chain threat, you have certain simple activities which need to be there and they secure your network to 70, 80%. We should not, and this is a more advanced hint, build around still active domain controllers when you recover a network or CIS after a compromise, because you never know what is lurking on the domain controller. And I don't even talk about malware. This might even be a hostile account. And from there, the attack just continues. You need to be careful with the diversity of access. We need to monitor basically the whole network and understand what is happening. Again, take Corona, take this conflict. It is more and more difficult also with all the cloud presences, the interdependencies, which leads to the next one, the unconventional network design. If you know what you're doing, design your network unconventionally, because some of the attacks actually stopped because the malware in use didn't find a Microsoft-based network, lack of active domain controllers, for example, or Active Directory leads to certain issues for modern malware. You need to think of mitigation and mediation before any issues arise. Best example, again, Corona. You cannot send people home and then realize, oh, dang, they need IT and they need to have remote access securely. Threat hunting. If you don't do threat hunting, I know it's an industry buzzword, but you should actually look into threat hunting. Look for pre-positioned either entities or attack tools. Think outside the box. You need to protect everything that is important to you. And this is also including things that support your activity. As I said earlier with the supply chain problem, hardware as well as software, as well as logistical support. For example, in this context, IP cameras. IP cameras are cool when you have a perimeter defense control. Hopefully those IP cameras cannot be accessed by the internet, because you never know, somebody else might also be watching. Now the asset separation, as I said, you need to have a segregation of the network, and you need to be prepared to do this any time of the day in a conflict or in an issue. Now for the lessons identified, remember the people and your staff. Cyber attacks, multiple cyber attacks hitting always the same people will lead to a certain burnout. You need to make sure you are prepared on the resource as well as the morale aspect. You need to take the civilian sector along, because now cyber is owned and operated a lot by the civilian environment, especially in the West. We talk about cyber activities, remember to speak earlier on even the legal frameworks or the lack of legal frameworks. Now, what happens if your cyberspace that you need is basically operated by German Telecom, France Telecom, you name it? That creates dependencies and issues you need to consider. Develop a plan. Of course, I'm Captain Obvious again, ahead of time. You need to deal with a hack and leak operation. As many ransomware victims have figured out, plan ahead. Once you are hit and information is leaked, it is too late. And as I said earlier, we see a change in this since fall last year. There's a lot more happening in cyber, which is aligned with the kinetic efforts. Again, the theory might be cyber being more surgical. Kinetic is a one-time only attack and then it's done. And one of the lessons we have, why would you try to destroy something? Because in many cases, the Russians like to take over and like to take over functioning infrastructure. And so we have 2 or 3 minutes maybe for a question, and here I end, and hopefully you found it interesting. Thanks a lot.
Thank you. Thank you, Mr. Spohn. Are there any questions from the participants? Yes, thank you very much for your exciting talk and your amazing findings. If I'm honest, you scared me a bit. Maybe just one light question. What is the main motivation for other hacktivistic groups to involve this conflict? Is there money, or what do you think?
Some hacktivist groups, we have to be clear, are of course supported or motivated by their governments. Totally clear. The other side of the hacktivism is really patriotic feelings. You identify with the cause and you identify with what's happening. You want to make a statement like we all do in social media, me included. You have a problem, you see something, you are frustrated, at least in social media. In the past, it was mentioned in a talk over a beer in a bar. Now you can also do this on social media, which is part of the problem because some of the barriers disappear. The financial aspect is a good question. I'm not sure if some of the groups actually see finances. Maybe on the Russian side, there is a lot of assumptions that a lot of the groups operating, also cybercrime groups out of the government, are basically tolerated. And there's a backdoor, either the government can use them as needed, or even better, they are allowed to keep the money and the government just makes sure, you know what, do not act against Russia. And we allow you to stay here and to do things because it's actually also in our best interest. But I think a lot of the normal hacktivists are not money driven because there is not much money to be made. It's more also building your skill set, getting in touch with people, getting better. And this getting better is then the next problem because they are exchanging code, learning and studying. And then what do we do with this?
Okay, thank you. Thank you. Thank you again. And now we are came to the last lecture in this section. The presentation was prepared by Mr. Djoko Krstić from Zero Science Lab. Mr. Krstić is with us, as I see. Mr. Krstić will reveal to us the background of radio stations hacking. So we are ready for this another exciting experience. The floor is yours.
Thank you. Let me know when you can see my screen.
You can use the green button in the bottom of your screen.
Yeah.
Okay, perfect. We can see.
It works?
Yes, it works perfectly.
Thank you, Alenka, and good afternoon, everyone. Just want to say that I had a chance to view the previous presentations, and I can say that I agree, and it was really wonderfully presented and really cool stuff to see. So I'm happy about that. So thank you for that. Kudos for the presenters. So we can start. My name is Djoko Krstić. I'm originally from Macedonia, currently living in Netherlands. And today there's a short story I want to present about broadcasting and intrusion, specifically how, hacking radio stations, how that works, and the motivations, I guess, and the methodology used, and the conclusion, of course, the agenda for today. Know if it's working. Yeah. So currently, I'm the founder and chief information security engineer for Zero Science Lab, which is the Macedonian information security research and development laboratory. Previously, I was working for in the industrial cybersecurity field as a offensive security research engineer for applied risk, dealing with OT and industrial SCADA systems, penetration testing and consulting. Currently, I'm working as an offensive security research lead at the ING Bank in Netherlands, which also implies that I do training for red and blue security teams and doing regularly advanced penetration testing and security research on software and hardware included. And also, I've been doing this for 16 plus years within the cybersecurity field or industry, from automotive, aviation, entertainment, telecommunication, and I also used to work as a audio video engineer in the television network. So that's why this interest was born, to do more deeper dive in within this broadcast signal industry. This implies also it covers the video also, not just radio or sound or audio. Member of Gugutka group, which is a CTF group that we have found sometimes with our friends, and a cybernetics student, which is concerned with concepts at the core of understanding complex systems, like learning, cognition, adaptation, emergence, communication, and efficiency, something like that. So it's already learning still. So yeah, agenda, I'm going to introduce, and we're talking about a bit of what a radio is, what are the radio signals, frequencies, components within this IoT world, broadcast signal intrusion, some incidents, and the Zero Science Lab method, the conclusion and end of transmission. Brief history includes the, invention of radio from the Italian inventor Guglielmo Marconi in 1894, and then he demonstrated in 1895, developed and improved his system, and in 1905 he successfully transmitted the first transatlantic radio signal. Alexander Graham Bell, he's an American inventor and scientist, teacher of the deaf, also considered one of the pioneers because he developed the early version of the radio, which he called photophone, that used light waves to transmit sound. And you can check this out. I'm not gonna dive, although from scientific perspective, how that works. But there are YouTube videos to see how exactly that photophone works. Through light, you can send sounds, which is pretty cool for me. For broadcast types, there are several types of broadcast. The streaming or web broadcast, which is including internet radio, which allows listeners to stream audio over the internet. We know about this, and this is like trending. And because this is a focus on the IoT and industrial, or the IIoT sector in the cybersecurity field. We have the traditional AM and FM radio, which is traditional type of radio broadcasting that uses variation of radio wave to transmit sound on the carrier electrical signals. And FM is better than AM, as we know. This is just a short introduction. Then we have a satellite types of broadcasts and digital audio broadcasts. Satellite, which is subscription-based service that uses a network of satellites to transmit radio signals. HD radio is a digital technology that allows FM and AM stations to broadcast additional channels and data alongside their traditional analog signals. So basically, you can use analog and digital FM transmitters, but the source is that this is where I'm going to discuss more in details, where we managed to potentially own 107 stations, radio stations worldwide, globally, with a click of a button. You could have changed or hijacked that signal and play your own contents. There are, of course, other types of broadcasts like shortwave, terrestrial or digital radio mondial, which is DRM. That's a set of digital audio broadcasting technologies designed to work over the bands currently used for analog radio broadcasting, including AM, particularly shortwave and AFM, FM broadcasting. So, it's self-explanatory. The typical radio components from start to finish, I would say, or components that are present within the radio station. So we have the source, which is a microphone or a CD player, MP3 file from the USB or SD or a FTP server, which is also possible. It depends how the radio station is equipped and what's the internal network comprised of. This is where the audio content originates. It could be a live show, pre-recorded content, or a streaming service. Radio signal or radio works by converting audio signals such as those from microphone and into electrical signals, right? So this blue highlighted thing, audio processor, this is where we are mainly focused for this presentation. This is the device responsible for processing the audio signals, such as adjusting the volume, equalization, and compression, but including encoding, RDS system, and of course the content, or making or changing the channels, what type of input is it, and left or right, mono and stereo, and so on and so forth. Modulator is responsible for modulating the audio signals onto a carrier frequency and to antenna. Transmitter, this device amplifies the modulated signal and transmits it via an antenna. Oops, sorry, my mouse is getting crazy. The antenna, we are aware of this, is used to radiate the radio waves into the air, and we have the receiver, that is the device that receives the radio waves and demodulates them to extract the original audio signals. This can be your car, smartphone, or the radio itself. And you have audio amplifier and speakers, which is also self-explanatory, and plays the sound via speakers. You have also some kind of so-called PA systems, which are used to to announce something publicly, right? We're moving towards a bit to the digital era. Of course, there's analog transmitters and analog audio processors and digital audio processors, but we're mainly focusing on the digital audio broadcasting in this perspective, because it's, it's a hacking conference, I guess, right? And we'd love to discuss this, not including SDRs, not including the flipper, not including something that takes over the transmission. So this is a typical diagram flow of radio station. You have on air, you have the sources, as you can see, there's like PC, headphones, speakers, microphone, MP3 players that goes through the console or a mixer on air, and then goes through the audio processor, FM, is it analog or digital, doesn't matter. And then it goes to the transmitter to demodulate and transmits that to directly to the large antennas that you see on the buildings. You also have some types of digital analog transmitters, but this is out of scope for this presentation. Currently, we're doing research on FM transmitters that are digital and analog, which are also online. And that's the main problem here. So we're going to continue. This is a sample, or how it looks like to see a FM transmitter. I don't know if this is digital or analog. It's really difficult to distinguish, but basically everything in this 21st century is online and unprotected. So we will show you how, I'm not going to say easy it is to penetrate the radio network station and take over the signal, even the backups, even the DI network. We're not going to talk about transmitters. This is how it looks like, distinguished between analog and digital FM transmitters, because FM is better, of course, it's still in use. The digital analog, the digital audio broadcast is used only for receiving those FM signals and decoding it, basically, if you will. So on the left side, you have the analog transmitter. On the right side, you have the digital one. It's pretty similar, but I guess the digital one uses more power. And yeah, this is a mixer or console for equalizing or adjusting the volume, maybe. Basically, it's some kind of filter to filter the audio income source. This is not also that we're gonna discuss about today. This is how it looks like to have, this is a sample from DB-DEVA. It's an advanced FM and digital radio 4-band audio processor with backup audio player. And in the top in the top side of the screen, you can see a Smart Gen Windows application that allows you to use it as a remote control software from a Windows machine, let's say, to modify everything related to the audio processors. So audio signal processing, that's a subfield of signal processing that is concerned with the electronic manipulation of audio signals. So basically, this is another vector, if you will, to be able to penetrate or to intrude into the signal of the radio source, right? So one example, this is a second example. This is Omnia. It's Omnia 7 audio processors, which you can see what type of input and outputs you can interact with within that source audio processor. And this is Sound 4 impact, which we're gonna maybe discuss more for this specific vendor. So we're not gonna bash vendors here or shame, just to a short journey or let you know of a journey that we had, because this was initiated from a building management system penetration testing engagement that we needed to do. And while we are doing that building pen testing, BMS or building automation system throughout the entire building, it's a corporate building, there was a radio station there, and the owner of the building wanted to test every type of component and network and device within that building itself. So we had also experience with bypassing biometric access control systems, physical penetration testing, and the lock picking. I saw the previous presentation. That was really cool to see. And then we moved on to the doing research about these radio stations, because it was really strange how easy it was to penetrate, but not easy to penetrate, but how come and why the audio processor or the components within the radio station were not at all secured, and then moving forward to see how they didn't do any security evaluation or assessment within that product. And it's a huge program or huge software hardware stack. So broadcast signal intrusion, of course, is the unauthorized alteration or takeover of a broadcast signal. This can occur on television or radio broadcast and can take many forms. Digital intrusion is more sophisticated and includes hacking into stations' computer systems and gain control of the signal, or intercepting and modifying the signal as it is being transmitted. But that's again using small FM transmitters. If you can create your own, and using SDR, software-defined radio, you can manipulate. Also, we also did network jamming or wireless jamming, radio frequency jamming up until to 1 gigahertz, which is of course always effective, that you can just block the outgoing of the signal itself from the station. Analog intrusion, of course, is the most basic and common type, where the attacker uses a transmitter to broadcast their own signal. So I wanted to see how many incidents I could find. There's a public repository, I think, on the Wikipedia page. If you Google broadcast signal intrusion, you can see a lot of different broadcast intrusion happened from 1980s, famously, and then towards this date. So I could not list them all, but I wanted to make something connected with this topic. So this is the malicious indication incident in 2016, and basically the connections, they said, we also noticed that majority of the connections made had the user agent Babić streaming client. So you can Google Babić and you see that it's like an IP audio decoder with USB/micro SD flash interface and serial port, support internet radio, MP3 shoutcasts, WAWSA, IceCast servers, streaming, VoIP, codecs, and protocols. Basically, the radio station was hacked throughout or through this device. Again, according to Kathy Weisbach, founder and president of Kentucky Crescent Hill Radio, 100.9 FM, most of the stations hacked were low-powered community FM radio stations that use a Babić extremer device. So somebody hacked the device and just took over the signal. They hacked the audio processor. They could have hacked the FM transmitter as well. Digital, analog, doesn't matter if it's online. And I can assure you that while we, just yesterday I found more than 100 exposed transmitters online, easily accessible with default credentials, or it doesn't even have to be, requiring authentication, but you can easily see if you point out to a specific vendor or product that deals with or offers radio HD processing. It's very dangerous that it's online, and I'm going to explain why they do this online. Of course, we all know this. Similar story, I think, is the same, but not quite sure. Yeah, it's the same story. 4ABC was hacked. Your station could be next. Hacked Russian radio station broadcast Ukrainian anthem, also something related to something that's happening these days, of course. No details, technical details provided, but apparently they just, I think they didn't use any analog or on station like a evil twin just to take over a signal. Maybe they hacked the radio station based on IoT device online, which was in the radio station network. Hackers, this was the most interesting part that I saw. Hackers use DAB or digital audio broadcast radio as backdoor into connected car. So this is very interesting how they got to it. This is a research done in 2015 by a NCC group. Car hack uses digital radio broadcast to seize control because the infotainment system processes digital audio broadcast data to display text and pictures on car dashboard screens. Attacker could send the code that would let them take over the system. I'm guessing that they sent a large array of bytes as a text to the RDS or RDS system and overflow the infotainment system within the car, and they could control the brakes and the steering wheel through this telemetrics. Zelensky address shown on television in Russia and Crimea. This is recent. I saw it yesterday, when the 25th of January. They say that unauthorized replacement of a television signal happened on several channels, and they emitted or played a video. This is how you can take over a broadcast signal, let's say. You can hijack it live. If you have your own camera or microphone, you can play your input source to the world, or just have a pre-recording message, MP3 or MP4, whatever it is, and just upload it to that device or the server that uses this content. So what is DAB and what is RDS? Digital audio broadcast is a digital radio standard that uses different modulation methods compared to AF. Uses a technique called coded orthogonal frequency division multiplexing to modulate the audio signals. It uses the DAB EPG that allows for the transmission of more advanced information. The RDS, DAB, there's a DAB plus, which is more enhanced with quality, and it uses more sophisticated encoding and decoding. So, but there's a trick, right? If you're listening to analog FM and AM radio within the car, for example, or at home, if the signal is weak, there's the outside effects are impacting the sound quality, like wind or the storm. Then you can hear like the white noise. But with digital audio broadcast, is just if you can reach the signal, if you're far away from the antenna, it just stops. There's no white noise, there's no breaking, it just stops immediately. And once it has like full coverage, then it will just continue. For example, if you enter into a tunnel, it's not gonna provide you a white noise effect or sound. So that's the difference. RDS is radio data system technology that is primarily used for FM radio. It allows for the transmission of additional data such as song titles, station information, pictures also, like avatars, right? And traffic reports over FM radio waves. This is from my previous presentation I had about modulators, encoders, and decoders, and but it was not about digital video broadcasting. This is just one example, a slide from it, and to see how it looks like if you have access to some kind of appliances that deals with video processing. This is how it looks like if you have control remotely. It's not like in the movies, but this is a similarity between digital audio broadcast and video broadcast. And so let's focus on Sound 4. It's a radio processing audio processor appliance or IoT device. It's flexible and powerful. It ensures perfect sound quality and full. These are the inputs and outputs from the back panel. So it has like SMA connector, FM multiplexer. I don't want to keep you. So they use built-in web interfaces, APIs that can allow remote management and using of remote control software that uses those APIs to control the device itself or the entire network radio station. The vectors I used are black box, of course. During that pen test, we found out the web interface, which is PHP, uses CGI and shell scripts. Telnet, link and share terminal server, which is a protocol from the vendor itself, compatible with all the audio processing and IP streaming products. ELF binaries, firmware, we didn't have this. The software also, we had sound server, sound for remote control, and link and share transmitter. So we did an investigation, of course, Googled, DuckDuckGo, documentation, OpenAI, YouTube, saw some videos, penetration tests with a manual and automatic analysis. We did coverage guided fuzzing, discovered a lot of 0 days, source code review because we had entered within, penetrated successfully within that device. And we got the code from there. We did a PHP source code review, and we found additional vulnerabilities. And of course, at the end, we did an OSINT or exposure check on Shodan and binary edge to see how many devices are available. So worldwide dealer network. So you can see that this product is used around the globe, mostly in Europe and Asia, but also in North and South America. Results: 25 0 days and counting, 107 radio stations affected so far. No response from the vendors. We tried to contact them, no response several times. This was 3-6 months, maybe more ago. Collaboration with national CERT teams and VINS, which is the Vulnerability Information and Coordination Environment from the Carnegie Mellon University. And CVEs are pending, but we don't really care about that. So this is an example of format string in username environment using the link and share transmitter. .exe binary file, which is the solution that just connects to the device and just controls anything. You can download your own MP3 to play. You can use a microphone to just hijack the signal, or you can just change the text that goes within your car display to see who's next or what to send to the people that are listening or watching that. So this is a screenshot from a Ghidra reverse engineering framework. This is how it looks like to create a proof of concept, and then you can see there's a memory leakage and stack buffer overflow identified within that binary. On stack, backtrace, WinDBG output. Also, we use Jackalope, which is coverage guided fuzzer from Ivan Fratric from Google, and WinAFL from the left. You have Jackalope, which found 7 crashes from the right. In Sound for remote control software, which is using the VC S4 client DLL, we needed to write a harness and then use that harness to call a function within that DLL file, which is, there's a lot of parsing functionalities, a lot of handling of audio data, or just not audio, just network, and a lot of different strings and everything. So there are a lot of different vulnerabilities. Use CFF Explorer to check the DLL file and so on and so forth. This is the main interface of the remote control software. This is how it looks like when you connect multiple devices, and this is by one station. So one station is one IP, maybe multiple IPs for one station. It depends which IP range you're using. When you log in, you have the default username and password. There was a situation like this. This is the main interface. How's the doing in the also in the web interface and also the TIC client. This is how you see and how you control anything, basically. All the inputs, outputs, all the modules allowed and everything, down to adding users. So we added a user broadcast intruder. We checked the communication. It's clear text, which is a problem. You can see some hash values, which is admin, of course. And this is the intruder from the left, where we, inserted our username, which is a broadcast administrator, so we can control anything. This is the RDS encoder, which you can see that RDS text here is changed to PONT. So this is just one tryout, but I couldn't, change it in reality, of course. And you can see which song is playing next and so on and so forth. So a lot of options. It's a really rich TIC client that allows anything, basically. It uses the APIs and just connects to the device. This is how you can change output from a telephone phone call to the radio to be, presented in the FM output or anywhere you want, which is redirection. Setup, link and share, as I said, telnet used. You can control anything. It says itself, remote control and monitor of the device across the network using simple text commands via telnet. This is how it looks like if you go in the telnet session, log in with admin, and then the RDS. I underscore this because it's the most fun for me to change the radio data system text to go within the car, right? These are the options allowed on the device itself. So you can see that there's internet streaming supported and the IP connect up to 32 links, IP pass-through, link and share protocol, and software itself. So you have also a backup. If one radio signal or audio processor fails, then they continue with another one. And you can control all of these from a single software. Newsflash from the AI, I asked the question about hacking radio station. I asked ChatGPT to see what it will let me know. And it says if an audio processor is hacked, it is possible that a hacker could take over broadcast signal. However, it's important to know that these kind of attacks are not easy to carry out and would require high-level technical knowledge and skill. Additionally, most IoT devices have some form of security measure in place to prevent unauthorized access, such as firewall, encryption, and authentication. So, of course, in this case, it was really not the case. But yeah, of course, you can agree with what happens. If the hacker, of course, is able to gain access to other parts of the broadcast system, such as the transmitter or the antenna, they could potentially take over the signal. So this is a firmware glimpse of the web gateway interface. This is the login PHP file, a code within that you can see that even if it checks through the /opt/sound4/sound4 server binary on the Linux server, it doesn't use any sanitization of the post password or post username parameter. So this is where the command injection happens. And this is where you can, gain access to the entire network and start sniffing and then gain additional pivoting and go down within the radio station itself. One reason is to allow, why is this, maybe you will ask, why is this device online? For internet streaming, yes, but also somebody needs to manage and control the audio processing and encoding functions remotely. This allows station operators to adjust settings or for debugging purposes or maintenance or firmware upgrade. A lot of different reasons, right? A number of vulnerabilities we discovered are enormous, more than 25 0 days, still counting. And at the end, of course, you can read about, everything is published. I want to show you a demo of the RCE, which is not that cool. In the middle, you have the Python code, which is in the shape of Irukanji jellyfish, which I admire, which is the most deadliest animal on the planet. So if I play, you're just going to see how a usual radio station intrusion happens. And you just see command line interface. It's a Linux system, ARM-based. And you got a shell, you got an ID by www-data. If you wanted to have the root access, you can just exploit the kernel itself and escalate privileges locally. And because my time is already getting shorter, I'm really at the end, but just another shout out. Radio and broadcast signal intrusion is a serious security concern that can disrupt communication and cause confusion and panic among the public. Security, of course, is overlooked by a lot of IoT vendors that expose devices online and vulnerable to attack. IoT vendors needs to have more awareness and include security in their SSDLC pipeline to prevent vulnerabilities from being introduced to their products. The usual suggestions. And that's it for me, guys. Sorry for taking additional time, like 1 minute more, but yeah. Thank you for the attention and let me know if you have any questions.
Thank you, Mr. Krstić. Are there any questions? There was a useful comment from Mr. Spohn in the chat, so I suggest everyone to check it. Quite technical topic for me. I'm not familiar at all, but I'm thinking, I don't know if this have sense. But is it possible that attacker establish a botnet of cracked radio stations? Is this?
Yes, that's a very fair question, and this was the already suggested scenario within the report for the for the client. Basically, that we had that one of the vulnerabilities that we discovered within this type of device was that you could have unauthenticated issue a ping or ICMP traffic from the device, acting as a botnet. You can just merge all of those devices exposed to one point of command and control, let's say, as an attacker, and just send commands to them to do an ICMP check or ping or some traceroute functionalities that you can multiply that and issue a large distributed denial of service attack against any target. So yes, botnet pretty much, because we had some experience before with these type of vulnerabilities, and it's public basically. We're still working with the French CERT team. And yeah, I think it's a matter of time that when the malicious actors are just going to take this for granted and just create a script that will botonize or botnet this target or these devices and just use it in their own, for their own gain. But yeah,
another issue to be scary of.
It is. Yeah.
Thank you again. Thanks. So we came to the end of the second section. Great thank again for all the speakers as well as to other participants. We heard a lot of interesting things and of course also learned a lot, but now it's time to lunch. 30 minutes break is available. So the last today's section will start at 13:45 and enjoy your lunch. Maybe Christina has some additional information for you.
Yes, I would just like to thank you, Alenka, for connecting the program. After the lunch, we will have another moderator, Andrei Rakar from Petrol will join us. So Alenka, thank you once again for your time.
You're welcome, it was my pleasure.
Okay, welcome back. We had a short break. Now I would like to welcome our next moderator, Andrei Rakar. He's Chief Information Security Officer at Petrol. Andrei, thank you for joining us.
Thank you.
And for connecting the program in the afternoon. And we also have another speaker with us, Božidar, welcome. I think, Andrei, the word is yours, so.
I will start.
Yeah.
So I think we have a very interesting afternoon session, which starts with Božidar Radosavljević. So as we all know, so most of the attacks today start with phishing mails. Therefore, it is very important to harden email systems. And the first talk is Microsoft 365 Exchange online security tips from Božidar. So Božidar, the floor is yours.
Thank you, Andrei. Hello, good evening. Nice welcome and hello from sunny Novi Sad. My name is Božidar Radosavljević. I live in Novi Sad, Serbia, and glad to be with you today. And today we will talk about some security tips from Exchange Online. Just to share my screen, entire screen. You see now my screen, right? And hear me well?
Not yet. A bit. Let's wait. Okay, now it's working.
Great. My primary focus, what I doing in my life is Microsoft 365, and we do a lot of some doing with Exchange, with the Sharepoint, with Power Platform, with all aspects of Microsoft 365. And we see a lot of things on the Microsoft 365, what I want to share with you in this 30 minutes. It's a small time frame, and I hope that I find 6 interesting things what I want to share with you. I'm hoping that I will get answer from you on the end of my session. Božidar, you are boring, that all things what we are all set up and you talking about from all the stuff, but I know that that is not will be answer, because we will lots of see this misconfiguration on our client every day. Exchange is very important load in every company, mail server like is, and the Exchange is very popular on mail server. And what we see every day is these 6 tips what I can give you to increase your security score and how you can increase it. Well, let's start with the first one. This is the authentication protocol. Microsoft support on beginning. Microsoft support a lot of authentication protocol. How times go, every few months, every year, Microsoft shortening the list of authentication protocol what we can use on the Microsoft 365 and Exchange specifically. But if we don't use any of these protocols, just a little some modifications I must do because this sharing not give me position to click. Just a second. Okay, no, never mind. And we want to we don't want to wait Microsoft to turn off some authentication protocol. We can do it by ourselves. If we open the Microsoft 365, go on the admin section, we must be some kind of admin to access to this. And on the settings part and the organization settings subpart of the main admin center config, we can find here something what we call modern authentication section. On modern authentication section, you can find all authentication protocols what are supported by, today on Microsoft 365. If you see, I already disabled some authentication protocols. Just I mentioned, this is my demo environment, and if you see something is not configured properly, that is all okay. This is just for showing off, and that is not production or something like that. And all the things I do here is because it's this demo. I don't encourage you to do on the same way on production. Please do some audits before you apply any of these changes. Just a little disclaimer before I start. Okay, and I can switch off this authentication SMTP, put free and click on save, and that we all done. That is all okay if we do on the demo, but if we want to do on the production, before we apply these changes, we must just first to see if someone on our organization use this one of these protocols which you want to disable. How we can see if anyone use this protocol? We can go to the Active Directory, Azure Active Directory. On Azure Active Directory, we have under monitoring part something what we call signing logs, and then there we can see all signings from our users in our environment. We can filter that by adding the filter. For example, I can add filter client app. And if I add client app, I can select what I want to disable. For example, SMP, POP, and I don't know what I select anymore. Okay, this is the best scenario. I got clear list. I don't have any users who use these protocols. I can immediately switch off. If I have here some especially success signings, I must take care about that users who still using that and find a way to provisioning them new authentication protocols, change some maybe clients or something, and after that I can use it. Also, we can add by status filter where we can filter by success and failures. Also, you can find here a lot of failure. I don't have it, thanks God. If you have some big failures, that can also give you a clue that you have some kind of attack on your organization. So maybe someone is trying to guess your email username or no username and trying to guess password or something like that. Because of that, the best way to disable this is here. Why here? Because also we can disable these options by conditional forwarding. But if you disable by conditional forwarding will activate after user authenticates. So, for example, if we have some attacker will get information that he got a valid credential, and after that will go error and deny that he cannot use this protocol, but he will know that he have a valid credential. If we disable it here, if he has a valid credential, he cannot be able to log in because these protocols are disabled. Because of that, the best way how we can disable these options is here. But I also mentioning before you do this, please audit your environment, and after that you enable that options. Sorry, disable these options. Second thing, what we will talk is security override. Security override the configurations is very often situation that we have a lot of things when we using on-premise Exchange, or we using some other mail servers, and we start to migrate to Exchange Online. We have situation that on all the on-premise environments, you have a lot of configuration by some kind of third-party security software, or your some decision configurations because you have on-premise infrastructure, and you must done on that way because you have some specific configurations. When we migrate to the Exchange Online, our primary focus is to check if every mailbox is healthy, is everyone user have access to the mailbox, is all mail there, something like that. But very rare we taking care about configurations and how configurations are migrated to Exchange Online. For example, we have on the Microsoft security section, which now is called Microsoft 365 Defender. We have something what we calling policy and rules. Under policy and rules, we have something what we call threat policies, and we have anti-spam. We have all three by default. You can have more, but I have default 3. Anti-spam inbound policy, connection filter policy, and anti-spam outbound policy. We will now talking about first two. Later on the lecture, we will talk about third. Connection filter is very often list a lot of IP allows entries here, and that is not good. We have 3 sections here: IP allow, IP block, and IP save. If we have some IPs that defined here, you can see that that users communication will avoid security filtering, spam filtering, or any kind of security mechanism, and be directly communicated to our employees, our users. And that is very, very bad. If you have some kind of entries in the IP list, that will be good practice to leave it to blank and delete all entries from there. If you delete that entries, you will not block connection with your source and destination, but just transfer this communication to your security mechanism, and they will be filtered. After the filtered, they will be delivered to someone who needs to get that messages. But if you have here some kind of IPs that is allowed, that will be directly without any filtering. Also, you have safe list. Safe list is the same principle like IP list, allow list, Just the difference between them is to safe list the populating by Microsoft what they think that is the IPs that we can trust, but is also not good best practice. So my advice is to leave this both disabled or blank. But in some kind after migration, you can find here a lot of IP address, so you must audit and check if that is not using. You can delete it from there. Also, what we have here is inbound anti-spam policy. On the end of this config, you can find allowed and blocked senders and domains. And also you can find on allowed domains list of domains which are set to be allowed. And that is the same principle like settings before. Lots of admins see that and clean this, but do one major mistake. Leave their own domain. They think that is okay. If I leave my own domain, I trust my own domain. But Microsoft already put here a warning where said if there's someone in the world spoof your domain, they can send your email to your organization directly without any situation. So this is also good practice to leave it to blank and take out all domains, including in your domains. If you have some special domains, what you needed, it's okay. But if you don't need any of these domains for some special reason, good practice to leave it as is. So this is the configs, what we can configure like this, but immediately, and that is good if is that your demo environment or lab environment, but in practice we don't do on that way. In the practice, we open something what we call advanced hunting on the Security Defender same page. We have advanced hunting, and here we can put some KQL scripts, queries, where we can query our organization and find on the several levels, do we have any communication by the policies, and what is that communication? Can we see if that communication exists? What is that communication? And after we clear the game, we can disable that configuration. If you don't run this KQL and don't see how that filters using these IPs or allow domains, don't turn off. First run KQL, audit, and after audit it is okay, you can disable or appropriate configuration for that. Or I will send to check. I will send this KQL to you have on your environment that someone, if need, can modify or use it. I also find it on internet, so for which price I buy it, I sell it for the same price. Okay. So I said hunt here, and if that is okay, turn off it here. That was all about second. 15 minutes already passed. Wow. First story is audit. Audit is very important, a very important part of every infrastructure, every organization, every IT system. Also, same is on the Microsoft 365. Also, it's for Exchange Online, especially when we got something what's happening. We need to investigate how that is happening. Because of that, on Microsoft 365 portal, we have something, admin portal who called compliance. By new name is PureView. on pure use side, we can click on audit and do some audit of our environment. If you open Pure View and click on audit and see a bar here where you got a message, auditing is not enabled for your organization, I'm recommending you to fast enable that, because that is very important to use. So don't have any problems, and if you have some investigation, you can't do investigation. So if you don't have any messages, you are ready to go. You can go to the retention policies. On the retention policies, you will have some retention policies defined. Also, I mentioned in this my demo, and I don't have any retention policies. I can click on create retention policy and create some retention policy. I give some retention policy name. I promise I will write description as soon as possible. Can select which record I want to monitor. I wish to have here some button which calls select all, but we don't have. And we must select each one by one. I think that possible exists some PowerShell script for that, but I don't have any. So if I selected that all, I can leave it users blank, because if I leave it blank, that will be affected by all users. If I want just for specific users, I can put it here. I put here priority, one number, 1, 2, 3, 10. Every number except 0 is valid. I put it 1. And I can select duration, how many I will hold my audit. Please be aware, E3 licensing have 19 days retention period, E5 1 year, and you have a special Microsoft solution provides licensing which enable you to have retention about 10 years. So you must be aware which licensing you have and which amount of retention you can choose. So if you don't want some additional costs, select proper and you are ready to go. You are ready to go almost. What we experienced on one client is that we are migrate them from the Exchange to on-premise to Exchange Online, and we set up this, and we didn't get any response. Why we didn't get any response? Because someone on the on-premise environment disabled a logging on the mailbox level. Because of that, we didn't get any data. Because of that, when you enable this option, it will be a good start to run some commands which look like these. I also will paste it on the chat. This command, PowerShell command, also you must be logged on the, you must have imported Exchange Management Shell and connected to, you will get all your users or mailboxes with is that audit enable or not, and which settings are defined for every specific mailbox. You can see here that I have some mailboxes that still have false, but all the others have true. That is all okay. You have some mailboxes that is not yours. The Discovery Search mailbox is Microsoft special mailbox. That is mailbox which working under hood on the Exchange Online, and we cannot affect on them. So some mailboxes like this, they still staying in the false, and that is okay. Other mailboxes have is a true enable, which time period is defined, and which options are selected here. On the Microsoft page, you can find Microsoft Learning. We have a page where you can find all setups, what you configure, what you can enable or disable for specific user. And this is also something what I will send on the chat. Here you can see, just to mention, that mail item access is now moved from the E3 license to E5. So please be aware of that. If you want to see, for example, if hacker compromised some your mailbox and you want to see which mail they access, you must have E5 licensing. Microsoft now forcing the E5 licensing with security stack, and if you want some fancy and good security features, you must enable E5 security stack. So this is option in the security stack 5. So if you have E3, that options will be not available for you. This is all others variation of E5, academic and government licensing. So if you have E5, you can see also them. Someone complaining that that is mechanism is a little bit slower if a hacker takes you a large amount of items. That is true, but you will get some information and you will know what they searching. So that is also good information. For someone who don't have enabled these options, I also provide from internet script, which will loop your all mailbox and find all items that can apply and try to apply all that configs for you. So if you have something, the situation like that you migrated and you have disabled on the mailbox level, this script will help you. Also, please be aware to understand this script and run before and don't immediately run on production. Please test it, read it, understand it, and everything else. Okay, that is third options what we want to talk. 4 options is to talk about outbound forwarding. Outbound forwarding is very crucial thing. It's not hard and not so strange. Someone wants to forward their emails from work to personal or something like that, and that seems cool. But what we see today is that we have a lot of hackers who take over the mailbox from the employees and set up some Gmail or Yahoo or something like that mail seems that some users create forward, but they monitor that mail and waiting right chance to go to the action. Because of that, Microsoft put here a big card which reminds you every day how many out-of-forward messages you have. So because of that, this option is also very important to disable on the organization level. Also, if you have some exceptions like ERP or support ticketing, that can be put in the exception, but that is very good story to disable on everyone. If you want to see before you start who use auto-forward, you on Exchange admin console, we can go on the reports on the mail flow subsection, and first you have report auto-forward message report. And after that report is run, you can see which mailbox are using this option. If you see that someone who is not needed to use it, you know what you need to do. If that is someone who need it, that is okay. If we all good, we can configure that. We will come on the same place like a little bit earlier on security stack, Microsoft 365 Defender. Go to the policy and rules, trusted policies, anti-spam. But this time we will go to the spam inbound policy. On the end, this policy, outbound. On the end, we will set up protection, and forwarding rules, we will set it to off. This will disable forwarding and redirection at the same time. And if you needed someone special to use these options, we can create another policies where we can put it some user and said, okay, this user will be automatically allowed, and that is.
Božidar, you have a couple of minutes left. So.
Okay, we are on the last. Last is when nice thing that you give a user to have ability in Outlook to get report when they get some phishing or spam email. If you want to deploy that, you can deploy it third party, or you can deploy it free Microsoft. How can you that use? Go to the Microsoft 365 Admin Center, organization settings, organization settings, integrated apps. On this list, you will find store, search here, report. You will find two software, report phishing and report messages. You can get it and deploy it to client. After you deploy it, you can configure on the, again, in the security part, Microsoft 365 Defender, on the setting, usage report settings, you can define behavior for that reporting. If that reporting will be sent just to Microsoft, just to you, or both, and which mailbox they will receive these messages. Also some branding and stuff. And after that, every user when report some phishing or suspicious mail, you will find. Oof. A minute before end, I am done.
Okay.
Thank you very much.
Maybe if somebody has some questions, let's put it in the chat. So we are out of time.
If someone have a question, I will be glad to answer. Thank you everyone for the listening and joining. Goodbye from Novi Sad.
Thank you to you too. So our next speaker is Jurica. He is the security governance team lead with the InfoBip. He holds the Masters of Computer Science from the Faculty of Electronics and Computer Science at University of Zagreb. And his talk is very actual. So his talk will be about the new NIS2 Directive. So Jurica, the floor is yours.
Do you hear me?
Yes.
And do you see my screen?
Yeah, beautiful island. Yeah.
Okay. Is it now in presentation mode or?
Now it's in presentation mode. Now
okay.
It's, yeah. Okay. Yeah.
Thank you. Thank you for the introduction. So nice to hear and see you all. My name is Jurica, and as said, I'm working as a security governance team lead at InfoBip. Prior to this position, I worked for nine years as a part of Croatian government CERT, and that's where my interests for the NIS directive actually originate. So today we'll talk about the new NIS2 directive, what it brings to states, what it brings to companies, what is the timeline, and things like that. So as you do you see the slide switching? Please just confirm. Do you see the stars?
Yeah,
the slides moving? Okay.
Yeah, we see the flag, EU flag.
Okay, cool. Then everything works. As you probably know, in the last days of December 2022, the NIS2 Directive was officially published in the Journal of European Union. Although there was a site how the directive is going to look like. This was the date when we actually officially saw what's new for all of us regarding information security in the European Union. So just to repeat once again, all the member states need to have common legislative environment within the European Union. This is done through three types of mechanisms. One are regulations. They have a binding legal force for every member state, and they enter into force that is set in all the member states. The other type is directive. It lays down only the certain rules that must be achieved within the local member state legislation. So directive gives you just what you need to achieve, and it's up to member state to write its own law or any other kind of legal document. And the third option are the decision, and they are actually related to specific cases and directed to individual or several member states. So in this case, we are talking about the directive. NIS2 is a directive setting a goal for all the member states, and then it's up to them to write their own local legislation environment. A bit about the NIS history. So the first time NIS was mentioned in now far distant 2013, when we got the legislative proposal for the NIS directive. 2 years after that, there was a political agreement on the EU level how the directive should look, and then in the summer of 2016, we actually saw the actual text of the NIS1 directive. All the member states then got 18 months to transpose the directive into their legal system, and this was the date was in late 2018. Most of the countries did it within that timeline. Some were late, but basically all the countries adopted NIS directive. Within the directive, it says that Commission will do the assessment on the success of the directive, doing reviews on each member state, doing peer reviews, and writing kind of recommendation for further improvement. This actually started in 2019. It was a bit slowed down due to COVID coronavirus, but actually all the country visits were performed, and we got the impressions from member states on what their thoughts on the first version of the NIS directive. After that, it was decided to go to create recommendations on how to improve the directive in the next version. During 2021, the negotiation on the new text of the NIS directive were started, and as said on the first slide, in the last days of the last year, we finally saw the new NIS directive live. So the question is, why do we have NIS2? Was NIS1 not successful? Was there something wrong with it? Actually, no. As said before, it was envisioned that the directive will have its update within the 3 years. Commission actually said that introduction of the NIS1 was a significant progress for the cyber resilience within the European Union. It was the catalyst for the institutional and regulatory approach to cybersecurity in the Union. Also, for the first time, we basically saw that all the countries in the European Union have adopted the cybersecurity strategy, which is a kind of prerequisite for every country to be aligned with the NIS directive. So, what is said in the preamble of the NIS2 that the NIS1 directive has served its purpose. It has brought us to much stable and resilient cyber environment within the EU. So what's actually the reason for the change and update? So the NIS2 directive recognizes that there has been a significant push in digitalization across the EU from the time the NIS1 was adopted. More and more services are online. This was specifically fastened and improved during the period of the pandemic, when work from home became kind of a standard, making most of the services we usually use available online. Of course, this created the environment for the threat actors. So we do see again a pretty significant rise in cybersecurity crime over the past year. So what was actually wrong? What's not good with the NIS1? It's also recognized within the NIS2 directive. As said before, directive is not giving each member state specific and clear guidelines or rule set on how something should be done. It's up to member state to decide on this. This can be a good thing, of course, but if we want to create a single market, this can also be a not so good position. So once the reviews on the national legislation was done, it was recognized that not all the countries are using the same criteria to identify operators of essential services and digital service providers. That was the number one point. So you could get into a situation that a specific company is recognized as operator in one country, but in another country, same or similar company is not in the scope of the NIS1. The other thing, what has been recognized as a potential problem is that the imposed security measures that operators need to accept also massively vary from state to state. So in some member states, these measures are very harsh and very strict. In others are light. And this actually brings us to kind of not stable situation that actually is not promoting cross-border economical activities and can actually lead to incidents. That's basically the reason why the NIS2 tried to address these problems. So what's the vision between the NIS2? First, it's to cover a larger portion of economy and society. We'll see that later. If you remember, NIS1 had 7 sectors of operators of essential services and 3 types of companies that would come in the section of digital service providers. On later slides, we'll see how the NIS2 actually got much bigger. Within the sectors, the vision is to focus on bigger and critical players. Number 3, the goal here is to align security requirements. As said before, they did pretty much vary from state to state, and the idea here is to try to have them more aligned. Also, the intention is to streamline incident reporting obligations and also to align provision on national supervision and enforcement. So these are actually the basic visions that NIS2 is trying to accomplish. If we look at the document itself, we can recognize these three major pillars, and that's actually what I'm going to talk in more details about today. So the first pillar is what actually should member states or countries do? What are the capabilities they need to bring to the table and offer to the market? The second pillar is risk management and reporting. As in most information security standards, it is in much more sense advocated within the NIS2 that all the activities need to be risk-based, and that all the accountability should be on the top management. The third pillar is, of course, the cooperation. Now we'll be talking about inter-country cooperation within a member state, and of course, cooperation within the European Union. So we'll start with the things that impact member states. So each member state now needs to designate one or more competent authorities that will be responsible for cybersecurity in specific sector, and of course for the supervisory tasks. There are two, of course, approaches here. Member states can have a single central point, competent authority that will be in charge of all sectors, or of course they can have more sectors, more competent authorities, maybe one for each sector. Also, member states need to establish a single point of contact. That's basically a point through which a member state will communicate to every other member state in case of incidents, and actually it will be used as a communication towards the Commission. Also, each single point of contact will have a liaison function to ensure cross-border cooperation with the member states, Commission, NISA, Cyclone Group, and so on. Important thing within the NIS1, also with the NIS2, is a prerequisite for each country to have a national strategy. This prerequisite stays the same, but also imposes the countries to adopt and update their strategies, specifically to address cybersecurity in supply chain. As you may know, for the last 2 or 3 years, there were several significant high-scale attacks that were performed through supply chains. So that's the reason why the Commission wants every member state to address specifically this domain within their strategies. Also, as before, member states need to notify Commission within 3 months after they adopt their new strategies. This is a new concept, CVD framework, or Coordinated Vulnerability Disclosure Framework. This is a rather new thing. This was not mentioned within the NIS1, and it's kind of a new capability each country needs to have prepared. What CVD is, it's a structured process through which vulnerabilities are reported to the manufacturer or provider of potentially vulnerable ICT products or services. What each member state needs to do is to designate one of the CSIRTs to be a coordinator for the purposes of this process. Their task is to identify and contact the entities concerned. They will assist legal person when they need to report vulnerability, and they will, of course, negotiate disclosure timelines. Member states, of course, need to ensure that legal or natural person are able to report anonymously recognized vulnerability to the CSIRT that is designated as a coordinator. Also within this framework, NISA got a new task. It will develop and maintain European vulnerability database that will include information describing the vulnerability affecting ICT products and potential patches that can mitigate the negative impacts of this vulnerability. Again, kind of a new thing within the NIS2 is this crisis management framework. Although this concept has been presented a few years ago, now it's officially a part of the NIS2. So each member state needs to designate or establish more competent authorities responsible for management of large-scale cybersecurity incidents. For the purpose of time, I will just try to speed up a bit because I think we will not be able to cover all the details on each slide. As in NIS1, NIS2 also implies that each country needs to have a designated CERT. It can be one, it can be more. The important thing is that each sector that is covered in the scope has its own designated CCERT team. Similar to NIS1, NIS2 also describes in details what the requirements and what the tasks of each CCERT is. Now we can talk a bit about the cooperation at national level. So as mentioned before, all the structures I just mentioned can be done central or decentral. So you can have a single competent authority, you can have a single CERT, but usually that's not the case. Usually countries have several competent authorities and several, of course, competent CCERTs. So member state has the obligation to ensure cooperation within these national authorities. When we talk about the cooperation on the international level, basically all the structures have been introduced within the NIS1. First of all, that's a cooperation group. It is composed of the representatives of the member states, Commission, and ENISA. Also, European External Action Services will participate as an observer. The goal of cooperation group is to support and facilitate strategic cooperation. On the more operational level, European Commission has established a CCERT network. Similar to a cooperation group, also member states give their representatives there. The goal of this group is to exchange operational information and strategies on how CERTs are fighting cybersecurity incidents on a daily basis. As mentioned, both of these groups are already existent from the NIS1 directive. Here you can see tasks that are assigned to CCERT network. So these are just few of them. Exchanging information about the CCERT's capabilities, facilitate sharing, transfer of technology, data, policies, tools, processes, and exchanging relevant information about incidents, cyber threats, risk, and vulnerabilities. Basically, this last task that I mentioned is pretty much the most important one. EU Cycling Group is a group that's related to this mentioned large-scale cybersecurity crisis. It is actually established to support the coordinated management of large-scale incidents. Again, it will be composed of the representatives of member states, cyber crisis management authorities. The goal is to increase level of preparedness of the management, to develop a shared situational awareness for large-scale cybersecurity incidents, and to assess the consequences and impact of these events. They will report on regular basis to the cooperation group, and they will of course cooperate with the CSERT network. Okay, so we are now coming to the key changes within the NIS directive. What are actually the covered entities? As you can see on this image, we are not talking anymore on operators of essential services and digital service providers. Entities are now distinguished as essential entities or important entities. Also, as you can see, the number of sectors has increased dramatically. In the energy sector, there are changes. In the health sectors, there are new subsectors. New sector is wastewater. Digital infrastructure that part of it used to be digital service providers now have more subsectors like data centers, CDNs, electronic communication trust service providers. And maybe the biggest change is the sector public administration. Basically, all the public administration is now in the scope of the NIS directive. And the last sector is the space sector. Within the important entities group, you can see the change there even bigger. So the postal and courier services, waste management, chemicals, food, and all the manufacturing. You can see the subsectors here have been introduced as part of the scope for the NIS2. Basically, if I would have only one line to say what's new in the NIS2, this would be the slide. So the scope of the NIS2 directive is significantly bigger than the one for the NIS1. Who are these covered entities? Of course, they need to be a part of the sectors mentioned on the previous slide, and also they need to qualify as medium-sized enterprises or bigger than that. In short, what's the difference between essential entities and important entities? So you saw the scope, what it covers. Regarding security requirements, they both have risk-based security obligations. They both have significant reporting obligation on reporting significant incident and significant cyber threats. The difference is within the supervision. So essential entities are supervised in ex-ante, ex-post ways of doing, and important entities are only supervised as ex-post. Sanctions apply to both of them, and jurisdiction rules also apply for both of them. What are the changing for the incident reporting? As we saw, one of the vision is to have a more streamlined incident reporting mechanisms. So now all the essential and important entities need to, within 24 hours, report and early warning, even if they suspect that something is happening with their IT systems. This early warning should be followed by incident notification not later than 72 hours of becoming aware of the significant incidents. And finally, they should have prepared a final report submitting not later than 1 month after the incident notification. One important thing that is, I would not say changed from NIS2, but more clearly defined are these sector-specific union legal acts. As you may remember, a lot of discussion with the NIS1 was this lex specialis rules. So if some of the sectors were already covered by some other EU law, does the NIS1 apply or not? So within the NIS2 directive, we have a pretty clear statement on that, saying that if there is a sector-specific union legal act that contains provision that require essential or important entities to adopt cybersecurity risk management frameworks, those provisions should apply to such entities. Basically saying that if there is a previous act coming from EU that is imposing similar or even harsh rules to the entities, that legal act should be used and not the NIS directive. So to be even more precise, EU is saying that regulation 2554 will be a sector-specific union regional act in regard to financial entities. And if you know what 2554 is, that's actually the DORA legislation that just got approved for the financial institutions. So if you read the directive, all the entities from financial sector that apply to DORA must or should not apply to NIS2 Directive law. Also,
you have a couple of minutes left.
Yeah, I'm finishing, trying to finish. Yeah. One more thing, very important, that has been addressed in the NIS2 is the confusion made with the critical infrastructure. In the NIS1 directive, there was a lot of discussions on that. Are the operators of essential services actually critical infrastructure? Some member states adopted this, some didn't. This new directive was very, very clear, saying that all the entities identified as critical entities under directive for critical infrastructures should be considered to be essential entities under this directive. So member states only once need to identify what's critical for them. Then the NIS2 will be kind of in charge for their cyber protection and this other directive for the physical protection. Okay, to finalize, when does all this start to happen? So member states have up to this date to adopt NIS2 directive and have their laws updated, approved, and running. So something more than a year and a half. It's pretty clear from the text of the directive who will be the who is going to be the scope. So if you are recognized within that scope, now is time to act and start preparing for full alignment with the NIS2 directive. That's pretty much it. It was a lot of information, tried to speed it up, but it's a huge subject, but we got only half an hour. If you have any questions, here are my contacts, and you can reach me out at any time.
Thank you, Jurica. So we continue with our next speaker, Andrei Georgiou. Actually, so the rest of the talks are all related to machine learning, artificial intelligence. So Andrei Georgiou is a highly accomplished trainer with extensive knowledge in the service management and security management fields. He has also worked as an internal IT auditor and actively participates in various security or audit-related projects. Andrei, the floor is yours.
Hello, everybody, and thank you for having me here. I just wanted to make sure that everyone can see me properly. Can you hear me okay? If I can get a confirmation? Yeah. Great. So again, thank you for having me here. My name is Andrei Georgiou. I currently work as a full-time trainer for IT Academy, which is a training company in Romania. And in my past experience, I've worked, as you mentioned, as an internal IT auditor. I've been connected to the security field. I've done security assessments, penetration testing. And though I'm not currently connected anymore to the practical field, I have maintained a keen interest on the trends and the evolutions in this industry. And that is the reason why I wanted to speak today about this new hype that we have right now these days in the market, in the industry, which is large language models. And I wanted to tell you some things that I have found during my short research about these technologies and what kind of implication do they have on current, but mostly on the future of security in general. So this is the topic today for my presentation. Let's begin with a short definition first. What are we actually talking about? What is a large language model? As you can see on my screen here, this is the exact definition that I've got from ChatGPT, which is probably the technology that I'm going to be talking mostly today. So I actually asked the engine to introduce itself, to explain to me what is a large language model, and this is the answer that it came up with. So it's a type of artificial intelligence that has been trained to understand and to speak like a human being. So it's able to analyze, to process, understand, and generate natural language. And in itself, this may not sound like much, but if we consider the huge amount of knowledge that has been used to train this engine, to train this technology, it's like having a very smart person next to you, always available and able to answer any kind of queries you might have in any kind of domain you might think of. So it can be a very powerful tool. And I'm going to show you some demos today and try to give you some ideas of how we can use these technologies in our domain, in our field. Let's say for usability reasons, I have preferred to use ChatGPT as the main technology to create the examples today. That doesn't necessarily mean that there are no other better technologies in the market. I am sure there are, but right now, at the moment, ChatGPT is probably the most popular, and it's also the easiest to access. It's the most accessible and user-friendly of all. So let's see what kind of other technologies we are talking about right now. Again, this is not a complete list. This is just to give you an idea of the current environment in this domain and get some, you can get some ideas about what interesting tools you might use in the future, or at least you might explore. The first one is the one that I'm going to be focusing most on, ChatGPT, created by OpenAI. GPT actually stands for Generative Pre-trained Transformer, which means in basic English, it means that it's an algorithm that has been pre-trained on a set of data, on a huge set of data. Basically, they have fed a lot of information collected from the internet, from Wikipedia, from GitHub, and other different sources. They have fed all this information to the engine. And now the engine not only understands these topics and can actually understand the context of the queries from the users, but it can also access, instantly access any kind of information that has been stored in all these knowledge repositories over the time. So it's like a search engine, but much faster and much smarter than a usual search engine. There are other technologies which are quite interesting. For example, we have Codex, also from OpenAI, which is similar with ChatGPT, but it has been optimized on code. So it is mostly optimized to understand, analyze, and generate source code. So you can actually use it to program, to create programs. And it's very, very, very useful. Some of you may have already experimented with these tools. For some of you, they might be something new. But I encourage everybody to try to explore this technology because it's definitely very promising. In the meantime, I also have to emphasize the fact that there's a lot of hype right now and a lot of unrealistic expectations about what a technology like this can do. And to be honest, it's not perfect yet. It's not there yet. However, it has made huge progresses over the past 2 or 3 years. Actually, large language models are just a part of something bigger, which we call generative AI, generative artificial intelligence, which is like an AI engine which is able to create content, different types of content. Language models create text, they create language, as the name implies, but there are other tools like DALL-E, for example, which creates images. So based on a query from a user, it can create an image. There are tools which can synthesize voice. There are tools that can be used to create music, to write different, different types of content, or even create an artificial face, a fake identity, if you want. So very powerful technologies which gradually become available in the market. Another interesting alternative to ChatGPT would be Bloom from Hugging Face. Bloom has the huge advantage of being free and also completely open. So if you have the right hardware, you can simply download the pre-trained model, you can customize it a bit, and then you can run it on your own infrastructure. So this is great for whoever has the appropriate technology, the necessary infrastructure. There's also Lambda from Google Research, which unfortunately I wasn't yet able to gain access to. I'm still on the waiting list. It looks very promising. It sounds very interesting, but not yet publicly available. And another interesting alternative that you should explore is a tool which is called Perplexity. And this tool actually does something interesting. It adds knowledge about current events. A main disadvantage of a pre-trained model is that it uses a snapshot of data up to a certain point in history. For example, ChatGPT does not know anything which happened after 2021. So the latest knowledge that it has in its database, in its storage, is up to 2021. So if you ask ChatGPT anything about the conflict in Ukraine, it won't be able to give you any answers. However, Perplexity adds an additional layer and integrates ChatGPT with Microsoft Bing, which means that you can actually add context regarding the current events and use that to query the knowledge from ChatGPT, which I think can be very, very, very powerful and useful. There is also a new job in the market. I'm not sure if you're aware of that. There is a new job title, which is called prompt engineering. And I wanted to tell you a few words about this new job. It's actually a new field of science, if you want. It's the science of creating queries. It's just like writing SQL query, is just that instead of using the SQL language, you are basically using natural language, plain English, or any other language whatsoever. So it's a matter of understanding and finding the best way how to define your problem and ask the right question to the AI in order to get the expected result. This is what we call prompt engineering. It's like designing queries. And most of the times, the process of interfacing with a large language model, for example, or any kind of AI tool like this, through prompt engineering, it's mostly a trial and error process. You never get the right result from the first attempt. You have to fine-tune the query until it understands exactly what you mean. And sometimes you really have to be very precise in what you're asking. Playing with this technology actually made me realize that most of the times I am very vague in the way I speak. I'm not always being very precise regarding what I want. So you have to to exercise precision and be prepared for a trial and error process until you get the right result. But most of the times, if you're patient enough, you can get the results that you're looking for. Okay, a few words about the current trends, because we talked about the present, but let's look a bit into the future. And what I expect to happen in the, in the near future is more and more people, we're going to see more and more people using this kind of technologies. Because as the models become more user-friendly, they tend to transition from a purely research concept to something more like a commercial product, which means they become more usable, they provide much better user experiences, more accessible to everybody. And also, in the meantime, as technology evolves and we get better and better infrastructure, we can also expect to see an increase in performance. So they are going to become smarter, faster. This is the trend. This is what I expect to happen in the future. More and more individuals and companies become interested in this technology, and they try to get access to large language models because they want to understand how they can use this technology to disrupt the market, to create new services, new products. And they probably will in the future because it has a lot of potential. And also, I think we should regard language models and in general, all fields of generative AI as merely some stepping stones to something bigger, to something that I think we are trying to achieve as a society, which is the concept of artificial general intelligence, you know, the one that we see in the movies. Whether we like it or not, this is the direction that we are heading in. And I think these are all components of that. So it's slowly taking shape, piece by piece. Having these technologies getting better and better, we are getting closer to that objective. So there's also an ethical side to this whole evolution, but I don't think we have enough time in this short presentation to cover the ethical aspects. There's a huge discussion to be had in that area, also legal aspects and so on. So let's move on to the more interesting stuff, the actual use cases. So during my relatively short research on this topic, I have managed to come up with a few, I'd say, interesting ideas of how we might use ChatGPT and other types of language models and generative AI in the domain of information security. And to make it more clear, I've tried to classify the examples in defensive use cases and offensive use cases. And first of all, let's discuss about how can we defend ourselves and protect our assets using large language models. How can they be useful? Here are a few ideas. For example, assessing security controls. Now, we all know having a security control, it's not only about implementing the actual control, you also need to have the proper documentation behind it. So we are talking about procedures, policies, and standards and rules and stuff like that. And most of the times in many companies, managing all that documentation can be very difficult. It's difficult to keep track of versions, to make sure that you've updated the content, and to make sure that they are clear enough and they do not contain any, let's say, any conflicting requirements, for example. Right? Well, ChatGPT can be very useful. You can basically feed this kind of documentation into the engine, and it can help you detect any issues, any I'm not talking about a spell check. I'm talking about meaning. I'm talking about understanding the context and telling you that you've missed something or that you have some conflicts between your procedures. Another interesting topic would be threat analysis. Now, obviously, I wouldn't rely on ChatGPT to do a threat modeling, for example, for an application. However, it's always a good idea to have a checklist with you. Now, I hate checklists, but working as an auditor, I've came to realize that a checklist can be useful because it gives you a structure. It helps you remember things and make sure that you haven't missed something. Well, instead of using a static checklist, you can have a personal assistant in the form of ChatGPT, helping you to make sure that you haven't missed something important when you identify the threats. You're going to see an example on threat analysis in a few moments. We can also use it for code review because it analyzes and understands the source code, and it can identify vulnerabilities, but it can also provide more efficient ways to write the code. So it can help you optimize the code. and simplify and correct different things in the code. Security awareness of employees. I'm going to show you a complete example regarding security awareness. Malware analysis can also be an interesting domain where it could be useful. Log analysis. Again, today, analyzing logs with human employees, it's not feasible anymore because we have so many systems, we have so many technologies. So the sheer amount of information is huge, which means humans are not capable anymore to process all this information. So we are using already a lot of automation in this field. ChatGPT, it's smarter than the average tool because it doesn't function on rules. It's basically smarter than current technologies because it can understand the context, it can understand an actual threat scenario. So it can be used to analyze logs and quickly identify a security incident, for example. And I'm going to show you also an example of detecting insecure configurations, which is another interesting use case. So let's get to the demos, shall we? First of all, threat modeling. This is you're probably familiar with the interface of ChatGPT. If not, I encourage you to use it. What you're seeing here, it's a pre-recorded video because unfortunately, I do not yet have access to the professional version. So I'm using the free version like everybody else, which is kind of unreliable still. So that's why, in order not to have any surprise, I prefer to use pre-recorded videos. And on top here, I have the actual prompt that I've used. So the query that I've used to talk with ChatGPT. And let's see what kind of response we get. I'm asking the engine to identify potential threats to a web application which is used to process payments data. And it's used worldwide by quite a lot of users. So almost immediately, you see, we get a list of potential threats. Again, I wouldn't rely exclusively on this list, but I think it's a very nice starting point for someone who doesn't have enough experience, who doesn't have too much knowledge regarding security, but wants to identify the most important threats. And the next step, I am actually asking for a list of mitigation techniques. So for each one of the threats that it identified, it now provides different ways to mitigate the threats, different controls that we might implement. Right. Now, imagine that you can further explore. If you want more details, you can ask the engine to provide you with more details about, I don't know, number 5 or number 6 to explain how to practically implement that particular control. So this is just a very simple use case, but I think it can be very useful, especially in companies where there's a lack of specialized knowledge or where you have a huge amount of assets that you need to protect. It can be useful. Let's go to the next one. And the next one is an example of code review. I am actually using a piece of known vulnerable code. This is a part of the server message block driver from Microsoft Windows that was found to be vulnerable 2 years ago. The name of the vulnerability was SMBleed, if you remember about it. And this is the actual piece of code responsible for the vulnerability. So I'm trying to see if ChatGPT, for example, would have identified it as a vulnerability. So I'm feeding the code to the engine, and let's see what kind of results we get. As you can see, I'm using natural language. I might have as well used another language instead of English. And here is the response. We can see right here that with a certain degree of, let's say, confidence, the engine, basically ChatGPT, identified a buffer overflow vulnerability in this piece of code. Now, I'm not saying that we could not have identified this vulnerability using other technologies or just using human factor. However, the simple fact that it's able to do that, it's very interesting because you can actually automate this kind of reviews if you have access to source code. You can find even zero-day vulnerabilities like this using a large language model. Okay. Sometimes you also have to keep in mind that it provides different false positives. So in some cases, it might find vulnerabilities because it doesn't have the actual complete code. So for example, it might say that a variable has not been declared, or because it doesn't see the place where the variable has been declared. So if you just provide it with simple pieces of code, it may not, you may not get the best results. Another interesting use case is in the domain of security awareness. Now, we all know how time-consuming this can be, especially in big organizations which have a lot of employees. We all know that, unfortunately, humans are still the weakest link in terms of security. And this is why every company should invest in a very strong security awareness program. And this can be very expensive. It can be very time consuming. However, we can use a large language model to assist us in this task. In this example, I have used, I didn't want to use a real password policy. So I've asked the engine to write the password policy for me. And this is what it came up with. It created a password policy. And now I'm asking the engine to create 3 sample questions to make a quiz for my employees to test their security awareness knowledge. And we get the questions. But as you can see, the questions are not yet exactly how I want them to be. So I need to refine my query and ask the engine to add 3 potential answers, 3 possible answers to each question. And this is the result. So imagine that if you would have an API, for example, and you could integrate with this engine, you could generate a lot of content, a lot of quizzes and a training program and slides and training material based on your actual security documentation. And this can save a lot of time, a lot of money. Yes, about insecure configurations and how we can detect them. This is an example of a configuration file from an AWS configuration, and it has some vulnerabilities in there. And I'm asking the engine to identify these vulnerabilities. I'm not even telling the engine that this is an AWS configuration. So I'm just feeding the content. And let's see the results. It analyzes the content, identifies it as a configuration file, and then provides some information about potential security issues in that file. Something that maybe a human operator might have missed. Maybe someone who is a junior who doesn't have enough experience may have not noticed. So it's like a double check that we can have to make sure that we properly configured our systems. Okay. Enough with defensive use cases. Let's talk about offense for a few minutes. And these are some of the ideas that I came up with in terms of offensive use cases. Code obfuscation may be useful from time to time, especially when we want to avoid detection, when we want to employ an attack and we want to avoid detection. And ChatGPT provides countless of ways to obfuscate the code, so it can be useful for that. Another interesting use case is to gather a lot of information about a particular target and then feed all that information to ChatGPT and ask the engine to create a password dictionary, a probable or potential password dictionary for attacking, for password attacking that particular target. This can also save a lot of time. I'm going to show you an example of how we can do data manipulation and how can ChatGPT be useful for that. Social engineering, I think this is obvious already, because the main use case for such a language model is to create natural language, to create credible text, credible content. Payload generation, network reconnaissance. If you gather information from the network, if you capture traffic from the network, you can analyze that traffic and you can have ChatGPT identify potential targets, identify points of interest, or I don't know, different anomalies in the traffic that you captured. And it can also be used for reverse engineering purposes, because it can analyze the functionality of a code and it can help you understand and change that functionality, tweak it. So here is an example of data manipulation. Me personally, I've never had any experience working with Swift payments. So I thought about this scenario, like I'm someone employing an attack on a network. So I just came up over a file like this, like the one behind me. I don't know what it is. I suspect it's something important. And I have ChatGPT with me. So I'm feeding this file in the engine and ask for an analysis. And what I get in return is not only it understood that this is a Swift transaction, but it also provides me with a detailed explanation of the fields in the transaction. So that gave me the idea of asking the engine, okay, next step, the logical step, let's see how we can manipulate the data, change the transaction in our benefit. So I'm actually trying to employ a salami technique, like asking the engine to modify the transaction, modify the file, and remove a very small amount of money from that transaction and create another transaction to a different destination. So I'm asking to generate a script to do that. And this is exactly what we get. Sorry, it's a bit slow. This is the actual real-time speed. So now we get the Python script that I've asked for. And this actually works with a bit of tweaking. I was able to make it work pretty fast. So it takes like just a few minutes.
Only a couple of minutes you have left.
Okay, I'll try to make it quick then. So I had another example regarding social engineering, but I think this is too obvious. I'm going to skip this one. I just wanted to, I also had an example regarding SQL injection. This is also, there was actually something interesting here because people who run the tool, this language model, people from OpenAI are actually trying to implement safety measures so that people do not abuse the functionality. Sometimes when you run a query, you might get an error because your query is identified, like in this case, it is identified as something that might be illegal. For example, I'm asking how to do SQL inject. And first time I got rejected, but then if you are persuasive enough, you can actually rephrase the query in such a way that you can trick the engine so you can bypass the protection mechanism. And the problem, one of the problems of large language models is that they can be misused, and it's very difficult to protect against this kind of misuse. And this is probably the topic of another presentation. Some white hat specific use cases, which I think you might be interested in. We all know how much we love writing documentation. Well, ChatGPT can be a very useful assistant, not only to create test documentation, it can also generate realistic test data, and it can be very useful in generating actual reports. As I said, many technical people struggle with communication skills, and it's difficult for them to actually present the findings in a meaningful way to the management so that they don't use a too technical language, but they are still concise. And this is an example of a report generated with ChatGPT. Just a few quick takeaways, and that's it. I just wanted to emphasize that every new technology, it's like a double-edged sword. So in one hand, it can be used for good, but it can also be used for bad. Right now, it's not 100% accurate, but remember, an attacker does not need it to be 100% accurate. Precision is not required. You only have to get it right once in order to succeed with your attack. So it's already very dangerous. And in the future, I see that there will be a huge increase in the number, at least in the number of social engineering attacks. Not only that, but script kiddies rejoice. You know, everybody who has an interest in this and doesn't yet have the knowledge can use such a technology to basically run very sophisticated, in some cases, very sophisticated attacks. And for those of you who might be thinking that you will be replaced by AI, don't worry, it's not going to happen. This is a very nice quote that I found on the internet. You're not going to be replaced by AI, but probably by a person using AI. That's the message I wanted to send today. Thank you very much.
Thank you. So let's move to another speaker. So Wilson Tang, he's an MS graduate in computer science from the University of Washington. He's currently working as a data scientist on the threat hunting team at Adobe. So this talk is also related to machine learning. So machine learning for detecting sensitive documents on SharePoint. The floor is yours.
Hello, I'm Wilson. Give me 1 second to share my screen. Sorry, this is the first time I'm using Zoom, so I need to restart so I can share my screen.
It is still not working, yeah.
Yeah, okay. Give me 1 second. Sorry about that. Okay, I'm back, sharing my screen.
Now it's working, yeah.
Perfect. Yep, sorry about that. That was my first time trying to share the screen and had to quit and reopen. Perfect. Cool. So I'm Wilson, and this presentation is on machine learning for detecting sensitive documents on SharePoint. A brief agenda before I start the presentation. First, I'm going to give a little introduction on myself. Then I'm going to define what sensitive documents are. Then talk about the machine learning models we use to detect sensitive documents. Talk about the automated pipeline we implemented to detect these documents. And finally, talk about some key challenges on our project and future projects we want to tackle relating to this as well. So first, a little introduction on myself. I wanted to let you guys know a little bit about me before I dive into the technical details. So yeah, what better way to do this with a series of pictures? This first picture up here is the picture of a Space Needle, the Space Needle from Seattle, Washington, where I grew up. But recently I moved to San Jose, California, where I'm in the heart of Silicon Valley, currently working at Adobe. This next picture is a picture of cherry blossoms, and this represents where I got my BS/MS degree in computer science from the University of Washington. And there I studied a lot of machine learning, which is this picture of this neural network down here. A lot of my studies were mainly in machine learning. And last year, I recently started going into security and learning a lot of stuff about security, and super excited about doing new applications of machine learning in security. And the next hunting photo is explaining how I'm currently in the threat hunting team at Adobe, where we're detecting new cybersecurity attacks that we aren't currently detecting. And that has been a lot of fun this past year. And finally, these last two pictures represent some of my hobbies. This first one is you see this wok stir frying. I really enjoy cooking. I really enjoy cooking Asian food, particularly, and this final one is represents my hobby of video games. And this icon is like this video game Valorant that I really enjoy, and it's just how I unwind and de-stress. And yeah, that was a little aside from the technical details. Hope that was good. But yeah, that's a little bit about me, and now we go straight into the presentation. Cool, sensitive documents. How do we broadly define them? So how we define sensitive documents here are files that contain any information that shouldn't be shared broadly across the company, most commonly when permissions are set incorrectly on these documents. And to give a little context on why sensitive documents matter to us, this quote really encapsulated it really well. So this is from Dan O'Day from the Unit 42 IR Report 2022. The quantity of stolen data does not directly correlate to the negative impact of its theft. Unauthorized acquisition of a single spreadsheet containing a list of individuals' personally identifiable information, PII, could result in a large data breach, even though the file size itself may be very small. Companies should avoid storing such repositories of sensitive information in unencrypted files and should be cognizant of where this information is located in their environment. And to basically summarize this quote is even though there might be only one document on our SharePoint that's sensitive, if that one file for example, a job offer gets leaked to the public, it could cause a large data breach to the company and cause a lot of legal issues. So we want to keep this very secure and be very mindful of where we keep our documents. And now that we think about this, the question is, how can we detect and respond to all these unrestricted sensitive documents as the scale of cloud documents is constantly increasing? I can assume that a lot of us are keeping our documents on Google Drive, SharePoint, OneDrive. So how do we monitor this? And how we are deciding to answer this at Adobe is through machine learning. To give a little context on how we're trying to approach this problem falls under document classification with machine learning. And to briefly define machine learning, if you are not too familiar with machine learning, this is a very brief definition, but it's a category of artificial intelligence where we leverage lots of data to build a model that can predict on some task. And if you look down here in this little diagram I made very briefly, this is kind of a common accurate / semi-accurate Venn diagram that you see that's popular. Artificial intelligence is this big bubble, and machine learning is a subset of artificial intelligence, and deep learning, which uses neural networks, is another subset of machine learning. And this is some sort of abstraction that you would see a lot on the internet, whatnot. And so our problem falls under document classification, where you assign a document with one or more categories. Some examples would be spam filtering, genre classification, sentiment analysis, and some common techniques people use for document classification would be naive Bayes, expectation maximum, TF-IDF, neural networks. And for our project, we're going to focus on random forest. And I'm going to take one step deeper into sensitive documents, because when we talk about our data in machine learning, it's really important to define our data in an ML task so we know how to approach it. And for our project, we define sensitive documents in two different ways. The first one is sensitive documents where the whole document itself is sensitive in nature. For example, a job offer, tax returns, that whole document should not be on our SharePoint. And the second one is documents with sensitive information. And these are documents that aren't necessarily sensitive in nature, but they contain sensitive information in them. For example, there might be API documentation that should be shared, but for some reason it contains API keys, and that is sensitive information that should be locked down. Or for example, if someone's keeping a personal document, but it somehow contains a social security number on that document, those would fall under this category. And now I'm going to address how we approach each of these categories. Now I'm going to talk about how we approach the first category, the sensitive documents category, where the whole file is sensitive. And this is how we do our machine learning model from start to end like this. So starting from the very top, we have a raw document on Sharepoint. And now how do we convert each raw text document into training data for our models? And the approach we used was this bag of words technique. So you start out with this raw document on the left, and it has like a lot of words in it. And the second part we do is we filter out non-informative words. And this non-informative, informative is a category or criteria that we define on some words that help us differentiate between different sensitive document categories. For example, maybe like the word this and is and is not a great decider on whether this is a job offer or not. But if you see the word job offer, that's a really good indicator if like this is a job offer or not a job offer kind of letter. So that's what we mean when we say we filter out non-informative words. And when you filter it out, the set of words in the document become much smaller. And that really helps us train the data because there's just less words, less noise to deal with when we're training the model. So after you filter out, you get like less words in the document. And then we create a vector with the counts of words after that. So here you see like this, this turned into 1, 2, 2, 1, 1, 0, 0. You can imagine this 1 means that we have like 1 document word. This 2 is like 2 sum words, 2 is 2 informative, and then 1 for job and then 1 for offer. And then you can also imagine like there can be zeros where this document doesn't even contain like some of the informative words that is important for like training the model. And that is what we will refer to as the document like for the next slide when I talk about the actual models that we implement. So this is a very big slide with a lot of diagrams, basically 2 parts. The first, the main model that we use for this project is the random forest classifier. And what it does is that it trains multiple decision trees and averages the decision across all trees. And if you're not familiar with a decision tree, it's kind of basically like an if-else branch statement kind of thing. Like, for example, like you start at the top and then it's like, if this document contains the word job offer, then it's probably a job offer. And then you kind of make these if-else branches until you reach the end. And the strength of this technique is that instead of just having one decision tree, you have multiple decision trees which split on different criteria. And if you average the decision across all trees, then you'll get a better decision on what's made because you have different criteria, and that final number should be more accurate. So basically what you see in this diagram is that you take one document and then you run it through like these 5 individual trees. They'll come out with like different probabilities, different numbers, and then you'll average that number and you'll get this final one right here. And so that's random forest. And the second thing we did on top of that is that we implemented this use of one versus all classifiers, where you train multiple models where each model is specialized at classifying one specific document type. And for each document, you run the text over each model and take the model with the highest confidence. So for example, you take the document and then you run it through 3 different random forest classifiers. So you can imagine this RF model 1 is basically if you expand out these 5 trees down here. And you can imagine like this first random forest model might be really good at like tax returns. The second one's really good at job offers. And this third one is really good at just detecting like non-sensitive documents, so like neutral documents. And you can see they'll come out with 3 different probabilities, and you just take the result with the highest probability, and if 2 is the job offer, then maybe this document is a job offer. And now that was the whole part on just the whole sensitive documents and how we build a machine learning model for the sensitive documents. Now talking about just the documents with sensitive information, and these are the ones that aren't sensitive in nature, but they just have sensitive information, and we implement regex for the detection for this one. Specifically that these were pertaining to secrets, such as like AWS API keys or PII, like social security numbers. And the way we came up with these regex was a combination of open source and internally curated regexes. For example, right here, you can see this is like a very this is just an example of what an AWS API key what regex would look like. And this basically you have a bunch of these, and we use a regex library for us to be able to run through these overall documents and detect if there's any of these living on our SharePoint. Cool. And now this is the, now that we have the model, we talked about the model, this is the whole pipeline that we established and deployed to implement this in real time. So first thing we do is we use the start from the SharePoint API. Particularly, we use the SharePoint Graph API to query files from SharePoint. And then this is we're able to get a bunch of files, or like one or a couple files at a time, depending on like the timing of our jobs. So we get a bunch of files from SharePoint, and then we run it through our model that we just talked about. And the new part here is that if the model classifies a document as sensitive, then what we do is that we immediately alert our users through our user notifier project. And as well, we would store the alerts in our SIEM for future records. And the main part here is that the user notifier in this project, what happens is that they'll send the message, oh, we found a potentially sensitive document on the SharePoint. But the special thing is that we're able to record responses from them. So it'll be like, oh, please click 1 if you're like, if you think if this is sensitive, or 2, this is not sensitive. And what this really enables us to do is to establish a feedback loop, which is really important in machine learning, so that we can constantly keep improving our model and tune our model and retrain our model based on new data, and make our model more accurate with real user input. So where that user response goes, it goes into our SIEM, and the SIEM stores all the user records and our user responses. And then finally, we'll bring those responses back up to the model for retraining. And that is the whole pipeline of how we implemented the model detection. And finally, some key challenges for this project that I want to talk about. And the first one is minimizing false positives. And the reason why we want to really minimize false positives is because we want to ensure in the security domain is because we want to ensure that analysts won't be flooded with alerts. We don't want our analysts feeling like, oh, this is a sent document, but they're really not, mostly not. And we also, for our user notifier, we don't want to alert too many of our users with like a non-sensitive document. So we want to be really confident when we send a message to the user that is actually sensitive. And what we found was that random forests tend to overfit the data, but we take that trade-off here because that means that when the random forest thinks that's it, when the random forest classifies positive, we can be very confident in the positive result. It might have false negatives because it can't generalize as well. But what we found here is that with these like corporate documents, like a job offer, like they're very like pre-formatted, and you won't have to generalize as much because when these documents are in this template format, the random forests still work really well because each document kind of looks about the same anyways. So that's why we chose to use random forest in this. And on our test data set, our current false positive rate is 0.8%, which is under 1%. So that is extremely good for our context. And finally, a reliable feedback loop. It could be difficult in security to label like a malicious benign or like a sensitive non-sent document, and to really get a large like training set of like a lot of like these kind of documents. So getting user responses for training data, like, oh, this is sensitive, this is not sensitive, is super useful. And our user notifier project is what really automates recording responses from these users and allows us to grow our training data with this reliable feedback loop. And finally, some future projects that we want to do in this domain. We want to implement more sophisticated ML models, such as like BERT models would be really cool to see because this is an NLP project. We want to expand document categories, like think about what other sense documents might be living on our SharePoint and expand what we're currently detecting. And also it'll be really cool to scan other cloud storages such as AWS S3 buckets, which I'm currently doing, but then also extending it to Azure storage blobs. These ones might be more lean towards like secrets instead of like maybe a job offer, but jobs could still live there too. But yeah, just these ones would be like looking at a lot of secrets. And yeah, that was basic. That was the end of my presentation. Oh, one more thing, sorry. I want to give credit where credit is due on this project. So not just me on this project, but also Tiberius Boris, which he is on this call right now as well. Andre Stan and also Joseph Davidson. I wouldn't be able to do this project without them. I started less than a year ago and they've helped me guide through leading this project with them. Cool, and with that, I would like to open it to Q&A if there are any.
Any questions from the participants? Otherwise, Wilson just gave the contact, so you can freely contact him or his team for any questions. No questions right now. Thank you, Wilson, for your cooperation. I think we can start with the last talk, even if there are a few minutes earlier, so nobody will object if we finish earlier. So I welcome Kumar Vikramjit. Are you here? Kumar?
Yeah, hi. Can you hear me?
Hello. Yes, yeah.
Okay.
So Kumar is a security engineer specializing in machine learning and statistics based on security engineering and threat hunting. Currently, he's working for Adobe's security coordination team, and his talk is also related to machine learning, so fast-track incident detection with WEBA user and entity behavior analytics. Kumar, the floor is yours.
Thank you. Let me share my screen. Is my screen visible?
Not yet. Aha, now it is, yeah.
Okay, thank you. So let me get started. Okay, so hello everyone. I'm Kumar Vikramjit, and we are part of Adobe threat hunting team, and these are our team members. So our skill varies across various domains. So our core skill is threat hunting, but we also do security engineering, machine learning, and data science. So the last presenter is also in our team, as you can see here. So this presentation is about UABA and how you can use it to improve your incident detection and fast track it. So the major problem that we are tackling is information overload. So that's the problem in all spheres of our life. And we are usually fed up with a lot of information. And whenever we get a break with the huge amount of information, we feel relieved. So that's also happening in security, where we have a lot of vendors producing a lot of logs that we need to process. And getting a lot of logs and data doesn't really improves our decision quality in every time. So it's possible that after a certain limit, the more information you are adding, it might just be affecting your decision quality in a worse way. So because the new information that you're getting, it's possible that is not adding any new context to the decision that you are doing, or it might be just inaccurate information. So you just need to limit the information that you're getting sometimes. So in SIEM, we get logs from different applications and different security tools. Now there is a plethora of tools to go around, and all of those logs, they just come into SIEM. So to tackle that, you can use something like UABA, where we filter the logs as per the incidents or security compromise that you're interested in. It can also cover a wide range of cyber attacks that might involve phishing or ransomware attack or any zero-day vulnerability. It will also generate accurate alerts in automated fashion. So usually you get a number of alerts from SIEM, which or any security vendor, which you might not be interested in. As they are just looking in their use case, they are generating alerts as per the tool, that is being set up. But you want to have a holistic view. So that will, if you use all the alerts together, you might be able to correlate, and that will lead you to generate more accurate results. And it will also lead you to generate timely detections. So when an incident happens, the delay in investigation really matters. So if you give the attacker or intruder more time, they might be able to gain hold of more systems, and they might be able to leak more of your assets or compromise more of your clients. So that's a major issue. So timely detection is also very important. So what is UABA? So UABA stands for User and Entity Behavior Analytics. It's an information security implementation to detect anomalous events by employing machine learning and data statistics. So by anomalous events, we mean abrupt change in behavior or activity of the user and entity. And just to give more context about entity can be an IT process or asset, or it can be certain devices that you might own. UABA also helps in data churning and reduction of data by using ML and DS approach. Here you do use case coverage for conditional detection of a particular kind of anomalies or alerts that you're interested in. So right now there are many commercial tools that are available in market that some organizations might feel like installing or deploying in their corporate network. So there are various issues when you deal with a very big organization. So these tools, they don't usually support a wide variety of logs. And whenever you onboard a new kind of platform or a new set of logs, you might face issues in onboarding those kind of logs to your UABA. So these external vendors, they also have certain trade secrets, and that is basically a black box implementation. So you'll see certain alerts, and you will not know how they are getting alerted. And it's possible that for your case, these are just operational events, and these are just clogging the alerts queue for you, and people are getting bogged down. The SOC analysts are getting bogged down. So that's also an issue. And if you have any feature request and bug fixes, it might take months, or it's also possible that they will never get around it and you'll have to live with that bug. It's also expensive. So you'll have a recurring cost that you'll have to pay. And you'll also have to hire a knowledge expert, which will look into your organization and try to set sensors and try to find appropriate detection for you. So that also has some additional cost. So we choose to develop our own UABA implementation that is designed to fit our security ecosystem. So we have implemented a very open implementation that interface with existing SIEM and EDR platforms. And the use cases that we tackle are designed by our security analyst as per the threat model that we are interested in, and whatever is priority for us. Whenever we have to onboard new logs or event, the process is well defined. So it doesn't take a very long time to get around that. You can also have successive improvements in iterations as per your priority, and fixing bugs and feature updates. They also have a low barrier, and you can get it fixed as per the priority or whatever is critical for you. So now we'll look into UABA in a nutshell, and what are the various components inside UABA. So the first one is use cases. So here you define certain detection strategy that you're interested in. And this is the first stage where data reduction also happens. Next is data. So for use case coverage, you have to filter out certain data, and that's help you in getting selective data out of scene that might not be a huge computation overload for you. Next stage is analytics. Here you implement the use cases by using ML or DS approach, whatever fits for your use case. And at the end, you get the anomalies out of this. And next stage is correlation. So once you have a set of anomalies coming for different use cases, you might want to cluster them to get a big picture. So once you cluster it, you might see that there are certain users or entity generating a lot of anomalies, and this seems to be linked together quite nicely. It might help you in identifying certain compromises or intruder within your organization or network. So the next stage is enrichment. In this stage, we add more data and context to the anomalies, and it can aid filtering false positives. And the final stage is detection. Here you score and prioritize the clusters of anomalies that you created. And once you score and prioritize them, you can send it to SOC for review. So now we'll look into all those use cases in much more detail. So there are 5 basic use case category that we came up with. So these are network, application, cloud, host, and authentication. So use cases are meant to capture events that indicate particular suspicious and malicious activities at a certain threat level. So you can define as per whatever is priority for you. So for example, there is assume that you have a company that operates mainly on cloud, and you are mainly concerned with cloud threats, right? So your use cases will cover mostly the cloud threats. So that's completely fine. So for some company, there might be just 3 kinds of log types. For some company, there might be 10. So it completely depends on what kind of infrastructure and assets that company owns. And at the bottom, I listed some examples of use cases. So in cloud, there can be a use case where an entity is attempting to retrieve credentials of many Windows EC2 instances. And this should raise a red flag for the SOC team. So this can be one use case. Another use case is application one, where you see a very high data download from an external IP. And this should also raise a red flag. Going next to data. So just like use cases, you will have 5 sections of data. As I listed here, those are network, application, cloud, host, and authentication. And there'll be different kinds of logs which are flowing on those 5 categories, right? So for network, we have firewall, DNS. For application, Salesforce or any other application that you might have. In cloud, we have 3 major players: Azure, AWS, GCP. And host can include EDR logs. And in authentication, you can have AD or second factor logs and any authentication related logs. So in this stage, our main focus is to minimize the data and clean up the data and give a uniform data structure to the data so that you can prepare the data for correlation at a later stage. But assume that your data is not well refined and it doesn't has a uniform data structure, then it might become very hard to correlate it at a later stage. And there is a thing called pipeline. So pipelines are execution set, which includes a number of execution tasks, which you can where you can handle one or more use cases. So here you can, for cloud, you can have one use case or like say 100 use cases. Similarly, for host, you'll have many use cases. So you can include these use cases in a pipeline. And at a certain point, you might realize that you can handle 3 different use cases together because they deal with the same kind of data. So you might include all these use cases in a one single pipeline. Sorry. So next stage is analytics. So here we do anomaly detection. So depending upon the complexity of the use cases and data availability, you might choose machine learning or data statistical approach to get the anomalies that you're interested in. So it's not necessary to apply machine learning every time. If your data is too good and it will just indicate something malicious going on, just like that, then you might be just fine using a statistical approach. So machine learning, they add some computation limitation there. So you have to rely whatever fits for you. And after this, when you get the anomalies, you might want to do some additional filtering to capture highly anomalous or suspicious events, because it's possible that your anomalies are still of a very high count. So you might want to reduce them. So for example, assume that you have an external server where you are providing content to your clients, and you're getting a lot of bad traffic or malicious traffic from Tor IPs. And you want to look at those particular IPs in general, and you have a use case defined for that. So you might want to get the Tor IPs from some knowledge base or some threat intelligence platform, and then you might just want to filter them out first. So you can have a logic like that built up here, where you will filter out only the anomalies that you are interested in. We also have built one tool called OSAS, that stands for One Stop Anomaly Shop, and that's the link for that. So it's an open source project that we have developed in past years, and it can help you detecting anomalous events as per predefined threshold. It includes supervised and unsupervised machine learning algorithms, and it will generate labels as per predefined configurations. So this is a very useful tool, and we have been using this a lot. This tool was also mentioned in some of the security blogs that you can just go here and. So the next stage is correlation. So once you have a bunch of anomalies, you might want to get a bigger picture, and that will help you understand if there is any compromise happening within your network, or if it is just operational. So for a user, there might be anomaly for authentication log type, where you're seeing abnormal log. In cloud, you might see some external accesses coming from a Tor IP. In application, you might see a data dump activity happening, and you might also see unusual pattern. So when you club all these activities happening within a short span of time, say within 1 or 2 days, you might see a sequence of activities happening, and once you investigate it, you might realize that it looks like there is an intruder in the network, and you might want to get it investigated. So in that situation, this correlation stage really help you to gain a bigger picture. And when you create a cluster of this kind, the user entity will identify that cluster, and you can use that cluster ID to have more anomalies in that cluster. So next stage is enrichment. So here you want to enrich the anomalies that you generated, as I discussed before. So for a user or entity, we are basically dealing with 2 kinds of data, that is dynamic or static in nature. So dynamic data is activities or anomalies that is generated. Static data deals with identity, relationship, and ownership of that particular user or entity. So some examples can be user accounts or assets that are owned by that user. It can also contain data like which user team the user belongs and what roles that user have, what privileges they own. So by using this data, you can also do conditional filtering that might be useful at a later stage. So the final stage is detection. In this stage, we do user identity scoring, and we look at various factors when we do scoring calculation. So those are anomaly severity, anomaly age, and pipeline log types. So anomaly severity comes from the pipeline, and it is dependent upon the use cases. So for some use case, you might have different conditions which will define whether this alert is high severity category or medium severity category or low severity category. And next factor is anomaly age. So you might be more concerned about the anomaly happening within few hours than say a past week. So that also adds to the user identity score. And the final one is pipeline log types. So assume that there is a lot of anomalies coming for a user from one pipeline log type, and there is another user for which we are seeing anomalies from 3 or 4 pipeline log types, right? So in that case, that might be a more severe case for you because you are seeing activities from different kind of applications and assets that you own, and that might be more urgent for you to look into. And once you have the clusters scored, you can present it in a security analytics dashboard that might be reviewed by SOC. So finally, I want to discuss how you can build up your own UABA project. So this is a very general diagram. So here we have a UABA node, which will execute the pipelines. And the pipeline will comprise of data fetch, anomaly detection, and you can just execute it in regular intervals. So that node will have integration with SIEM platform and code platform and the DB platform. So for implementing this whole infrastructure, you might rely on CI/CD platforms like Jenkins, Circle-CI, or Databricks. Databricks here is sort of a different platform that basically deals with machine learning processes, but it can be used here. And you can run your machine learning model to understand the data better. SIEM acts as the primary data source here. You get all the data as per the use cases you are interested in. And in DB, you store the use cases data set that is generated, and all the detected anomalies also goes here. So that's it for me. And these are the Adobe resources where you can go and check out other security projects that Adobe is working on and get in touch with us. So that's it for me. Thanks for having me. And please let me know if you have any questions.
Thank you, Kumar. Any questions from the public? No questions? So maybe Christina, will you wrap up the conference?
Yes, of course. First of all, I would like to thank you to all the speakers who joined us today for all the interesting presentations. And thank you also, Andrei, to you to connect the program in the afternoon. It was great to have you all here online, and looking forward, of course, to the next opportunity to meet. So enjoy your weekend and have fun.